This course was created in response to a real problem I've seen again and again. Thousands of people are learning AI, machine learning, and deep learning, but only a small fraction are actually landing AI engineer roles. The gap isn't intelligence or effort. The gap is clarity. Most learners don't understand what companies truly expect, how AI engineering has evolved, or how to prepare in a structured way. This course is designed to give you that clarity. It's not just about learning AI concepts. It's about building the skills, systems, projects, and confidence needed to succeed as an AI engineer in 2026. Welcome to How to Land an AI Engineer Job in 2026. AI engineering is one of the fastest growing and most competitive roles in tech today. At the same time, it's one of the most misunderstood. Many people believe that learning a few algorithms or frameworks is enough. In reality, companies expect much more. This course is designed to help you understand what it actually takes to succeed as an AI engineer in today's job market. We'll focus not only on technical skills, but also on how those skills are applied in real-world systems. From day one, you'll be learning with a clear outcome in mind, becoming job-ready and interview-confident. Most AI learners don't struggle because they're not capable. They struggle because their learning path is fragmented. Many people jump from topic to topic. Some Python here, some machine learning there, maybe a deep learning course, without understanding how everything fits together. Others focus heavily on theory, but never build real systems. Some even build projects, but don't know how to present or explain them in interviews. This leads to weak portfolios, low interview confidence, and missed opportunities. Companies aren't looking for scattered knowledge. They're looking for engineers who can reason, build, and deliver. This course was designed specifically to address those gaps. AI engineer hiring today looks very different from just a few years ago. In the past, being able to train a model in a notebook was often enough. Today, that's only the starting point. Companies now expect AI engineers to think in terms of systems, how data flows, how models are deployed, how outputs are evaluated, and how failures are handled. Interviews increasingly focus on reasoning, trade-offs, and system design rather than memorization. You're expected to explain why you made certain choices, not just what you built. Understanding this shift is critical. This course is built entirely around modern hiring expectations, not outdated ones. In 2026, companies expect AI engineers to be strong engineers first, and model users second. That means solid Python skills, a deep understanding of machine learning fundamentals, and the ability to work with modern AI systems. It also means being comfortable with deployment, monitoring, evaluation, and iteration. Beyond technical skills, communication matters. Hiring managers want engineers who can clearly explain their thinking, justify design decisions, and collaborate effectively with teams. This course is designed to help you develop all of these capabilities, not in isolation, but as part of a complete AI engineering skill set that aligns with real-world expectations. By the end of this course, you'll have much more than theoretical knowledge. You have hands-on experience building AI systems from the ground up. You'll understand how different components, data, models, infrastructure, and evaluation fit together. You'll also have a portfolio of projects that demonstrate real engineering ability, not just coursework completion. Equally important, you'll gain confidence. Confidence in interviews, confidence in explaining your work, and confidence in knowing that you meet the bar for AI engineer roles in 2026. The goal isn't just learning. The goal is transformation, from learner to job-ready AI engineer. This course follows a carefully structured path designed to build skills progressively. We start with strong foundations, Python, data science, mathematics, and machine learning, because every great AI engineer relies on these daily. From there, we move into deep learning, transformers, and modern AI architectures. Later sections focus on Gen AI, agentic systems, and production AI engineering. Finally, we shift toward career preparation, including portfolios, interviews, and public projects, and job strategy. Each phase builds on the previous one. This structure ensures that by the time you reach advanced topics, you truly understand what you're building and why. This course is designed for anyone serious about becoming an AI engineer in 2026. That includes students preparing for their first role, software engineers transitioning into AI, data scientists aiming for engineering positions, and career switchers entering the field. You don't need to be an expert on day one, but you do need commitment. What matters most is your willingness to learn deeply, build real projects, and think like an engineer. If your goal is to move beyond tutorials and toward real world AI engineering roles, this course is built for you. To get the most value from this course, treat it like real engineering work. Follow the sequence and don't rush ahead without understanding the fundamentals. Build every project seriously, even when it feels challenging. Focus on understanding why things work, not just how to make them run. Take notes, revisit concepts, and reflect on how each topic connects to real-world AI systems. Most importantly, adopt an engineering mindset. This course isn't about passing quizzes. It's about preparing you to solve real problems as an AI engineer. Now that you understand the purpose and structure of this course, we're ready to begin. In the next lecture, we'll walk through the essential AI concepts you need to understand before diving deeper. This will give you a high-level mental map of the field and help you see how everything fits together. From there, we'll move quickly into hands-on learning, starting with Python and engineering fundamentals. Step by step, you'll begin building toward the skills and confidence required to land an AI engineer job in 2026. What exactly is Claudebot? At its core, Claudebot is an open-source, self-hosted AI assistant. That means it runs on your machine or server, not locked inside someone else's cloud. You can connect it to powerful language models like Claude or GPT, but the agent itself lives with you. It has persistence, it has memory, and understanding. What makes it especially interesting is how you interact with it. You don't need a fancy dashboard. You can talk to it through tools you already use: WhatsApp, Telegram, Slack, Signal, even iMessage. So instead of opening 10 apps to get things done, you message your AI agent and it handles the work. This is less like ChatGPT and more like having a personal AI operator that's always on. Now let's talk about what Claudebot can actually do. First, it's persistent. This agent doesn't disappear when the chat ends. It keeps running in the background, waiting for instructions. Second, it can execute actions, not just generate text, but run shell commands, manage files, browse the web, trigger scripts, and integrate with external tools. Third, it has memory. It can remember preferences, ongoing tasks, and long-term context, so you don't have to re-explain yourself every time. And finally, it acts as a coordinator. It takes your message, routes it to an LLM for reasoning, then decides which tools to use to complete the task. This is the key shift. AI is no longer just responding, it's operating. Let me walk you through how this works in practice. You send a message, something simple like, summarize today's emails and schedule follow-ups. That message goes to Claudebot. The agent sends it to an LLM to reason about what you're asking. The model doesn't just respond with text. It produces intent. What actions should happen? Claudebot then executes those actions. It might read emails, extract key points, update a calendar, and send confirmations. Finally, it reports back to you, right there in chat. So the loop is human intent, AI reasoning, real-world action, feedback. That's the missing bridge we've been waiting for. This is how AI stops being passive and starts being useful. Once you understand that loop, the use cases become obvious and honestly, a little mind-bending. Claude can clean up your inbox, unsubscribe from spam, and draft replies automatically. It can give you a daily briefing every morning, news, calendar, tasks, without you asking. It can run scripts, schedule cron jobs, manage files, and automate repetitive workflows. It can help plan trips, manage calendars, integrate with Notion, Spotify, or internal tools. And all of this happens through simple messages. You're not learning a new UI. You're not clicking through dashboards. You're just delegating. This feels less like software and more like having a junior ops engineer or executive assistant on standby. Under the hood, Claude is surprisingly clean and modular. At the center is the gateway process. This is the always-on daemon that listens for incoming messages. Next is the LLM backend. You can plug in models like Claude or GPT for reasoning without locking yourself into a single vendor. Then come the executors. These are the tools: shell access, file operations, web access, APIs, plugins. This is where actions happen. Finally, there's the memory layer, usually local files or stores that retain context and preferences. The beauty here is separation of concerns. Reasoning lives in the model. Execution lives in the agent. Control stays with you. That's a powerful architecture, and a very intentional one. So, how is this different from ChatGPT, Siri, or Alexa? First, location. Claude runs locally or on your infrastructure. Your data stays with you. Second, persistence. This agent doesn't reset every session. It remembers. It learns patterns. Third, execution. Siri might tell you how to do something. Claude just does it. And finally, customization. You decide what tools it has access to, what it's allowed to do, and how autonomous it should be. This isn't a consumer assistant optimized for small talk. This is an operator-grade AI agent, closer to DevOps than voice assistants. This is where things get interesting. Claude represents a shift from apps to agents. Instead of installing software for every task, you have an AI that orchestrates tools for you. It also changes the privacy equation. Because it's self-hosted, sensitive data doesn't have to leave your environment. But the biggest change is conceptual. We're moving from AI as a feature to AI as infrastructure. Once you experience AI that can observe, reason, and act continuously, there's no going back. Now, to be clear, this power comes with responsibility. An agent that can run commands and access data is also a security risk if misconfigured. API keys, credentials, and permissions need to be handled carefully. There's also a learning curve. This isn't plug-and-play consumer software yet. You need some technical comfort. And governance matters. You must define boundaries, what the agent can do autonomously, and when humans need to stay in the loop. So this isn't about blind automation. It's about controlled autonomy. Looking ahead, this is where the industry is going. AI agents won't live inside apps. Apps will become tools used by agents. Your calendar, email, CRM, cloud infra, all orchestrated by intelligent systems that understand goals, not buttons. Claude is an early glimpse of that future. Not perfect, not finished, but directionally very clear. This is how AI moves from novelty to necessity. So let's wrap this up. Claudebot or Moltbot is an open source, self-hosted AI agent. It connects conversational interfaces to real execution. It brings persistence, memory, and action into AI systems. And most importantly, it represents a new mental model. AI as an operator, not a chatbot. We're not just teaching machines to talk anymore. We're teaching them to work. And that changes everything.
Welcome to Week 1, Python Programming Basics. Our Day 1, we will cover Introduction to Python and Development Setup. Day 2, we'll be looking at some control flow in Python. Day 3, we'll be looking at functions and modules. Day 4 will cover data structures, which will encompass lists, tuples, dictionaries, and sets. Day 5 will be looking at working with strings. Day 6 will be file handling, followed by day 7, we'll be looking at Pythonic code and project work. So let's get started with week 1. Day 1, Introduction to Python and Development Setup. Let's jump into overview of Python and its role in AI. Now, why Python for AI? Python has become the go-to language for AI due to its simplicity, readability, extensive libraries, and supportive community. Libraries like NumPy, Pandas, TensorFlow, PyTorch, and scikit-learn make Python ideal for machine learning and data analysis. Now let's look at some of the applications of Python in AI. Python is widely used in various AI applications such as machine learning. Libraries like scikit-learn enable building and deploying ML models. We have deep learning, where we have TensorFlow and PyTorch, which power neural networks and deep learning architectures. In data science and analytics, libraries like Pandas and Matplotlib allow data manipulation and visualization. We also have natural language processing or NLP. We have NLTK, Spacey, and transformers, which are the key for language related tasks, and automation and scripting. Python's simplicity and flexibility make it perfect for automating repetitive tasks. Next, let's jump into installing Python and setting up a coding environment. Here, first, we'll be installing Python. We'll be visiting python.org and download the latest version of Python for Mac. And then we're going to do the similar thing in Windows. We're going to ensure that you check your options to add Python to path during installation if you don't have it. But in my case, I will have directly set up available. But if you have any issues, let me know. And then we're going to go to setting up a coding environment. We'll install Jupyter Notebooks, which is a popular tool for interactive coding, ideal for data exploration and visualization. We'll be installing that by running pip install Jupyter in the terminal. Now we're going to do that in Mac, but on Windows, it's the exact same command. And then we will start the Jupyter Notebook by running the Jupyter Notebook in the terminal to open the notebook interface. Next, we're going to go ahead and install Visual Studio Code. We'll be downloading it and installing this from code.visualstudio.com. And then we're going to install some Python extension, which in VS Code is used for syntax highlighting, autocomplete, and debugging. We'll be doing configuration of Python interpreter, where we set the interpreter to the installed Python version for easy script execution. So let's go ahead and install Python and set up our coding environment. So first step is to install Python. So I'm going to go here into python.org, go into downloads, and in here I can download Python 3.13.0. If you want to download Python for Windows, you go here and you download. But there's another way that I'm going to walk you over. So I'm going to, for Mac, I'll go ahead and download Python. It's going to take a few minutes. So I'm going to go to Visual Studio Code, which is code.visualstudio.com, and download my Visual Studio from here. You can do the same thing for Windows and download for Windows. And now it's downloading my Visual Studio. I can open my downloads folder. And as you can see, Python is already downloaded. So I'm going to click on that and walk through this process. Continue, continue, agree, install, put my password in. And it's going to take some time. At the same time, I'm also going to run Visual Studio. And it installed my Visual Studio here. I'm going to bring that and put it on my dock and open Visual Studio Code. And say open, close all these tabs that are open. And first, let's go ahead and see our Python installation. And it says Python 3.13 for Mac OS or later was successfully installed. I'm going to close this and move this installer to trash. Now to check if I have my Python installed, I'm going to open my terminal and say Python, and it should give me an option to write Python script. I'm going to say print hello world, and it prints it out. So that's perfect. So that means I have Python installed. I'm going to do the same step now in Windows. So in Windows, first I'm going to click on the Windows icon and then open command prompt by pressing CMD. Here I'm going to check for Python. If Python is not installed, it's going to take me to Microsoft Store and it will give me an option to download Python here. So I'm going to go ahead and press download, and it's downloading right now. It's not going to take much time to download Python in Windows directly from here. So I'm going to give it a few seconds. This is almost done and installed. So I have it downloaded. I'm going to press launch, and this will launch another terminal which I will open here, and you see my Python prompt is available here. I can type print hello world, something that I did in Mac similar to that, and it will print out hello world for me. I can do the same thing in my other terminal where I can write Python and it will give me the Python prompt. So if you're opening something new, you can directly use the Python prompt from your command prompt, and it will let you type your Python code. So I'm going to type quit, or it's actually quit with brackets. I'm going to do that, and you can quit out of Python. Now that we have installed in our Mac and Windows Python, so next step is to get the Jupyter Notebooks, which is a popular tool for interactive coding, ideal for data exploration and visualization. So I'm going to say pip install Jupyter. And it's the same command for Windows too, if you're installing on Windows. It's going to take a couple of seconds or minutes. And once it's done, it's going to tell me that it's installed all the packages. So I'm going to give it a couple of seconds. And there you go, it's installed. So now I'm going to clear this out and say Jupyter Notebook. And it's going to run my Jupyter Notebook right here on my browser. And here I can go and create a new notebook here. I'm going to say Python 3. And here is my Jupyter Notebook. I can just say print hello world and run it, and you'll see hello world being printed. I can fix this by saying this and run it again, and it will print it out. So I have my Jupyter Notebook installed. If you had any issues or problems, let me know. Now let's go back to our Visual Studio editor. So we have our Visual Studio editor installed. First thing that you would want to see is go into extensions and look for Python. So I can just say Python, and it will show me my Python, and it says this is already been installed, but you need to restart this extension. So I'm going to restart this. If you're first time coming here, you'll probably see an install option, and just install it from there, and you will have this plugin added to your Visual Studio Code. Next thing that we want to do is set the interpreter to the installed Python version for easy script execution. So for that, I'll make sure my Python extension pack is also installed. And once that is done, you have your Python installed, and you've also set up your coding environment. You can start with running our first projects, which we'll cover in a short while. Introduction to basic Python syntax, variables, and data types. Here, we will look at some of the basic syntax, like how to use comments, where we will be using a hash or a pound key for single line comments and triple quotes for multi-line comments. We'll be looking at indentation. Python uses indentation to define code blocks, unlike other languages that uses braces. Also, we'll look at variables. Variables are dynamically typed, so there's no need to declare types explicitly. We'll look at variables which are defined by assigning values. Example, we'll create a simple variable and assign it some values. And then we'll look at different types of data types. We have integers, which are whole numbers like 1, 42, -3. We have float, which is decimal numbers like 3.14, 2.7. It can be negative, like -1.5. We have strings, which is text enclosed in single or double quotes. And then we're going to talk about lists, which are ordered mutable collection of items. Example, you can have inside square bracket 1, 2, and 3. You can also have strings inside it. Then you're going to look at tuples, which are ordered immutable collections, which we'll look in our examples, how they are different from list. Then we're going to look at dictionaries, which are key value pairs. And then finally, we'll look at some booleans, which are true or false values used in logical operations. So let's go ahead and look at examples of using variables and data types in our code. I have my Visual Studio Code editor available. I'm going to go ahead and say new file. Here we are going to look at different Python variables and data types. So I'm going to say I want to select a Python file. So I have my Python file created. Here first, let's look at integers and floats. Now my font is very small. I'm going to increase it just so it's much more clear. So integers and floats. Now if I want to create an integer, I'm going to create an integer age and give it a value 25. I want to give height as 5.9. Now first one is an integer because it's a whole number, and the second one, height, is a float because it is a decimal point number. Next, we looked at strings. So let's say strings. For strings, what I'm going to do is I am going to use a variable called as name and provide it Alice. Now every time you provide something inside double quotes, that's what creates a string out of it. I can also create a concatenation string variable. I can say greeting equal to hello and pass that previous variable from above here saying hello name. That's how you can create strings with concatenating each other. So this greeting variable will have hello Alice in there. Next, let's look at list and tuple. So I'm going to create list and tuple here. Numbers variable which will have 1, 2, 3, and 4. These are the four numbers that I'm going to put inside this particular list. So this is how you define a list. Now this can be numbers and it can also be names array where you can have Alice and Jack inside it, something like this. Now let's look at tuples. So for that, I'm going to create a variable called as coordinates, and to this I will use the rounded bracket and say 10, 20. So this is the tuple which has two values inside it with inside rounded bracket. So that's how we can say it's a tuple. Now let's create a dictionary, which is I mentioned is a key value pair. So dictionary looks something like this, where I say persons equal to where name is Alice and age is 25. So here I'm saying there's a person whose name is Alice key and this is value, and next key is age and the value is 25. And finally, let's look at booleans. Is underscore student equal to true. So this is how you can create booleans. We can give true or false. These are the different values that boolean variables can have, and we'll be using all these quite a lot in our projects. So let's jump into the next topic, which is hands-on exercises. Next is our hands-on exercise. For our first exercise, we'll be writing a Python script to print a message. So let's get started. So our objective here is to create a simple script that outputs text. So first, I'm going to open my Visual Studio Code. You can do this in Jupyter Notebook too, but I would use this for now. Create a Python file. I'm going to create a folder on my desktop, call it AI Bootcamp, and I'm going to save it inside here. So I'm going to save this. I'll say, where do I want to save? Desktop. Inside my AI Bootcamp, I am going to call it Day 1 Exercise 1. And here I'll write the code print hello, AI world. That's about it. So now I'm going to run the script. To run the script, I'm going to open my terminal or command prompt, depending on which machine you are. And you can just go to desktop, in my case, wherever the file is saved, which is AI bootcamp, and I see this file here. I'm going to say Python day1 underscore exercise py. That's what runs the code, and it says hello AI world. Whatever I've written here will be displayed here. So if you got this working, great. If not, let me know. So now that you've completed exercise 1, let's jump into exercise 2, where we will practice creating and manipulating variables of different data types. The objective for our exercise 2 is getting comfortable with variables, data types, and operations in Python. So first, here what we'll do is we'll define variables for an integer, float, string, list, tuple, dictionary, and boolean. So everything that we learned. We'll experiment with basic operations such as concatenating strings. We'll look at adding items to list and accessing dictionary values. So for that, I am going to create another file, Python file. I'm going to save it as day1 exercise2.py. And here, first I will define variables of different data types. So whatever we picked up today. So I'm going to say integer underscore variable. That's the name that I'm giving it. And I'm going to assign it value 10. Okay, there you go. Next, I'm going to say float variable. I'm going to give it value 3.14. Next, I'm going to say string underscore var. And for that, I am going to call it AI. Next, I'll have a list, which is list underscore variable. And here, I'm going to put values 1, 2, and 3. Next, I'll create a tuple underscore var. And to it, I'll put values 4, 5, and 6. Next, dictionary variable. I am going to call it, inside this, I'll have a person with name of Alice, and role of this person is an engineer. And then I'm going to create a boolean variable and set it initially to true. Next, now let's print and manipulate the variables. So I am going to say print and manipulate variables. So first step is printing our integer variable. So I'm going to say integer, comma, pass integer variable. So this will print my integer variable. Next, I'm going to say print float, comma, float variable. Next, I am going to say print. This time I want to display string. So I'm going to say oops, string, and to this string I'll say string variable. Also, I am going to say add bootcamp at the end of it. So I am concatenating here. So it will say whatever the value of string is, which is AI, and then bootcamp at the end of it. Next, I have my list. So to the list variable, I want to add one more item to it before I even print it. So I'm going to say append and add the item 4. So we have 1, 2, 3 in the list, and I want to append another object here called as 4, the number 4. Now if I print this and I call it list, comma, list variable, and see what it displays outside. Next, I want to display the display the tuple. So I'm going to say tuple, comma, tuple variable. Next, we have dictionary. So I am going to say print dictionary value, and here I'm going to say dictionary variable. Now I don't want everything inside it. I just want to display the name. So I can just specify the key. If I don't do specify this, it will show me the entire dictionary, but I just want to see the name. So I can do that. Next, I'm going to say print me boolean. To this, I am going to say bool variable. So let's go ahead and run it on our command prompt here. So I am in the folder. I want to run this one. So I'm going to say Python day1 underscore exercise 2.py. And as you can see, it will display me integer 10, float 3.14, print string AI, and then I concatenated bootcamp, and that's why it's there. My list, which was 1 to 3, got appended by 4. That's why I see 4 items here. My tuple has 4, 5, 6. My dictionary value, which is I was specified for name, and it gave me only Alice. If I say role here, it will give me the role as engineer. Similarly, Boolean, I displayed it out as true. So if you have this same output, that's great. If not, let me know. So just to summarize, on day one, we set up our development environment. We understood Python's role in AI and gained familiarity with basic Python syntax, variables, and data types. The hands-on exercise helped us apply what we have learned, setting a strong foundation for upcoming modules. Whatever we did today prepared us with practical coding skills as well as fundamental understanding of Python and AI development. Let me know if you had any issues or questions, and I'll address them promptly. Welcome back. Today, on day 2, we will be covering control flow in Python. Control flow is pretty important, so let's get started initially with conditional statements. Conditional statements allow a program to execute specific blocks of code based on the conditions. Let's look at a syntax of what all different things are available in the conditional block. First, we have if, which executes code if a condition is true. We have else if, adds additional conditions after the initial if. And then finally, we have else, which executes code if none of the previous conditions are met. Let's look at a couple of examples for doing this. So I'm going to open my Visual Studio Code. I'm going to create a new file, call it Python file. I'll save it on my desktop AI Bootcamp. I create a new folder, or inside week 1, I'll create a new folder since it's day 2 inside our week 1. And here I am going to save this as day 2 underscore 1.py. And here, let's start with an example. Let's call it example 1, where we are checking a particular condition using control flow. So I'm going to create a number variable and give it a value of 10. Next, I'm going to check if number is greater than 0, which is true in our case. It will say or print positive number. Now, this is a conditional statement where it will check if a variable is greater than 0, which is in this case is, so it's going to print this. But what if I want to check for multiple conditions? So I'm going to say else if number equal to 0. So let's say if the number is 0, then I want to just say print 0. And finally, I'll also add an else, which means if it's not greater than 0 and not equal to 0, then which means it's less than 0, which means it's a negative number. So I'm going to say print negative number. Okay, so there you go. So it's either positive or 0 or a negative number. That's what I'm doing here. I can save this. I'm going to go to my command prompt and see that I am in week 1. I'll move to day 2, clear this. So I have my day 2 underscore 1. I'm going to run this Python day 2 underscore 1py, and it says positive number. If I change this number to 0, run this again, it will say 0. If I change it to minus, let's say 50, run this, it'll say negative number. So what happens is every time it looks at the number, and depending on which one of these are true, it will print that particular value. Either if it's greater than 0, which is 50, will print positive. If it's 0, it will print 0. And finally, if the number is negative something, which is less than 0, it will print negative number. So let's do another example for this, just to get clarity on this. I'm going to call it example 2, and this one I'll call it nested conditions. So in this case, what I'm going to do is I'm going to set a variable called as age and set it to 25, and I'm going to check if age is greater than 18 and Then I'll put a couple of more conditions in there. I'm going to say if age is less than 30, which means the age is in between 19 and less than 30 to 29. So I'm going to say this person is a young adult. And if it's not, else I am going to say print adult. Save this. I'm going to comment this out by putting the hashtag over there. Clear this out. Run this code again. It says young adult because the age is 25. But what if the age is 32? Run this again and it says it's adult. So what it does is it checks, first of all, is this person an adult? And I will check if that person is less than 30, then it's young adult, which means the age is in between 19, it's between 18 and 30, so it's 19, 20 up till 29. If it's greater than 29, if it's 30 or above, it will say print adult. But what if it's 5? It's not even going to run into this. So if, let's say if the age is 3, I run this, nothing is printed because it will not even go inside this particular nested conditional statement. So that kind of wraps up our control flow in Python. Let's look at the next thing that we have to do. Next, we have loops. Now, there are different types of loops. We will start with for loop. Now, for loop iterates over a sequence of items. It can be a list that we have seen before. It can be a tuple. And again, it can also loop over string because string is nothing but a sequence of characters. And we also have range and other things, which we'll look in future. So let's first look at the syntax for this. So if I want to use the same one, comment it out, go above, and I want to look at the syntax for loop. And that goes something like that. You say for item in a particular sequence, be it as I mentioned list, tuple, string, range, and or anything else, I can write my code block inside here, something like that. Now let's go ahead and create an example. So what I'm going to do is I am going to comment this out and let's create an example where I want to loop through a list of items. So to do that, first let's create that list. I'm going to say fruits equal to, I'm going to create a list of fruits. The first item I want to say apple, another one I want to put a banana in there, and C for, let's put cherry. So I have a list of fruits here, and now I want to loop through them. I'm going to say for fruit in fruits. So this variable can be anything. I can just say a, but it doesn't make sense. What it does is it takes each item one time and runs through the loop. So for example, it will look for first time when it runs, it takes apple and the value of fruit is apple in this case. In the second run, when it runs through it again, it will take banana and assign it to fruit. Third time it runs, it will take cherry and assign it to fruit. What I'm going to do here is I'm going to say print fruit. So this, let's run it. And we have apple, banana, and cherry. That's what is printed out here. I can do loop through a range, which I mentioned earlier. The way to do it is, let me just first write a comment, loop with range. And inside this, I'm going to say for I in range of 5. So what this does is it will create an list of 1 to 5 items, and it will assign each item once inside this range from 1 to 5 and print that out. So if I run this here, it will say 0, 1, 2, 3, 4. So what it does is here it creates, let me just add a comment, create a list of 0, 1, 2 or sequence 4. So these are 5 items. So when you say number range of 5, it will create these 5 items and assign it each every time it runs through the loop. So I'm going to say first time it will take 0 and print that 0. I'm going to comment this out so you can see a better output. Also clear this out so you can see it properly. So first it goes through the first item in the range, which is 0. It prints that out. Next 1, 2, 3, and 4. These 5 items are printed one at a time. If I say 10 here, Run this again, 0, 1, 2, 3, 4, all the way until 9, the 10 items we can display here. So this can be used for a bunch of different things. So that's for loop for you. I'm going to comment it out. The next loop that we're going to look at is while loop. Now while loop executes as long as the condition is true. So what I mean by that is you write a condition with while. For example, let me show you the syntax. So the syntax for while loop is something like this: while a condition, so this is can be a variable name, which is a boolean, can be a particular, you can equate things and check if this particular condition is true, and if that is true, then this is the code that it will run until this condition keeps on staying true. So if I say if true, this is how you can write an infinite loop. So it will keep on running forever unless you add some break or something inside it, but we'll cover that later. So I'm going to comment this out right now, and let's go ahead and create an example. I'm going to say create a countdown. I want to create a countdown. I'm going to call it countdown from 5. So I am going to create a variable, say count equal to 5, and then I'm going to say while count is greater than 0, I want to print that count. Now what will happen in this case is, if I run this, is count greater than 0? Count value is 5, so it is greater than 0, so it's going to print 5. Again, it will come again and check, oh, count greater than 0? It is 5, nothing has changed this value, so it's going to print 5, 5, 5 and keep on going forever. So that it does a proper countdown, I am going to say, or reduce the count by 1. So what I'm doing here is, I'm using the decrement operator here, where it's same as saying count minus 1. Instead of doing this, there's a shortcut, which is a decrement operator. There's also an increment operator or a multiply operator, division. So all those are available, but what I'm going to do here is I will reduce the count by 1 every time this prints out. So 5 reduces the value of count to 4, and this count is greater than 0. Yes, it is. So 4, 3, 2, 1. Then when its assigned value is 0, is count greater than 0? Nope. It will come out and come here, where I'm going to say outside while loop. So that's what will happen. So let's go ahead and play with it. Clear this out, run it. There you go, 5, 4, 3, 2, 1, and outside while loop. So that's how while loop works. So I'm going to clear this out, comment it out, and go back to my slides. So next, we're going to look at using break and continue for control flow. So I mentioned these before a little bit, but let's go ahead in more detail of what break and continue does. So first, break. Break terminates the loop prematurely when a condition is met. So if a loop is going on and you want to stop because a particular condition is met, you can use break for that. So an example for that can be, let me just create here, let's create a for loop for I in range of 10. I want to print I. So what this will do right now is, if I run this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because I'm saying range of 10, I want to print I, so it goes through that. But I want to stop it after 5. So I can say if I equal to 5, so I'm adding a conditional statement here saying that if the value of I is 5, just break out of this for loop. I don't want to run this anymore. And I can always put this here outside for loop. Run this. You see 0, 1, 2, 3, 4, because when the value of 5, it will break out from this for loop and come outside and print this. If I similarly, I can say 7, it will print all the way till 6 and then come outside the loop. So that's how you can break a particular loop. Maybe it's for or while, anything, you can break out of the loop by using break. Next, we have continue. Now, continue skips the current iteration and proceeds to the next one. So what it happens is that if you're running a loop, it will skip that particular operation and run to the next one. So for example, in this particular case, same case, I can give you an example. Continue. So what will happen is, in this case, when the value of I is 7, it will skip that print and go back here. So it will say 0, 1, 2, 3, 4, 5, 6, and then skip 7 and go 8, 9, 10. So it continues to the next loop. So if I run this, let's go ahead. So 0, 1, 2, 3, 4, 5, 6. See, 7 is missing, 8 and 9. Similarly, if I want to miss, let's say 5, run it. 0, 1, 2, 3, 4. I can skip something and run, still continue running the loop. So that's what continue is used for. Let's look at one more example here. So what I'm going to do is I'm going to clear it out. I'm going to comment this out. And I'm going to say for I in range of 10. And in here, I am checking if I mod, I'm not sure if you've used the mod operator, but it gives you if it's divisible by 2 or not. If it's divisible by 2, I want to continue, not break, and go to the next one. So this will print only odd numbers. So if I run this, 1, 3, 5, 7, 9. So what's happening is it's going through this I range 0 to 10, but when it checks 0, it will say, oh, 0 divisible by 2 is 0, whereas 1 divided by 2 is 1. So it will print 1. It will not go inside this loop. But for 2 divided by 2 is 0. So it will skip this, and so it will run through 0 to 10, and it will only look for odd numbers because even numbers are divisible by 2 and the value is 0. So it will continue and skip that particular loop. So that's why I see all odd numbers here. So now that we have completed all the different conditional statements and loops, control flow types, so now we can jump into our hands-on exercise. Our first exercise is to check if a number is prime. So here the main objective is to write a Python program to determine if a given number is a prime number. So for this, first you need to know what a prime number is. A prime number is only divisible by 1 and itself. We can use a loop to check divisibility for numbers between 2 and the square root of the given number. That's what we can do, and we can break the loop if a divisor is found in this particular case. So that's how you can get prime numbers. So let's go ahead, and I'm going to leave it as it is, this one. I'm going to create a new file, save it as day 2 exercise 1.py. Now here, first let's get the number equal to int, and instead of me giving a number here or setting a variable with a number, what I'm going to do is I'm going to ask the user who is going to run the command prompt to give me that number. So I can use input, and I can ask the user enter a number. So there you go. And now I'm going to say if number is greater than 1, first of all, inside here I am going to check for I in range of 2 comma integer number raised to 0.5 plus 1 if num mod I equal to 0, then in this case this is not a prime number. So just to go over it again, just to understand better, what I'm doing here in the first line is I'm asking the user to enter a number, and I'm converting that number into an int right over here, and that number I'm saving inside the variable num. Next, I'm checking if the number is greater than 1. This checks if the input number that I've saved here is greater than 1. But why am I doing it? Prime numbers are defined as integers greater than 1 that are divisible only by 1 and themselves. So that's why I am checking if the number is greater than 1. If not, it will skip the program and then proceed to check if it's prime. So if not, then it will skip to the else block at the end, which we'll write in a little while. But right now here, once let's say if the number is say 13, it's going to check here in line number 3 to 7. What it does this is range 2 comma integer num times multiply 5. What it does is it generates numbers starting from 2 up to the square root of num. So this is how you get the square root, rounded up to the nearest integer plus 1. So that's what's happening here. Now, why am I doing square root here? If a number is not divisible by any number less than or equal to its square root, it's prime. This optimization reduces the number of checks. So for I in this thing, it iterates through each number I in the generated range to check if number is divisible by I. So that's what it's doing here. So next, in this particular line, if num mod I equal to 0, it checks if the number is divisible by I using the modulus operator. If num mod I equal to 0, it means num is divisible by I, so it's not prime. Next thing is to let the user know that. So I'm going to say print, and since I'm going to add a variable, you start with f, and then here is what you pass the variable inside the curly brackets is not a prime number. So this will show it like that, and I'm going to go and break out of it here. So this will break out of my current loop. Else, now else is for this particular case, I am going to say I am going to print f number is a prime number. Now I have one more if, like let's make sure we are all aligned on which if I'm writing that to, and I have one more if on the top. For that I'm going to else print f of number is not a prime number. Oop. Is not a prime number outside. So what's happening here is in the else loops, once I break out of here, if it's not a prime number, that's done. Next, what I'm doing in the following lines is I am printing. So if it's not a prime number and if it doesn't mod this, so I am saying else it's a prime number. That's what I'm saying here. And finally, the last else block is associated with the for loop, where so when does this execute? If the for loop completes without encountering a break, no divisor was found, that's when this will run. So it has to be kind of given right outside for loop. And then the final one, it prints. So what happens in the end is this else block belongs to if number is greater than 1 statement, which means if this will execute saying that if the number is not greater than 1. So for example, if it's 0, 1 or negative numbers, this will run from here. So let's go ahead, save this and run this particular code. I'm going to say Python day2 underscore exercise 1.py. So it's asking me first line, enter a number. So let's say I will enter 10, which I know is not a prime number. Say 10 is not a prime number. I am going to go and run it again. And this time I'll give 13, which I know is a prime number. And it says 13 is a prime number. So it goes through the loop, finds out that it is not divisible by any of these numbers. And that's why it's going to go and say it's a prime number here. So that kind of completes our first exercise where we have created the code to find out if a number is prime or not. Our next exercise is to create a menu-driven calculator. The objective here is to create a Python program that takes user input to display a menu with simple math operations, where we'll be doing addition, subtraction, multiplication, and division. So the instruction that I would want to give you before we start is we'll have to present a menu with options, just like how we did before. But before we asked user to, in exercise 1, we asked the user to enter a number. But here we'll give them a menu of addition, subtraction, multiplication, and division. Then we'll allow the user to select an option and input numbers. Then perform the selected operation that user wants and display the result. We'll use a loop to repeat the menu until the user exits. So first, let's go ahead and create a new file. I'm going to save this and I'm going to say day2 exercise2.py. Here, let's start with the functions. We have not yet covered functions, but it's better we go through it as and when we learn it. So what I'm going to do is I'm going to create a function called add, which adds two numbers. I'm going to give two parameters, a and b. Now, if you don't understand what I'm doing here, just follow along, and in the next section, we'll learn more on these. And here, I'm going to say return a plus b, because that's how you add two numbers. Next, I am going to say subtract, and that again takes two numbers, a comma b, and this one returns, so this function will return a minus b. Next, I want to do a multiplication. I'll say multiply, and I'll take two numbers, a comma b, and I will return a times b. Next, I am going to do divide, and this again will take two parameters, and this will first in division, sometimes you check if it's not equal to 0. So I'm going to say not divisible by 0. So b is not equal to 0. So I'll have to make sure that division by 0 is not allowed here. So I am going to check if b is not equal to 0, because a divided by b, and in this case the second argument, if it's 0 or not 0, I will say return a divided by b. If the user gives me a 0, I am going to print out saying, or return back saying division by 0 is not allowed. Just an extra precaution here. So these are my four functions to add, subtract, multiply, and divide. Now I'm going to write a loop here. I'm going to say while true. Again, as I mentioned, when you say while true, it will run on a constant loop. Now to break out of it, you can just say break, but where should I say it break? So first, as I mentioned, we need to give a user a menu option. So I'm going to say print, and in here, next line /n adds the next line in the terminal or a command prompt. I'm going to say menu. Now the menu, I will give user options where, so this one is for addition, subtraction, multiplication, division, and exit. So I think I have all of them. Number one, so if user says number one, with an addition. If the user presses number 2, I will say subtraction. If the user presses number 3, I'll say multiplication. If the user presses number 4, it's division. Number 5 is to exit. So which means if the user presses 5, I will just exit out of the loop. So if you want to see how that is done, I can just say if let's get the choice first from user. So I'm going to say choice equal to input. I'm going to ask user enter your choice based on the above menu. So based on the above menu, I'm going to ask the user to enter something, and if the user picks, let's say 5, what I'm going to do is I'm going to say print exiting program, and I will break out of this code. Break out of while loop, which is end of this function. There's nothing else outside it. Or else I'll ask the user to enter the two numbers. I'm going to say number 1, I'll take it as float because user might enter decimal point values, and I'll ask the user to input something. I'll say enter the first number, and I let user enter his first number, his or her first number. Number 2, float, enter second number. This is where the user will enter the second number. Now I have both the numbers. What I'm going to do is I'm going to check if choice equal to 1. If the user selected 1 as his choice, which is addition, so what I'm going to do is print result is add. I'm going to call the function add, which is right here, and it needs two parameters, which are my number 1 and number 2. So I'll pass that. So what it does is, if the user picked 1 here and then entered 2 and then enter the second number as 4, I'm going to pass this 2 and 4 to this add, which is 6, and it will show me print the result equal to 6 in this particular case. So that's the first one. So I'm going to copy this few times. Now I can't do if because what it will do is it will go through each and every one 4 times. 1, 2, 3, 4. So this is 2, 3, 4. If I leave it like this and add the functions, subtract, third one was multiplication, and the last one was subtract. So these are the different options. Now if I run it through here, it will check each and every time, but I want to see, like, if I'll check 1, if it's not 1, then I want to check the second one. Or else what it will happen is, even if the choice is 1, it will go through each and every statement. Else this one. Now what if user types anything other than 1, 2, 3, 4, 5? So for that I will say else print invalid choice, please try again. So for example, if the user presses 9, we don't have anything to do with 9, so I'll say invalid choice and I'll ask the user to try again. So go ahead and run this. Let me clear this out. This is called day 2 exercise 2. So here is my menu. Addition, so this printed out addition, subtraction, multiplication, division, exit. So I am going to say 1. Now it says enter your first number. I say 3. Enter second number, 5. Now 5 plus 3, and as you saw that I took the input as float, so it will take it as 3.0 and 5.0 and print out 8.0 for me. Similarly, if then again it will run through the while loop again. Since I've not exited the loop, 2, let's say 5 and 1, let's say 4.2 is the result. Similarly, if I pick 3, let's say 4 times 5 should be 20. Now 4, I want to divide 4 by 0. So looks like here in the code, instead of calling the divide, I was calling the subtract. So I'm going to fix that and go ahead and run my code again. Give the option 4 and say 4, second number 0, and it's a division by 0 is not allowed. Let's go ahead and pick 5, exiting the program. So that's our exercise number 2. I hope you were able to get through it. If you have any questions or any problems, let me know. And for the next things, what you can do is, for additional practice, I have a couple of more programs for you. What you can do is you can write a program to calculate the factorial of a number using a while loop. Now, if you don't know what a factorial is, go ahead, look it up, and then write this to create to calculate the factorial of a number using a while loop. Next, you can try to create a program to find the largest number in a list using a for loop. So you can try that out. So if you have a list of items, so create a list of items and add some numbers inside there and use a for loop to go through each and every item in that particular list and find the largest number in the list. So that's it for day 2, where you learned the foundational control flow constructs in Python, including conditional statements, loops, and flow control keywords like break and continue. The hands-on exercise probably helped you with concepts with real-world programming tasks, preparing you for more complex logical challenges, and try to do these additional practice sessions on your own. If you had any problems or have any questions, let me know and I'll get back to you. Welcome to day 3, where we will be covering functions and modules in Python. We'll start with defining functions with def. Now, we've already done this in the previous day or yesterday, but we're going to go in more details about what are functions. Now, a function is a reusable block of code that performs a specific task. Functions improve modularity and code reusability. It helps you. So, for example, if you see somewhere that you are repeating the same code over and over again, just create a function out of it and call that function from one single place. So in future, if you have to change something, you change only at one place and don't have to change every single place where you have the same functionality. Now, defining a function. To define a function, you use the def keyword, as we saw in our calculator example in yesterday's video. So you use the def keyword to define a particular function. Now, the syntax for that might look like, I'm going to create a file, save it inside our day3, call it day3 samples.py. And here, if I want to create a function, you say start by saying def, then comes the function name. So here is the function name, whatever name you want, you feel like you give here, and then the parameter. So whoever is calling this particular function needs to send parameters. It can be empty too. If you don't want to send anything, it's just like say print hello, for example. You don't need to add any parameters in here. But if you want to add two numbers, then you add two different parameters here that are passed. And below it, so next line, it goes where code block goes. Now a function can return or not return something. If you want to return something back to whoever called it, like how we did in our calculator example, you can use the return keyword and pass a result back to the calling variable. So again, as I mentioned, parameters are values passed to the function for processing. The return values are values returned by the function after the processing. Let's look at some examples in this case. So we already created that file. I am going to comment this out and here create a function with parameters and return value. So I'm going to create a function. To create a function, as I mentioned, you use def, and then I'll say this is for my addition. I'm going to say add numbers. That's what I want to call this function. You can call it anything you want, add, addition, add numbers, and I need to send two parameters because I want to add two numbers. You can also add three numbers if you want and add a third parameter over there, but I want to make it simple where it adds two numbers a and b and returns it back. Now I can return it directly like this. You can also do is inside here I can create a variable c and say a plus b and return c. So that is also possible, but less lines is always better. So I always like to say a plus b instead of doing this. I'm going to comment this out. And now to call it, let's say a variable result wants to add two numbers. It can say add numbers and pass two numbers, for example 5 and 3 in this case, and I want to print that summation of addition of those two numbers. I can just print that result variable out here. If I go to my prompt, you can say cd day 3, and here I have day 3 samples. So I'm going to say python day 3 samples.py and sum is 8. So similarly, I can change here 45, let's say that says 48, which is 45 plus 3. Clear it out. So that this is how you can create a function. Again, the function is created by the keyword def, where you're defining a function, then the function name, whatever name you want to give, the parameters that it has, or if you don't want to pass any parameters, you can just skip it. For example, in this particular case, I can just say add two numbers and I can just return two numbers like this, run it, and it will add two numbers and return it back. But you have to change the variables here, which doesn't make any sense, but this is how you can call a function with no parameters in there. So now that you know functions, let's look at scope and lifetime of variables. Now scope has two different types of scope. One is called as a local scope, where the variables defined in the function are only accessible within that function, which means, for example, if I create a variable c here, the scope of this variable c is only for this particular function. If I use c here, it will not know what c is, and it will probably say, oh, nothing, I don't know what c is. So that is called as a local scope within a particular function. We also have something called as a global scope, where variables defined outside functions are accessible throughout the program. So that's the global scope. We also have something called as lifetime, where local variables exist only as long as the function executes. So what it means is the the local variable that I created, for example, the C that I've created here, only exists as long as the function executes. As soon as the function is done executing, those variables do not exist. Global variables persist throughout the program unless it's modified within a function using the global keyword. I can show you some examples. For it to run into examples, let's first go ahead and comment it out. Let's start with the local scope. So for local scope, I am going to create a function called as greet, and inside here, I am going to say message equal to hello world. Now this is a local variable inside this greet function, which means if I try to use that outside, it will not know what is the value of this variable. Now if I call the greet function here, this should call this this will call this function and print the message. But if I try to print something like message here, it will not know, because this function, this message variable, is local scoped only to this function. It's not available outside. That's why we indented, just so that we better understand this. I can go back here, clear it out, and run that, and you see it gives me an error. It says name message is not defined. It doesn't know where it's defined. What are you trying to do here? So this gives you an error. If I remove it, it will just work as same as before, but doesn't try to run this, and it will not give you a message. So if you want to use this outside, one thing that you can do is you can use global scope. So let's comment these out, and let's look at global scope. Now in case of global scope, I'm creating a variable called as greeting equal to, let's call it hi, and I'm creating a function called as say hello, and inside here I am going to say print greeting. So what's happening is the message that I've created here, I have created that variable outside, which means it's available here inside the function, as well as I can just say print greeting outside the function too, and it will not give me an error, because if you see where the variable is defined is outside the function and is also accessible to this print statement right here. Now if I run this here, I will not have any error. It will say hi from here and then hi from here. This I can just concatenate it from inside the function, and this one I can say from outside the function. Run it. Hi from inside the function, because it calls this, it will print it, and then it will print this same hi message from both inside and outside the function. So that's how you can create a global scope for this. Next, let's look at importing and using modules. Now, what are modules? Modules are Python files containing a collection of functions and variables that can be reused. So instead of creating functions, if there are a lot of things that you are doing and want to reuse among different teams, you create modules. So modules again are Python files containing a collection of functions and variables that can be reused. Built-in modules can include something like, Python has already given you some modules like math module, OS module, and random module. So first, let's look at importing modules. So there are different ways you can import modules. You can import an entire module, where I can give you an example here. Just comment this out. So if you want to import an entire module, you do, for example, I want to import the math module. So I'm going to say import math. And in here, now I can use that module by saying math dot, there is a function called a square root in there. Let's call that square root of 16. If I run this, so I don't have to write the code to actually uh, get a square root of a particular number. I can just say math dot square root, and if I run this, it will say 4 is the square root of 16. Next is importing specific functions. Now math has a lot of different functions. What if you want to only import a particular functions? In this case, I want to from math, I want to import square root. So that way I don't have to write this. I can just say square root of 16 and it will know what I want to do. So go ahead, run it, and it gives me the same result, because of course instead of importing an entire module, I'm just importing a particular function from that module. Another thing that you want to know about importing modules is using aliases. So here, instead of calling it math, I can call it, sometimes the module names are really big, so I can just say math as m. So I can use an alias here, and then I can say m dot square root. Sometimes, let's say I create a module called as Vivian is dancing on the mountain top. So I can just say import Vivian is dancing on a mountain uh, top as VIV, something like that. So there are some functions that there'll be some modules that you'll see which have really long names, and if you want to use a shorter version of it, this is how you can use aliases to create this. Now, another option is creating your own custom modules. Now, sometimes what will happen is you'll have a lot of functionality that is available in your code, and you have multiple files, and you want to reuse these modules in different files. So what you can do is you can create a .py file with custom functions and variables inside that particular Python file, and you can import that into another script using import and the name of the module directly. We'll see those in future, but that's how you can create your own custom modules where you have a lot of code which might be needed in different places. Then you can use that. One example I can give you is, for example, let's say you have a organization which has 5 different departments, and they have the same login because the organization has the same login behind it. So instead of creating the login functionality every single time for 5 different departments, you just create that component or a module one time, and then let all these 5 departments import that module into their code, where every time a user comes in, they can log in. So that can be a good use case of creating custom modules. Now, let's jump into hands-on exercises. Our first exercise today is creating a function to calculate factorials. Now, I've given you something similar as an exercise in the yesterday's video, but here our objective is to write a function to calculate the factorial of a number and call it within another function. So first we will define a function called as factorial n that calculates the factorial of the number n. Then we'll create another function called as print factorial n as a parameter that calls the factorial function and prints the result. Let's go ahead and write the code for it. So I'm going to save this and close it, create a new file, Python file, save it inside my day 3 as exercise 1. And here, first, let's create a function called as factorial of n. Now here, I'm going to say if n equal to 0 or n equal to 1, what happens to factorials? If n equal to 0 or n equal to 1, that means I just return 1 in this particular case. Else, I will call the same function. So I'm going to say return n times factorial n minus 1. So what I'm doing is I am reducing that number by 1 and multiplying whatever the result is from this particular, keep on multiplying. So that's what factorial is. If you don't know what factorial is, for example, if I say what is factorial of, let's give an example of 5. 5 factorial is 5 times, reduce that, sorry, let's do something like that. 5, the first number, n times, reduce that number by 1, 4, run it here. So which means 4 times, it will call it 3 times, now the number will be 2, again it will call this, times, now it will be 1, in that case it will return back 1 here. So this will give me 5 times 4 times 3 times 2 equal to 120. You can do the math and check it out, but that's what factorial of 5 is, or we can run the function and check it out in a little while. So what I'm can do here is I'm going to say create another one function, and this one is to print a factorial, print underscore factorial n, and here I will say result equal to factorial of n, and this is used to print the factorial of n is result. So that looks good. And now let's test this function. I can say print underscore factorial and pass a number 5 is what we wanted to test. So this will call this function and it will get the result from this particular function, which is just only doing what I'm doing is I'm kind of separating these two here. The reason is so I can kind of separate the functionality of finding a factorial and printing a factorial separately in two different functions. I will save it, go here, clear this out, Python exercise 1.py, and it says factorial of 5 is 120. I can change the number 10. Factorial of 10 is 362. Give something simple. Let's say 2 times 1 is 2. So 2 times 1 is 2. So that's why factorial of 2 is 2 in this particular case. So this is successfully completing our exercise where we are printing a factorial of a given number. Our second exercise is to build a custom Python module. Now, objective here is to create a module with basic math operations and use it in a main script. So let's create a Python file called as math operations with functions for addition, subtraction, multiplication, and division, something that we've done in a previous day. And we'll import and use this module in another script. So we'll create two different files. So first, for this, let's go ahead here. I am going to call it, since it's a module, I am going to call it math underscore operations dot py and save it inside day 3. Now here I'm going to create a bunch of functions. Let me do that. A comma b, the addition will return back a plus b. Next is subtract a comma b, and this will return a minus b. Next one is to multiply a comma b, and then here I can say return a times b. Next is divide a comma b. Here again I will check if b is not equal to 0, then I will say return a divided by b, else I will say return division by 0 is not allowed. So I have 4 different functions here inside my mat.operation where it does addition, subtraction, multiplication, and division. Now I will create a main script or create another script. I'm going to call it exercise2.py, and inside here I am going to import that math underscore operations as mo. So I'm going to use the alias that we did. Next, I'm going to say number 1 equal to 10, and I'm going to say number 2 equal to 5, and then I'll say print addition is mo dot add is a function that we have there, and I'm going to pass number 1 comma number 2. So my 2 numbers. Let's see if it works just for addition, so we can do more after that. Clear this out. Let's say Python exercise2.py. and it says addition is 15. So what it did was, since it's in the same file, it picked up a same folder, it picked up this file and imported as mo, and then when I added these numbers, it called this function to add and then ran it here. So similarly, now I can add the other four, which is subtraction, multiplication, and division. And here I'm going to say divide, multiply, subtract, and add. So now if I run this, say 10 plus 5, 15, 10 minus 5, 5, 10 times 5, 50, 10 divided by 5, 2.0. And there you go. We have our function here, or we have our main code here, main exercise 2.py, where we are printing out all the different functions from our module that we created, which was called math operations here, which has all the functions in there. Now I can use the same thing in this exercise 2. I can call it in exercise 1. I can create another file and have them import this particular module and use it over there. So I hope you were able to follow along. If not, let me know if you had any problems. But next, for additional practice, I would say that you can try to create a function to check if a number is even or odd and call it within another function. And then try to create a module for string operations, including functions to reverse a string, count the vowels in there, and check for palindromes. Now import it into a script and test the functions. So you create a module and then import it in another script and test if it works for you. So today in day 3, you had some hands-on experiencing defining functions, understanding variable scopes, and working with modules. By practicing with built-in and custom modules, you developed reusable modular code, a critical skill in AI and software development. So this will be very much helpful in our future videos. So I hope you followed this along nicely, and if you had any problems or questions, let me know and I'll get back to you. Day 4, data structures. Here we are going to cover lists, tuples, dictionaries, and sets. Now we probably have used some of them before, but let's go deep dive into each one of them. Let's start with lists. So what are lists? Lists are ordered, mutable collections that can hold a variety of data types. When I say mutable, that means they can be changed and appended, deleted, edited, all those things. When it says immutable, that means once you create them, it stays as they are. So lists are again ordered, mutable collections that can hold a variety of data types. Now let's see, how do you create a list? So I'm going to start with an empty project, create a new file, Python file, save it inside our AI Bootcamp week 1, create a new folder for our day 4, and here I'm going to say day 4 data structures .py. Now to create a list, let's say I want to create a list of numbers. So I'm going to say numbers equal to, create these numbers 1, 2, 3, and 4. So this is a list of 4 numbers, 1, 2, 3, and 4. I can create a list of fruits where I can say, so again, square brackets, I can say apple, banana, and cherry. So this is my list of fruits, which are list of strings inside here. This was list of integers. This is list of strings. I can have a mixed list too, which has combination of both or more. So 1 is a number. I can have apple, and I can also have boolean in here. The third element is true or maybe false. So that's how you can create a mixed list. Now next I want to talk about accessing these elements. Now you can access these elements by index. So what I mean by that is, so for example, if I want to print numbers and I want to print this is the 0th element, first and second element, and this is the third element. So the index is 0, 1, 2, 3. Again, for this is 0, 1, and 2. 0, 1, and 2. So if I want to access the third number, which is 3, 0, 1, and 2, so that's the index, and that's what I'll pass here. Similarly, if I want to access the first fruit, I'm going to say fruits of 0. If I want to access inside this mixed, I want to access the second element, which is apple, I'm going to say 0 and 1. So this is first element, 0, 1 index. I save it. I can run it here. You can say ls cd day 4, and I'm going to say python day 4 data structures. And if you see, this is 2, which is this one, apple, and the apple again. So I can change this to 0, 1, and 2, which is cherry. So index 2 can print it out, 3, cherry, and apple. Perfect. So that's how you can access this element, by accessing through their index. That's what it's called. We also have something called as negative indexing. What happens here is, so for example, if I say that fruits of -1, so what will happen is, this is the index 0, 1, and 2. Now if you go in the opposite direction from here, 0, -1 will be the last item here, -2, -3. So if I say fruits of -1, it should give me cherry. So if I go here and print it, it will give me cherry, because index of -1 is, this is 0, so the last one is -1. So that's how you can use negative indexing. We also can, next we're going to talk about modifying these lists. There's two different ways you can modify a list, where you can add items and you can remove items. Now if I want to add items, for example, in my fruits, I want to add more items, I can just say here, let me comment these print statements out, and I can say fruits dot append. So that's the keyword, append, adds to the end of a particular array. So in this particular list, I have apple, banana, and orange. I want to append another one, I can say orange. Another way of appending or adding items is, I can say fruits dot insert. In this case, I want to insert at a particular index, let's say index 1, I want to insert grape. So this inserts at index 1. So this is index 0. So this is index 1 right now. So this will insert grape in between apple and banana. So if I print fruits right now, the entire array will look something like this. Apple, then grape was inserted, and banana and cherry are there. And since I appended orange, orange showed up at the end. If I don't do this here, run it again, I have apple, banana, cherry, and orange. If I don't do this, I have apple, grape inserted at 1, and then banana and cherry move one index to the right, and that's why we have 0, 1, 2, 3, where grape is inserted at index number 1. Now if I want to remove something in here, so I'm going to keep all of them, clear this out. Now if I want to remove something, what I can do is, I can say fruits dot remove, and I can specify what I want to remove. So for example, if I want to remove banana, so I can just say remove banana. So if I do that, run it, it will say apple, grape. Okay, I didn't print it again. Let's go ahead and print this after the removal, of how it looks like. So before and after. So before I have apple, grape, banana, cherry, and orange, but after I removed it, it removed banana from here and moved everything one index to the left. So cherry came here, orange came here. So index is 0, 1, 2, 3. You can also delete by saying delete fruits at index, let's say 0. You can print it out just to show you how this works. Go here. So if you see apple, grape, banana, cherry, orange, then I removed banana, so it became apple, grape, cherry, and orange. Then I said delete fruit at index 0, so it removed apple and moved everything one index to the left. That's why we have grape, cherry, and orange here. Another option is, if you want to remove something from the top, you can say fruits dot pop. What this does is, it removes the last element. So if I go ahead and print it now, let's clear this out, and now you have if you see that we did this apple, grape, banana, cherry, orange, we removed banana, so we had apple, grape, cherry, and orange. Then we removed the first item, which is apple, so we got grape, cherry, and orange. Now when I said pop, it popped the last item, which is orange. If I call it one more time, it will remove even the cherry. So it pops two of the items. One is orange and one is cherry. It will pop items from the last elements, from the last indexes. Next, let's look at slicing lists. Now, slicing is kind of getting elements from a particular place. So, for example, I just want to get grape and cherry from this particular fruit. How do I do that? So, I am going to first remove my delete statements from here, still display this. So, I have apple, grape, banana, cherry, and orange. Now, I want to get, let's call it sliced fruits, and here I am going to say I want fruits from index 1 to 3. Let's print this, print sliced fruits. So this is how you can slice a particular list of items, where it takes, like, what is printing is 1 to 3, so 0 1, so this is the first one, 2 banana, and it doesn't take cherry because I said 1 but before 3. That's what it means. If I say 1 before 4, it will display grape, banana, and cherry. I can just say 2 to 4. So depending on which items you want, so 0 1 2 2, and before 4, so that is banana and cherry. So you can kind of slice a particular list into a smaller list and use that for some other operation you want. You can probably think of thousands of different operations that you can do with this right now, but that's how you kind of slice a particular uh, list of items, by giving this index colon index syntax. Next, now that we have completed list, let's look at tuples. Now tuples are similar to list, but what exactly are tuples? Tuples are ordered immutable collection of items. Unlike lists, which were ordered mutable collection, tuples are immutable, which means you can't change them. Now let's look at how to create tuples. So I'm going to go back here again. Go ahead and comment everything. Go all the way to the top here. And first, let's create a tuple of colors. I'm going to create a tuple by giving the rounded brackets. And here, first is red. My favorite three colors, red, green, and I guess you guessed it, blue. So these are three colors. Now in here, I want to create a single item tuple, where what you have to do is, let's say I would say glass. And if you want to create a single item tuple, you need to put a comma at the end of it, or else it will not take it as a tuple. So for tuples, you make sure that if it's only single item, you have to give the name of the first element, or the first element that is either a string or maybe a number or whatever it is, and then give a comma next to it specifying that this is a single item tuple and this is a 3-item tuple. Now, next thing that we'll look at, how to access elements in a tuple. It's very similar to list, since it's ordered list. It's an ordered item, ordered data structure. So you can just say print colors, and you can just say 0 and get the first color. You can also use the negative indexing, as I mentioned, and it will give me blue, the last element over there. Can clear it here, run this, and you'll see red for index at 0, and -1, which goes the other way around, and that's why we get blue here. Now again, something that we want to remember is immutability. Tuples cannot be modified after you create them. However, they can contain mutable items like list inside them. So we have strings here in this particular case, but you can have list inside there, which and list can be mutable. So that's how you can create a mutable list of tuples. Next, let's look at dictionaries. So first, what are dictionaries? Dictionaries store key value pairs for fast lookups. Now in case of list, it was ordered. In case of tuples, they were also ordered, so you can access them using 0 1 2 3. But in dictionaries, you access items using the key value pair. So you can access a value using the key item. So let's see how we create dictionaries. So I'm going to create a dictionary here. Again, comment it out and move it down. For dictionaries, I am going to let's create a student dictionary. And to this student, I'll give a name, and name I'll give Alice. Age I'll give, let's say, 25, and grade I will give as, let's say, A grade for Alice. So this is how you can create a key value pair where the key is, in this particular case, name, age, and grade. These are different keys, and values are Alice, 25, and A. So unlike list where you have like in ordered 0, 1, and 2, here you don't have an order, but you have key value pair. If I print this student, go back here and print it, you see name Alice, age, and grade. You'll probably see the way it is specified here. It's not an ordered item, so it might be saved in any order. The way it's accessed is through the key value here. Now let's talk about that accessing and modifying data. Now to access, first you'll probably can access this the values inside here from the key. So I can say what is the name of this student, and when I print that, it says Alice. So that's how you access. So you can say age here, and you can get age, or you can say grade and access the grade of this particular student. The next thing that we want to talk about is adding and updating. So what if I want to add something to this uh, particular group? So I can just say, let's move it here, print the entire student, and then to the student I want to add a subject. I can say student inside square brackets. I know square brackets are used for list, but when you are assigning a key and a value, you can do it using this. I can say subject that I want to add to the student is math. So this creates a key value pair. If I print this out, probably say name, age, grade, and subject all displayed here. Clear it out. And again, now if I want to update something, you can again do it similarly. You can say that I want to update the age from 26 to 32. Now if I print it out, you'll see name is Alice, age has got updated to 32, grade is A, and subject is math. So this is how you add and update items inside a particular dictionary. Next, let's look at how do you remove items. Again, something similar to list. You can just say use del student and a particular item you want to delete. For example, I want to delete the grade. That's how you can remove it. Also, let's print it out first, and then you can also use the pop. I can say student dot pop, but in this case you can't give empty. You'll have to specify what you want to pop. So I'll say subject is what I want to pop. Take this, print it out, let's display it. So first one, this is the original one, and then I said delete the grade, and if you see grade is missing here. Then I said pop subject, and if you see it popped subject out of this particular dictionary, and now I only have name and age here. Next thing that we want to talk about is iteration. Now how do you iterate through a particular dictionary? The way to do it is, because for lists and sets is easy because they are indexed, but if I want to iterate over a particular dictionary, the way to do it is for key and value in student dot items. So what it does is it puts everything inside student with calling this function student dot items, puts them in a list. This is what this function does, items, and now you can access each key and its value from the student dot items function. So I can just say print here key and value. So this will show me what will I get when I do this. So see, name is Alice, age is 25, grade is A. So it created a list of key value pairs from a dictionary, and then I can iterate over them one at a time and display those values. Next, let's look at sets. Now, what are sets? Sets are unordered collections of unique items. So the one thing that you have to remember in sets is you can't have repetitive items. Like for example, if you have a number, a set of numbers 1, 2, 3, 4, that's fine. But what if you have 1, 1, 2, 2, 3, 3, 4, 4? Then it will kind of drop those duplicates and it will give you a set of 1, 2, 3, 4. So a set or sets are unordered collection of unique items. So how do you create sets? To create sets, just first make sure that this is commented and go down here. We create numbers equal to, again, angular brackets 1, 2, 3, and 4. So it's not key value pairs, because inside angular brackets key value pairs are dictionaries. But if you use angular brackets with items inside here, that's an unordered collection of unique items, which are sets. You can also create an empty set. For example, I create just a variable name called an empty set, and to create an empty set you can just say set empty. That's how you can create an empty set. Now, how do you add and remove elements from a set? I think that's the next topic, adding and removing elements. To do that, first I can just say inside numbers I want to add 5. So let's print numbers here first, and after adding, let's print again. Let's run it. We clear it out first, run it. It says 1, 2, 3, 4, and if you see 1, 2, 3, 4, 5, so I've added one more item. What if I want to add, what if I try to add 4? It will say 1, 2, 3, 4, and the output is again 1, 2, 3, 4. Why? Because 4 already exists, so you can't add duplicates. You can add some other numbers, but no duplicates. As long as there's no duplicates, it all works fine. Now, what if I want to remove something? So I can just use something similar and say remove, and I want to remove, let's say 2, and let's run it. So I have 1, 2, 3, 4, 8, and if you see here 1, 3, 4, 8, so 2 got removed when I call the remove function on a particular set. Next thing that I want to talk about is set operations. Now you probably have learned about this before, but set has 3 different operations. First is union, which is union of 2 different sets. When you try to, so for example, I have this, or let's create a new one. I'll remove this. Set 1 equal to, I have 1, 2, 3, and I have set 2 which has 3, 4, 5. Now if you see in this particular case, if I try to union or put both the sets together, set 1, and union is done using the pipe symbol, so I'm saying set 1 pipe set 2. In this case, let's look at the output. First I'll clear it out and then run it again. 1, 2, 3, 4, 5. What happened when I unioned them? It took both of them, put them together, but since there is 3 that is duplicate, it used 3 only once. 1, 2, 3, 4, 5. That's what union is. Next that we want to talk about is intersection, which is intersection between 2 different sets. So in that particular case, you can use the and sign, something like this. Now the intersection between these 2 sets is 1, 2 doesn't exist, but 3 exists in both of them. So 3 is the intersection point. So if I run it, I get only a set with value 3. So that's intersection. Next, we talk about difference. Difference is from first set, what is difference as compared to the second one? That is done by using the minus symbol. Now look at the first set and the second set. The second set will only check the difference for what is there, not there in set 2. So that is 1 and 2. So this will give me difference of set 1 and set 2, which is 1 and 2. So if I run this, there you go, I have an output which is 1, 2. So that's the difference between set 1 and set 2. So we created union using the pipe, we created the intersection using and we created difference using minus. So that those are basic set operations that we have available. I'm going to comment this out, save it, close it, because next we're going to jump into our hands-on exercise. Our exercise 1 is to manipulate data in a dictionary. The objective here is practice adding, removing, and modifying key value pairs in a dictionary. So, first, what we'll do is we'll create a dictionary to store information about a person. We'll perform different operations like adding a new key value pair for the person's address. Then we'll modify the age key to update their age, and we'll remove the grade key if it exists. So let's go ahead, create a new file, call it a Python file, save it inside day 4, call it exercise 1. And here, first I'm going to create that person key value pair. Name is Alice. Next, I'm going to say the age of this person is 25. Next, I want to give a grade, and the grade is A grade. So this is my person. Now, the first thing that I want to do is add new key value pair. So as I mentioned, first thing that I want to do is add an address. So I'll say person address equal to 123 Main Street. So that's the address for Alice. Next, I want to update her age. So I'm going to say update age. So I am going to say person age from 25. I'm going to change her age to 32. Next, if there's any grade, I want to remove those grades from the user. So I am going to check if grade is a different way of doing it in person. So it's checking if the key exists with grade. What do I want to do? I want to delete person grade. So next I am going to say, so once I'm done with deleting this, let's print this person out. So that kind of completes our entire exercise, where we have created a dictionary with 3 keys with their values, and we added a new key value pair address to this person. We updated the age of Alice to 32 from 25, and then we saw if there's grade that is existing, we removed it from there. We can print this here first to check, and then after our operations, let's check it again. So let's go ahead, clear this out, and say Python exercise1.py, and there you go. Before, we have name Alice, age 25, grade A. Then we added address 123 Main Street, so it's there. We updated the age from 25 to 32, so that's there. And then we removed grade if it exists. So we removed that grade here. So that's our grade exercise 1. If you had any issues or problems, let me know and I'll get back to you. And let's get to exercise 2, which is word frequency counter. The objective here is to write a program that takes a sentence and returns a dictionary with the frequency count of each word. So what we'll do is we'll take a user input for a sentence here, then we'll split the sentence into words, and then we'll count the occurrence of each word and store the counts in a dictionary. So let's go ahead and you can follow along. If you had any problems, let me know in between, but I'm going to start with exercise 2.py, and here first let's take an sentence as input from our user. I'm going to say enter a sentence to the user, let them enter, give us the input. Then I want to, let's write this down, split the sentence into words. Now that can be done by creating an first a parameter, a variable words, which is a list. Now to this list, I'm going to call the split function. So what this does is split function. It will take a particular sentence and split it and put it inside this words list. So that's what it will do. Next, let's initialize a dictionary. Initialize a empty dictionary. To do that, I am going to say word underscore count equal to empty dictionary. Next, now I want to count the word frequency. So to do that, I am going to say for word in our words list. So I'm going to go through each and every word, and I'm going to say word equal to word dot lower, because the user might have entered the same word. For example, I can say uh, AI in capital or AI in small couple of times, and then it would take them as two different words. So I'm converting to lowercase for case insensitivity here. Next, I'm going to check if word in word underscore count. So I'm checking if this word has been counted before. If it has been counted before, I am going to say word underscore count for that particular word. I want to increment the number to 1. Else, I'm going to say word underscore count for this new word that we came across. I am going to say equal to 1, and that's it. So let's go ahead and print our word count at the end of it. So there you go. So we have our code ready here. Let's run it and play with it. So I am going to clear this out. Python exercise 2.py, enter a sentence. So I'm going to say the AI engineer is the future. So it says the comes twice because one with capitalized, one without capitalized. AI once, engineer once, is once, and future once. Let's give a bigger one. So I said the AI engineer is the engineer of the future who would work on different AI projects and build amazing tools. Okay, there's some typos, but that's fine. So the is 3 times, AI is twice, engineer is twice. As you can see from here, it picked those things and then gave me a word count array here, a word count dictionary, which is what we wanted to do. So now we have our word frequency counter built here. I hope you were able to follow along. If you had any issues or problems, let me know and I'll get back to you. Next, for some additional practice, I recommend you can write a program to reverse a list of and remove duplicates using a set. Then another thing that you can do is create a program that stores student grades in a dictionary and calculates the average grade. Try it out and let me know if you can get that working. Now, to summarize, on day 4, we did some hands-on experience working with Python built-in data structures, understanding their properties and performing operations on them. The hands-on exercises ensured practical application, building a strong foundation for handling and organizing data effectively in our AI projects. So let me know if you had any problems or issues and I'll get back to you. Day 5, working with strings. First, we are going to cover string manipulation today. We are going to look at first thing, which is concatenation. Concatenation is process of combining multiple strings using the plus operator or the join method. We have used the plus operator a couple of times earlier, but let's go ahead and look at how it looks like. So I'm going to create a new Python file. I'm going to save this inside my week 1 day 5 and call it day 5 underscore strings. Now here I can create a string first, which is, let's call it hello, and then I'm going to create another variable string which is world. Now if I want to concatenate these two together, I can say result equal to first plus, I want to space between them, so I'm going to say space, empty space, and second. Now this, when I print it out, I will see hello space world. Now to run it, I'm going to clear this out, cd dot dot slash day 5, and I have my day 5 strings here. I'm going to say Python day 5 strings. I think I spelled Python wrong. Go again, and it says hello world, which is output of this. So this is how you can combine multiple strings using the plus operator in this particular case. Next, We're going to look at slicing. Now, slicing is the process of extracting parts of a string using indices. Now, we have done this with lists earlier, but let's look at how we can do this using, so I'm going to just comment this out, and how we can do it for strings. So I'm going to create a text variable and call it Python programming. Now, I want to just print Python in this case. So I can say from text, I want to see from index 0 up till 6. So 0, 1, 2, 3, 4, 5. I don't want a sixth one. So that's why I said 0 to 6, not the sixth one. You can also have specify that you want to see programming by saying dash minus 11 colon to the end of the space. So what it does is, in this particular case, it's going to go until the 11th negative and then print the rest of the characters. So let's go ahead and run this. I'm going to clear this out, and you'll see for this one it was Python, and for this 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. So this is minus 11 index and until the end of it. So that's why it's giving me programming. So next, let's look at formatting. You can use the f strings or format for dynamic string creation. We already used the f string bunch of times, which is, let's go ahead, and what I'm going to do is I'm going to create a string called as name as Alice and age equal to 25. Now I can use the f string, which is the format string f, and I can say my name is, inside this specify name, so the curly brackets are used for variables, and I am age years old. So this is a sentence that I create. Now if I run it, I get my name is Alice and I am 25 years old. So this is very important or very key formatting technique that we use while working with strings. So make sure that you get used to this, and we'll be using quite a lot as and when we progress through our bootcamp. Next, let's look at common string methods. We have split, which splits a string into a list based on a delimiter. So you can specify, like if you don't specify anything, it will use default delimiter is space. But if you specify a particular delimiter like pipe or comma for CSV files, you can use those and split a particular string and put it inside a list of items. We also have join, which joins elements of a list into a single string. And we have replace, which replaces a substring with another one. And another one that we want to look at is strip. This removes white spaces or specified characters from the beginning and end of a string. So let's go ahead and play with these one time. So I'm going to go ahead and delete everything. And first, let's start with split, which is split something like this. Now, if I have a sentence, so for example, sentence equal to Python is fun. Now, I want to split these based on the spaces that it has. You can say sentence dot split, and as I mentioned, default is space. So when I print the words here, clear it out, it's a Python is fun. So it created a list with each one of them based on the space here. Now if I had a comma here, I can specify that comma is my delimiter. So give me the same thing, Python is fun, and uses that as a delimiter. Next that I want to show is join. So that is join. This is the function which joins elements of a list into a single string. So to do that, for example, now whatever words I have here, which is Python is fun, let's move it back to the original one so it looks simplistic. So I have this words here. Now if I want to join it into a sentence, I'm going to say sentence or say new sentence equal to, say space, and I'm going to say join words, and let's print it out. So I'm going to say print new sentence. go ahead, run it. So Python is fun. It took that entire thing and joined the words together using space, because that's what I've created here, and it created this. If I give pipe, say Python pipe is pipe fun. So that's how you can use this join, which again joins elements of list into a single string. Next thing that we want to look at is replace, which replaces a substring with another. So let's create a new one. I am going to comment this print, and I am going to create a text which says I love, let's say, Java. And then I'm going to create another variable, updated text, and you probably already figured out what I want to replace. What do I want to replace? I want to replace Java with Python. Now think about it, you have a book on Java and you replace everything that says Java in there with Python. It becomes Java programming to Python programming. Will that not be easy? But again, Python is much more easier. That's why I love Python. Now let's print that out. Updated text. So if I run this, I have I love Python instead of I love Java, because Java got replaced by Python. Similarly, the last one that we're going to talk about is strip, which removes white spaces or specified characters from the beginning and end of the string. So for example, let's say I have a messy string here, which is space, 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 hello, comma, space, world, and I have space, 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 space at the end of it. Now I can say cleaned text equal to, I can give that messy dot strip. Now by default it will remove all the spaces from front and back, so I'm going to say print me the clean text, run it, and there you go, I have hello world. I'm going to comment this just so that we just see hello world here. So all the space has been removed. If I just, what if I just print messy first just to see the difference? You see, there you go. This is my messy string which has space in front and back, and this is my cleaned up string which has no spaces in front and back. So that's how strip works. Next thing that we want to talk about is regular expressions for pattern matching. Now this is very interesting and is used quite a lot. If you have done any bit of programming, you know how important regular expressions are. Now what are regular expressions? It's a way to search, match, and manipulate text based on patterns. For example, email is a particular pattern where you look for text in the start, at the rate sign, and a domain name dot something com or AI or org or anything at the end. So it's a particular pattern that you're following. So it's helpful to search and match and also manipulate text based on particular patterns. That's where we use regular expression. The thing that we use, there's a module available. It's called the RE module or regular expression module. We import the regular expression module for regex operations. The way to do it is something similar to math that we've done before, where you can just say import RE. There you go. That's our module that we would want to import when we are using regular expressions. Some of the common functions that are available in the regular expressions are, one is re.search, where you give the pattern and the string. So what it does is it searches for a pattern in that particular string. So if you have like a big huge document full of string and you want to find emails in that particular string, so you can give a pattern saying that I'm looking for email style pattern inside that string and pass it there, and it will give you. Another thing that we have is find all, which actually finds all the patterns, all the occurrences of a particular pattern. In the first case, it will get you the first one, but find all will list you all the occurrences of that particular pattern. Next, we have re.sub, which is substitute, which means it replaces occurrences of a particular pattern. So let's try out some examples where we can use the regular expressions. So I'm going to go ahead and create a new file. I'm going to call it day5 underscore regex.py. Here first, as I mentioned, we need to import RE, which is our module for regular expressions. Now I want to create a string here which says contact me at 123 456 7890. That's my phone number. So what I'm going to do is I'm trying to find all the digits in a particular string. To do that, I can just say digits equal to re dot, as I mentioned, find all is the function. And here I'm going to say the regex that I'm trying to look for. This is the pattern slash d, which is digits more than once. If it appears, just display me those. And inside my text, so print digits. So what it will do is it will try to look for digits, either one or more than one, because I've said plus here. So 1, 2, 3, let's say 4, 5, 6, and then 7, 8, 9, 0, because there's dash in between them. That's why it will separate them out. So I am going to go here, clear this out, and I'll say Python day5 underscore regex, and there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that found me all the digits that are there: 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0. Those are the digits they found. Now what if I want to replace all the digits with x for security purposes? So I can say updated underscore text equal to re, as I mentioned, sub, which substitutes the numbers. Now I'll have to first give the pattern. I can say r wherever there's a digit. Now in this case I'm not going to say plus, because if I say plus it will replace 1, 2, 3 as a single x, but I want every single digit. So 1 is one digit, 2 is one digit, 3 is one digit. That's what I want to do. So I'm not giving the plus sign. So, and then I'll say that I want to replace with x, and what is my text? This is the text that I want to do it on, and I'm going to say print updated text. So you can probably see what is the use case for this. To hide for privacy reasons, you want to hide your email or phone numbers or anything that you have in the text. I run it, you see contact me at xxx-xxx-xxxx. At least I know it's in the right format of a telephone number, and it's been replaced by x wherever there is a digit in here. So try to play around with different functions like these, all the different patterns that are available, and let me know if you are able to do something. Next, let's jump into our hands-on exercise. First, we will create a text cleaner. The objective here is to write a program that removes unwanted characters, example, punctuation, extra spaces from a particular string. So what we'll do is we'll take a string as input from the user, and then we'll remove the punctuation, extra spaces, and convert the text to all lowercase. So let's start with the project of our exercise 1 for day 5. I'm going to save it as exercise1.py, and here I would need, of course, regular expressions to do the substitutions, and I'm going to create a function called as clean the text, and whatever text is provided here. Now first, as I mentioned, I want to remove punctuation. For that, I will first say from the text, I want to create a new variable text, and I want to substitute. Now in this case, I'll use r. Now for punctuations, I will use the square bracket, and I'll use the or here and say dash w dash s, so spaces. And so in here, if you see this, it says returns the string obtained by replacing the leftmost non-overlapping occurrences of the pattern in a string, the replacement repl. So that's what this does. So I am going to go ahead and say replace those with an empty string, and for operations, this is the text that I want to operate on. So it removes all the punctuations from our text that is there. Next, I want to remove extra spaces. Now for removing spaces, I'm going to say text equal to, wherever there is space, join text dot split. So this will split my entire text, remove all the spaces, and then join them with spaces just to clean it up. And finally, I will say convert to lowercase. So this will return my text that I've created call the lower function. That is a built-in function that converts the text into lower, and that's what will be returned. Now let's, instead of asking user, let's create a input text here, but you can ask the user for a text too. You already know how to do it. Give some space, hello world, and then I'll put some exclamation marks here. Welcome to Python, comma, programming, dot, 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 space, some more spaces, and I'll say clean text or cleaned text equal to, call the function clean text, and to it pass this input text, and then I'll say print cleaned text is cleaned text. So print this out. So let's run this and let's hope that it shows me hello world, welcome to Python programming, all in lowercase and without any punctuations and spaces. So I am going to run this. Clear. The name of the file is exercise1. So I say Python exercise1.py, and there you go. Hello world, welcome to Python programming. So it got me the entire thing all lowercase and cleaned up the entire text for me. Perfect. So next thing that I want to do is exercise 2, which is check if a string is a palindrome. And a palindrome is a word, a phrase, or sequence that reads the same backward as well as forward. For example, madam, M-A-D-A-M, which reads same from front or back. So that's a palindrome. So, or another example that I can give you is if it's a, let's say a sentence says a man, a plan, a canal, Panama. That is actually a palindrome because the other way is also reads the same thing. A man, a plan, a canal, a Panama. So let's go ahead and create a new file for this. I'll call it exercise. Instead of 1, I'll call it 2. And here I'm going to check first is, so this function is going to check is palindrome, and it needs an input parameter as a text. And here first I'm going to remove all the non-alphanumeric characters and convert to lowercase. To do it in one single line, you can do something like this: dot join character dot lower for character in the text that is passed if character dot is alphanumerical. So this goes through the entire text and then converts them, removes all the non-alphanumeric characters and converts everything to lowercase. Next thing I'll do is return text equal to text colon colon -1. What this does is this checks if the text is equal to its reverse, and if it is, then it's going to say true. If it's not, it's going to say false. So this, by saying this text colon colon -11, is going to reverse the text and check if both of them look exactly same. So even if it's like madam versus a man, a plan, canal, Panama, it will remove all the commas and remove the spaces and make sure that it's exactly the same strings front or back. So that's what it does. So now let's create input underscore text here. I'm going to ask the user to enter in this particular case, so we can try a bunch of different ones. The string if is palindrome, whatever my input text is that user provided, I am going to say print. I need to display that, so I am going to use this, put those under quotes and pass the input text. I'm going to say is a palindrome, and if not, I will use else. You got it right. Else I'll say print is not a palindrome. So let's try it out. Go ahead, clear everything, and say Python exercise2.py. So first one, let's keep it simple. Madam is a palindrome. I'll say Madden. Oh, sorry. Python XSS2 MADAN is not a palindrome because it doesn't read the same. Next one is, as I mentioned, a man. Oops, sorry. Run this function first. A man, a plan, a canal. I want to make sure that I don't do any Panama. So if you see a man, a plan, a canal, PANAMA. So run it. Is a palindrome because if you read it out, if you remove all the commas and spaces, and if you read it out, it's exactly the same read from front versus its reverse. So there you go. So we have our code here, which checks if a string is palindrome. If you were able to do both these exercises, that's good. If not, if you had any issues or problems, let me know in my messages and I'll check them and get back to you. And for some additional practice, you can try to write a program to count the number of vowels in a string. Try that out. Next, you can create a program to find and replace all email addresses in a text using regex. So, and for regex help, you can always go online, just search for regex expressions or regex creators, and you'll find some regex creators online where you can test it out and then use it in your code. And today we have one more, which is write a program to reverse the word in a sentence, not the letters, the words in a sentence. So try that out and let me know if you have any problems. So just to summarize, on day 5, we did some practical experience in working with string, mastering common methods, and learning to use regular expressions for text processing tasks. Now, these skills are essential for natural language processing (NLP), and that's why we went through these, and also for data cleaning in AI applications. If you had any issues or problems, let me know right now because these are the basic foundational things for functions that we need to do for NLP and data cleaning in AI. Welcome to day 6. Today we are going to cover file handling. Now, specifically, file handling in Python is much more easier with all the functions that are available. We will start with reading and writing text files. First thing here, we want to look at opening files. Now, to open files, you can use the built-in open function to open a particular file. Now, when you open a file, usually you have to specify read, write, or you want to append something, or read and write, both modes that you have to particularly specify here. So we have different modes. The default mode is read, which you can also specify by the letter R. We have the write mode, which overrides the file if it already exists, which you can use the W keyword. We have append, which adds data to the end of the file. You can use A for that. And finally, we have read and write, which is R plus, which you can use if you want to read and write a particular file after you open it. So this was about opening files. How about reading files? So when you want to read a file, you can use the .read to read the entire file content. But if you want to just read one line at a time, you can use the .read line function. And what if you want to read all the lines? So you can use read lines. What it does is it gets all the lines and gives you a list of the entire item. If you want to see an example of how this works, I'm going to create a new file here and save it inside my day 6. I'm going to call it day 6 samples. Here, I'm going to start with something called as a with statement, which we'll talk about in a little while. But to open a file, I say open and I give the name of the file. Let's say sample.txt. That's the name of the file. Now you have to specify here, as I mentioned earlier, the different modes for opening a file is either read or write or append or read and write. So these are different operations. This is the default one. If you don't specify this, it will use read. And I'm going to say read this as a file. So this will be my file that has all the contents of whatever I've opened here. And then I'll say content. I want to get that content. I'm going to say file dot read. So once I open the file as a file, I am going to take that file and then read it. Now this will read, as I mentioned,
the entire file content into one single variable, which is content. And you can just say print content here. Now, what if you want to read only one line? You can just say read line. Now, the thing with read line is it's always used with a loop where you loop through each line at a time and do process the content. But sometimes you just want to read the first line or one line, then you just use read line. Also, we have read lines, which will give a list. So, this content will be a list of each and every line that this file has. So, that's how you use open and read. Now let's go ahead and look at writing to files. Now to write to files, you use the function .write, which writes a string to a particular file. You can use write lines to write multiple lines from a list. So if you have a list of items and you want to write them to a particular file, you can just say write lines and it will take each and every item and write to a particular file. So the way to do this is you specify that you want to write to a file, and here instead of this, I'm going to comment this out. I'm going to say file that I have, object that I have. I'm going to write to it, and I want to write something like hello world. Okay, so that's what I want to write. Now, if I want to write multiple lines, I can just say file, as I mentioned, dot write lines, and here I give a array of items. I'm going to say Alice, Bob, and Cherry, something like that. So this will take this list of items and write these in different lines inside a particular file. That's how write lines work and write works. So next, let's look at using with statements for file management. We already used it, but how does it work? And first of all, what is the with statement? Now this ensures that files that you've opened are properly closed after the operations, even if an exception occurs. So make sure that something is not going right and your program crashes, it will make sure that the file is still properly saved and secured, and you don't lose the content that you're working on. So that's what with statement does. The syntax for this is, I can just continue here and specify with. So as I mentioned here, with, and then you say open a particular file, which we have done already here. So as a particular file, so what this does is at the end of it here, file is automatically closed. So this will make sure that the file that you opened, in this case our sample.txt file, is automatically closed, and you don't have to worry about closing it. In some programming languages, you'll probably have to close an open file, but in Python, if you use with, you don't have to close it specifically. So what are the advantages of using this particular with? As I mentioned, it ensures files are properly closed after operations, even if an exception occurs. The advantages includes it simplifies the code, making it much easier. You don't have to remember to close the file, and also it reduces the risk of file corruption. So if you have a file open and operations are going on and things are happening, it might corrupt a particular file. So making sure that every time, and no matter what programming language you use, you open a file, you have to close it. So that's what it make sure of. So that's why always using with is a very good best practice. Next, we're going to look at basic exception handling for file operations. Why use exception handling? What it does is it prevents the program from crashing due to file related errors. Example, file not found, or there is a file issue, file is corrupt, or file has some problems, or it is not readable by that particular user. So there can be a bunch of different problems, may it access related, or maybe the file is not there. So having exception handling helps you make sure that your code doesn't crash and moves to the next line or exits gracefully depending on what you're trying to do. So that's why exception handling is important. We use something called as the try except blocks. So let's jump into how to use the try except block. So I am going to quickly write some code here. I said try, this is how you start with, and then inside here you start with and open the file. So for example, sample.txt file I want to open. I want to open it in read mode, as file, and I'm going to take the content from that file and say file dot read. I'm going to comment all these things here because I think it got messed up. So I am going to say comment or just get rid of it. And here file dot read. Now if this doesn't work out, if it breaks, I have to do exception handling for except file not found error. If the file was not found, because there is no file called as sample.txt, so it will crash in our case. So that's why exception handling here helps. And I'm going to give an error to my user saying file not found, something like this. So what happens in this case is I'm trying to open this file, but if the file doesn't exist, I don't want this application to crash. I want to just print a message saying file not found. So some of the common file not or common file handling exceptions include, we have file not found error, which we just saw, where the file does not exist. We sometimes look for permission error, where the user doesn't have sufficient permissions to access the particular file. And then finally, also the IO error, where general input output errors, where you look for all kinds of editing permissions or input output errors. So that's what we look in IO error. So now that we understand how to open the file, read a file, go through a file, do exception handling, let's jump into some hands-on exercise. Our first exercise today is to count the words and lines in a particular file. So the objective here is to write a program to read a text file and output the number of words and lines. So the instructions that I would probably follow here will be open the file in read mode first, because we don't have to write something, we just have to count the lines. Then we count the number of lines using a loop. And then finally, we'll count the number of words in each line using the split function that you used before. So let's go ahead and write some code. Now open a new file. I'm going to save it as day 6 exercise 1.py. Now here, first, let's write the function. So I'm going to say, I always start with the function. The reason is it's always helpful to reuse this somewhere else if I need this in future. So I'm going to say count words and lines, and I'll pass it a file name. Now first thing is start always with the try except block. So I'm going to say try, and I'm going to say with open the file. I'll use that file name that is passed to me, and I'm going to say this is in read only mode, and take that and assign it to this variable file. So my file is available now. Next, I'm going to say lines equal to file dot read lines. This is how I can read all the lines into a list of items. So lines will be a list of items with all the lines in there. Next, I'm going to say line underscore count. So I'm going to count the lines, which is using the length function len, and then say how many lines are there in this particular, or how many list of items are there inside this. So that's what I'll get here. Next, I'm going to say word underscore count. So I need to get the word count. So this is sum of length of line dot split. I'm going to explain you in a second of what I'm doing here for line in lines. So what I'm going to do here is I am writing a for loop where I'm going through each and every line inside the lines list. So I'm going each and every item inside this lines, and I'm saying split that into based on spaces. So that will give me words. So this will give me the number of words that are there. And then finally, I'm summing all of them up to get the total word count. So next step is I'll say print f or f outside number of lines equal to line count. Use something similar, but this time I'll say number of words in there is word count. Now next I will get outside in of the try and write the except file not found. So this file I have not created yet. So this should, if I run this statement or run this code, it will just say file not found. So I'm going to say printf file, specify what the file name is, not found. So that's the error that I'll give the user. So let's write here outside some code to run this function. So I'm going to say count words and lines, and I'm going to give a file called as sample.txt. If you look at my, let's say, open this particular folder where we have day 6 code, but there's no sample.txt file here. So if I run this code, let's go ahead here and then clear it out. Say Python day 6 exercise 1 py file sample.txt not found, because there is no file inside here that's called sample.txt. So let's create one. So create one, save it as sample.txt, and here I'm going to say hello world, how are you, what is the plan for today, are you working on AI technologies. So just some basic 4 lines of text. Now let's go ahead and run this, and it says number of lines is 4. So 1 2 3 4. Number of words is 17. So if you count these words 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So it did count the words and the lines and displayed out to you. So this is what we are expecting for our first exercise. So I hope you were able to follow along. If not, if you had any issues, let me know. Now let's look at our second exercise. Our second exercise is to write and read a list of items. So the objective here is to create a program that writes a list of items to a particular file, then reads it back and displays the content. So what we will be doing first is we'll write a list of items to a file, each on a new line, and then we'll read the file and display it content. So which means we'll have to write a couple of functions, one to write and one to read. So let's start with our exercise 2. Create a new file, save it as day 6 exercise 2.py. Here, let's, as I mentioned, the first step is to write items to file, and then I want to know what is the file name where I want to save this or where I want to write, and what are the items that you want to write. Inside this function, I'm going to first say, I'm not using the try except, but it's a good practice to always use that. I'm just going to keep it simple and straightforward for now. Let's say file name write as file, and then I'm going to say for item, for each and every item that is passed in the items list that we have, I am going to say file dot write, not write lines. But we can use directly write lines and use this, but I'm just going to show you how to use this for loop. Item plus, I'm going to also do new line here, so /n. So based on whatever we get, I want to write that line and then go to a new line. Next, our next function that I mentioned was to read items from file and then pass the file name. So as you saw here, I didn't use the try except because I have full access to this OS and I don't have to worry about any of the exceptions. But sometimes you might have to, because what if you don't have the permission or access? But for read, I don't know if the file is available or not. So that's why I am going to use the try except. Open file name, comma, I want to do it in the read mode as file, so I get the contents of this file inside this file. Say items equal to file dot, I want to read all the lines, I'm not going to do one at a time but all of them together, and then I'll print saying items in the file are for item in items. So since I have all the items in there, I'm gonna loop through each one of them and print each item at a time. But I'll also strip those items if there's any spaces or anything, so I don't have to worry about that. And then finally my except block here, which is only for file not found. I'm not looking for any other errors because I know that I have permissions, I have no input IO error operations. But again, when production code, you should try to catch all the exceptions that are there. File name, make sure no typos there, not found. Okay, that's perfect. Now next thing is to test the functions. So I'm going to create an items array, call it apple, banana, or call it fruits. Then we have cherry and let's say dates. Just for consistency, make sure everything is capital here. And then first I'll write to a file. So I'm going to say write items to a file. Now this doesn't exist. I'm going to call it fruits.txt. This file doesn't exist. If you see here, there is no fruits.txt. I'm going to clear it out. And to this, so write to file needs two parameters. One is the name of the file and the other one is the items, which is my fruits. So that's once I've given that. Now next I want to read items from the file, and the file name that is same as this. There you go, perfect. If I change this name to let's say items.txt, let's see what happens just for the fun of it. Now go ahead. Again, ls, there's no file that says fruits.txt right now. There's no items.txt either. So now when I run this Python, I'm going to call it, what is the name, day6 underscore exercise 2.py, and it says file items not found. So it was not able to find that. Why? Because the name is fruits. But if I ls here, you'll see I already have the fruits.txt file. So that file got created, and I'm very sure if I open it, it will show me the fruits that I've added. But I am going to not run it that way. I'm going to use my code. And if you see items in the file, apple, banana, cherry, and dates. And that's the fruits file here. I can always go ahead, open dot, and open this file and see it has these 4 items that I've added. So you can add more items. So think of it as like if you want to build something where you're caching items to your local direct your user's local computer, you can call a API, get the weather for 100 countries or 100 cities, save it locally and show that throughout the day. So then the user doesn't have to call a particular API again and again for something. So that's where it can be helpful. Now in this particular case, think of it as like if you're making an application where you are displaying different types of recipes. Now you don't want to download the recipes from the website again and again. So you do it once, save it on the local machine, and then let the user see it. So I hope you were able to work with this project and follow along. If not, let me know. But there's some additional work that I can give you for practice. First, try to write a program to copy the contents of one file to another. So you create a file, add some data there, read the contents of that particular file. First open the file, read the contents, and then write to another file. Next, create a program that counts the number of occurrences of a specific word in a text, more like a search engine. Create a file where you add a bunch of text inside it and then search for a particular text and see how many times it occurred. Next, write a program to log messages with timestamps into a file. So this is a little bit different where we have not looked at how to write timestamps, but you can use some Python built-in functions, and I'll let you do the research of how to get the current time. So what you're going to do is ask users some input, and then when the user enters something on the command prompt, save them as a log message inside a particular file and also put the time when the user entered that, and then run a while loop through it and constantly log these messages. So to recap, today we learned the essential file handling techniques in Python, including reading and writing files, managing files with using with statements, and handling exceptions gracefully. These skills are vital for data processing tasks in the AI and beyond. So we'll probably be using this quite a lot. Let me know if you have any questions or any problems, and I'll get back to you. Day 7, Pythonic code and project work. Today, we're going to cover different topics, including writing clean Pythonic code. Now, what is Pythonic code? Pythonic code adheres to the best practices and idiomatic expressions in Python. It focuses on simplicity, readability, and leveraging Python's built in features. So, when you're writing code, you have to make sure that you write something where you have to ask yourself, will I understand what I'm writing if I come back after a year? So this helps with sharing the code with your peers, with other friends, with online, anyone. So if you can understand your code after a year, I feel like anybody can understand it. But again, focus on simplicity, readability, and leveraging Python's built-in features. Some of the best practices that we follow are use of descriptive variable names. As you've seen that we've done, every time you create a variable, make it very descriptive. No matter how long it is or how stupid it sounds like, but it's always good to use descriptive variable names. Write modular codes with function and classes. As we've practiced, every time we try to implement some functionality, we start with a function. We write a function, we try to make it modular and make sure that it's more readable. We follow PEP 8 style guidelines. Now, this is a Python related guidelines which you can look it up, but what it says is all about writing code that is very simple, that is easy to read, and using most of the Python's built-in features. Avoid redundancy. Leverage Python's powerful built-ins. So make sure that if you are writing something over and over again, try to use functions, and also remember that Python has a bunch of built-in functions available. So if you're trying to write something, for example, getting time or trying to split a particular string into different characters, this functions that are available by Python, use those. Don't rewrite all these functionalities. Let's look at list comprehensions. So what are list comprehensions? It's a concise way to create lists using a single line of code. What do I mean by that? Let's look at the syntax and some examples. So I'm going to start with an empty file, save it in our day 7. I'm going to call it day 7 underscore samples. And inside here, let's look at the syntax for list comprehensions. So you write your expression, and we have used it a couple of times before. And for each and every item in the iterable, use if condition. So if condition is satisfied for item in iterable, then the expression follows along. Now this is a little bit difficult to understand. So let's look at some examples. So first, let's create a list of squares. To do that, I can say squares equal to x square root of 2 for x in range of 10. So what this will do is it will give me squares for each and every item from starting from 0 to 9, because range goes from 0 to 9. So x square of 2, what it does is it will go to the first item. So if I print this out just to test it out, I can say squares, go to my terminal. Let me make sure I have this code, Python day 7 samples. And if you see, it took the first number in range 0, and 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, and so on. So that's what this gave you. But you wrote that in one single line as a list comprehension, then to kind of create iterable for multiple lines here. So this is something that you should probably get used to. Another thing I can do is let's filter even numbers. To do that, I am going to say evens equal to x for x in range of 10 if x mod 2 equal to 0. So what it does is it goes from each and every number in this range and checks the expression if x mod 2 equal to 0, then which means it's an even number. So I can just go ahead and print evens here. Let's run this, and you have here, this is the first is the squares, the second one is the even numbers. Now I can give it all the way till 100, make sure this is commented, run it, and you'll see all the even numbers from 0 to 100. Similarly, you can do odd numbers just by saying not equal to 0, and there you go, you have the odd numbers here. So this is how you can create list comprehensions where you're consolidating multiple lines into one single line. So that's how list comprehensions work. Next, let's look at lambda functions. Now, what are lambda functions? These are anonymous single expression functions defined using the lambda keyword. It's used in a lot of programming languages, or also called as anonymous functions or lambda somewhere else, but in Python is used the lambda keyword. So these again are anonymous single expression functions defined using the lambda keyword. So let's look at some syntax and examples for lambda functions. So I'm going to go ahead here, comment this out, and in here, first, let's look at the syntax. The way it goes is you say lambda, and then give your arguments. So it's like giving a function, but you don't have to give the name of this particular function. That's what's called anonymous. You just give the arguments and the expression. So for example, if I'm writing a function, I'm going to say the function name, and then give the arguments here, and then my expression or my function code inside here. But think of it as it doesn't have a name, just the arguments and the expressions next to it. So let's look at some examples. I'm going to say add lambda x and y. These are my two arguments, and I'm going to say x plus y. Usually you would create a function and then put this inside the curly brackets, and these are the arguments, but using lambda you can put everything in one single line. And I can say print add and give the arguments 3 comma 5. So it looks like as you can see, it looks like a function. And what does it output? Let's go ahead and see if it works. 8. 3 plus 5, 8. It passes these values as 3 and 5 here and runs this expression here and gives the output to here. So it's inline functions, anonymous functions, whatever you want to call it. That's what lambda is. Let's next look at some of the very common functions that we'll be using quite a lot. So we have map, filter, and reduce. First, map applies a function to each item in an iterable. So it keeps on looping through iterable item and applies the function to it. What do I mean by that? Let's look at an example. So I'm going to go here, I'm going to go to the top of this and create a list of items called as numbers 1, 2, 3, and 4. So this is my list of items. And next, I am going to say squares equal to map lambda. So I'm creating a function here, anonymous function, and I'm saying x times 2 comma numbers. So what I'm doing is I am taking this list of items and I'm saying that I want to run this expression on this particular list of items. I'm mapping it to it. So that's how maps work. So this is the actual function, and this is the argument that is passed as x each item at a time, and it will square the items and give it to me. I can just say print list the squares. If I save it, hope all the print statements are not, and run it, I have 1, 4, 9, and 16. 1, 4, 9, and 16. 1 square, 2 square, 3 square, 4 square. It took each and every number, squared them, and then I see the list output right here. Next that we want to look at is filter. Filter, it reduces or filters items based on a condition. Filter items. Next, let's look at the filter function. It filters items based on a condition. So let's look at an example here. I'm going to comment this out. And here, based on our previous even function, I'm going to say even list equal to filter, and here I'm going to say lambda x, lambda x is the argument, x mod 2 equal to 0. Write it properly, follow the Pythonic coding structure, and pass numbers which I have right here. So I'm going to take this here and put it here. So what it does is it goes through each and every item here and mod that and check if that item is a even number or not, and that is assigned to even list. And I can say print list of evens. When I run this, I think even list, so let's fix this. I have 2 and 4. So out of these, the even numbers are 2 and 4. And that's what filter does. It filters through an item and goes through an array, filters based on the associated lambda that we have provided here, and gives me a list of even numbers. Next, we have reduce. It's from func tools, and it reduces an iterable to a single value. So it takes, like you have an iterable item, it will reduce it to a single number. So what I can do is to use reduce. First, I'll have to, let's keep sure numbers is there. I am to get the module func tools, import. From there I want to import the reduce function. I have my numbers here. I'm going to say product of all these numbers. So if multiplication of all these numbers, I can say reduce. I use a lambda, give x comma y, because there will be two numbers that I want to multiply, x times y for a list which is numbers. So what it does is it takes one number at a time, 1 and 2, or two numbers at a time, pass as arguments here and multiply them, and whatever solution comes out, it will take the next number, do the multiplication, take the next number, do the multiplication, and finally print the product as one single number instead of a list of items. So if I go ahead and run it, I will get the output 24, because 1 times 2 times 3 times 4 is 24. Next, let's look at Python's OS and sys modules. So first, OS module. This provides functions to interact with the operating system itself. Some of the common functions include how to create a new directory, how to remove a particular file, and we can see those examples here. I can just quickly run through it. I am going to go all the way to the top, remove everything, and first, to use the OS module, you have to say import OS. Then I can say print os dot get cwd. This will get you the current working directory that you are in. So it's a function. Also, you can say os dot mk directory. You can create a directory inside there. Let's call it test underscore directory. This will create a new directory called as test directory. You can say os dot remove, and you can delete a particular file. Let's see, what do we have in this particular folder? ls. I don't have any file, so let's create a file. I am going to call this file file.txt and save it there and say test file. Let's make sure it's there. There you go. We have the file.txt file, and that file I am going to remove using this. So let's run it now. I'm going to say Python, and if you see, there's no folders inside this too. Day 7, and let's look at it. So day 7 has a test directory over here, but it doesn't have any files. So what happened to that? It got removed. It got deleted by this os.remove function. And as you can see here, it has the new directory that was created by this mk directory command or function. And then this is also, if you see here, I said get cwd, and as you saw here, it gave me the path users within Rana Desktop AI Bootcamp week 1 day 7. So I'm in this particular folder. So it gave me the current working directory. So this is pretty useful. Next, we have the sys module. This provides access to system specific parameters and functions, like you can get some command line arguments, Python version that you have. So all those options you can get using this system specific sys module. Let's run that and check it out. I am going to remove this. I don't need this anymore. So I'm going to say import sys, that's the module. And then I can say print sys.argv. This will give me the command line arguments. Print sys dot version. Now since I'm using Python, it will give me Python version here. I can run this. Let's clear it out first and then say Python day 7 dot samples, and you see here day 7 dot this is the arguments that was passed, which is the name of the file here, and then it gave me the version. I'm running Python 3.12.7 as per this, and it gives me some details about that depending on what it gives me when I write Python dash version Python 3.12 plus a little bit more details here. So that's what this sys module does. So now that we understand both OS and sys module, there's a lot of different things that we learned to this day. So let's go ahead and put them to use by creating a hands-on project. And this hands-on project will be a command line task manager. We have only one this time, but this is quite a detailed project that we're going to work on. The objective here is to build a command line application to manage tasks using Pythonic practices. So some of the features that we'll be adding to this particular task manager is you can add tasks, you can view all the tasks that are there, you can mark tasks as complete, and you can also delete tasks. So to go step by step, first step is always to plan the structure. We want to store tasks in a dictionary or a text file with unique IDs. And each task has a title and a status which will either be incomplete or complete. So let's go ahead and create a new file. I'm going to close all these other projects. Here, let's save it as, I'm going to just call it day 7 task manager.py. So now that we have named it, as I mentioned, some things that we need first is the OS module. Import OS. I am going to create a file where I'm going to store all the tasks. So I'm going to call it, let's comment it out to file to store tasks. And this file I can give a file name. Let's call it tasks.txt. And then let's load all these tasks from the file. So the reason I'm importing OS is, I'm going to tell you in 1 second, load underscore task. So this, I always like to write comments, load task from file, and inside this function, I am going to say create a dictionary task equal to empty tasks. Now I'm going to check if OS, the module that we imported, dot path dot exists. So it also helps you to check if a particular task exists. File name. So does this file exist is what I'm trying to do here. If it does exist, I'm going to say with open file name, comma, readable file as file. So we already saw how to open files. This is what we've done here. And then for that, I'll say for each line in file. Now this file is called task.txt. So I would assume that each line is a task. So that's what I'm trying to get here, I'm going to say task underscore ID, comma, title, comma, status. These are the three things that we'll save in a task. And these, since they're saved in the file, I'm going to say for each line, strip it, and I'm going to use a special character. I'm going to use pipe. So each so task ID, title, and status will be separated by a pipe. That's how I create my database here. And then I'll say task int of task ID. I'm converting the task ID into int and getting an index, and I'm saying that inside this, the title of this particular task is this, and the status is whatever status we got. So we have this task ID, title, and status. So I'm creating task inside this empty dictionary here, where I'm saying, let's say the first task in there has a title of title, whatever we got from the file. Status is status. So I'm creating my database here. I'm loading all the tasks inside this dictionary here. Once I have done that, I'm going to go here and say return task. If the file doesn't exist, which means there's no task, it will return back an empty dictionary, which is what's going to happen the first time when I run it, because there is no task.txt file right now, as you can see right here. I'm going to delete this folder which we have created in our previous project. So move to trash. Yep. So next is save tasks to file. So as and when user creates a task, I want to save those tasks into that task file. I'm going to say save underscore task with open. So I'll take the file name of the task. I'll say write mode as file. I want to save for task underscore ID, comma, task in tasks dot items. From in this particular task, whatever tasks are there, for each one of them, I want to save them to file. So to do that, I'll say file dot write f. And as I mentioned, how do we write this? I'll say task underscore ID space pipe space the formatting that we've mentioned, task of title space pipe space, and finally task of status. That's my third one. Let me see, everything is closed properly, slash n. I'm also giving a new line character, so it adds one task and goes to the next line and keeps on writing for each and every task that is available. It'll save to the file. So that looks good. Our next thing that we want to do is, so this will save the task. Now what if I want to add new task? Add a new task. I'm going to create another function called as add task and pass the task object. I'll say title equal to input. I'm going to ask the user enter task title. So user will enter a task title for this. Task underscore ID equal to max of tasks dot keys, comma, default equal to 0 plus 1. So what I'm doing here is I am taking the task and looking at the keys and getting the max value from the task. So I'm getting the max ID that is available right now. If doesn't exist, then I'll use the default 0, which means my first ID will be 1. If not, it will, let's say if there's 4 tasks and 1, 2, 3, 4 is the task IDs. So it will get 4 here, 4 plus 1, 5. That will be the new task ID. Next, I'm going to say tasks for that particular task ID. I will have to give the title, which in this case is whatever user entered, which comes from title here, and then status. Since it's just created, I would think of it as incomplete. There you go. So I am going to, at the end of it, I'm going to say f task, whatever the task is, title that user entered. Let's fix this, task title added. So we give this message to the user. Next is, let's write a function to view all the tasks. So def view task, and inside that I'll pass that task checked, and here I'm going to say if not task. What I'm doing here is I'm checking if the task values are there or not. If not, if there's nothing in there, if the array is empty, if the dictionary is empty, I'm going to say if no tasks available. Else, there are some things inside this dictionary. What do? I'm going to say for task underscore id. I'm going to iterate through all of them and get the task id and task in task dot items. So I'm going to go through each and every item inside task and get the task id and task and print that to our user. I'll say, let's say bracket, and inside this I'll say task underscore id. So we'll give that id inside a bracket and say task, whatever the title is, and task, I'll have to provide the status. So I'll say status is this. So that's what I'm printing it out to the user if they want to view all the tasks. Now next, from whatever we have done, okay, so these are incomplete. So let's say we want to change mark the task as complete. So this is mark task as complete from incomplete status. So I'm going to say define mark task complete function. It takes the array of tasks. Now first thing I'll have to do is I'll have to get the task id for which I want to change it. So I'm going to say task id equal to int input. I'm going to ask the user enter task id to mark as complete. I'm going to ask the user. Now we are displaying the task id, so I'm going to ask the user which one do you want to mark as complete that you've completed. And if first I'll check task underscore id in task, if it exists in that task object, what I'm going to do is I'm going to say task id. I'm going to get that item, and to that status I am going to mark as complete. So if it was incomplete when it was created, now it's complete. So that's good. I'm going to say print, just to display a message to the user, task id, whatever the title of that is, and it closes here, marked as complete. That's what I'm going to say to user, and that will be displayed to the user. Oh, wrong place. Okay, we also have else. What if the task doesn't exist? I'm just going to say print task id not found. So they can view, you call view all task and check if the task is there or not. Next thing, our main, we forgot to delete, I guess, in this case. So we have, which mentioned we are also going to add delete. So I'm going to say delete a task. It will be something similar to this. So I'm going to just copy that up here, and I am going to say delete task, and I'm going to get the id enter task ID to delete. Task ID in task, I'm not going to mark this deleted underscore task equal to tasks dot, I'll just pop it depending on the task ID. There you go. So that will delete it. So then I can say task deleted, else ID not found. Perfect. Our next step is the main menu, which will display all the options for our user. So I'll call it def main, and inside my main function I'll probably first say task equal to load task, and I want to see get all the tasks as soon as the program runs. I'll say while true. If you remember while loops, it will keep on running until the user specifically says exit. I'm going to give the user some access. First I'll say /n, next line, task manager menu. That's my first. Next I'm going to say print. First option that I want to give user is add a task. Okay. Next option that I want to give user is view all the tasks. Next option that we want to give 3 is, we said add view mark task as complete. Mark task as complete. Next option that I want to give user is the fourth one. Let's delete a task. And next one that I want to give user, the fifth one, is to exit out of this program. Print 5, exit. 1 2 3 4 5. So I have all my 5 options. Now let's get user's choice equal to input. Enter your choice. So we're asking the user to enter something, and now we'll run through all those. If choice equal to 1, what do I want to do? I want to add a particular task to the tasks. Okay, perfect. Add task. Next one, else if the choice equal to, let's say, the user type 2. In this particular case, I want to view task, so I can just say view task and pass the task object to it. Next, looks like there might be a problem in the code, but let's see as and when we run this. 3, if the user picks 3, I'm going to say mark task complete. Now for that I'll also give task because everything happens inside there. Next option is if the user picks 4, that is to delete tasks, so I'm going to say delete task. Perfect. Next thing that I want to do, delete task, if the user says that they want to quit, which is choice equal to 5. Since the user is getting out of the loop, I want to save the task, so I'm going to say save the task, because if user has added something, deleted stuff, so I want to make sure that it's persist on the hard disk. So I'll say save task. I'll say print, give a goodbye message to the user, always good to say goodbye, and break out of the while loop here. So that's what we're doing here. Also, what if user enters something else and none of these options? Oops. Else I will say, like, what if user says 6? Then I'm gonna say invalid choice. We'll try this first. Please try again. Okay, now in Python, if you want to run the main function, you have to say name underscore name equal to underscore main underscore. I want to run the main function. That's how you run the main function when the application starts, and that's our main over there. So looks like we have everything in place. I want to just check if we have somewhere task equal to, nope. Okay, perfect. So this looks good, but let's see if it runs properly. So first I'm going to clear this out. ls, I have my code file there, day 7. I don't have any files. Task manager. It gave me options here. If I say 9, invalid choice, please try again, because that was our choice that doesn't exist. I want to view all the tasks. Since there's no task available, it will say no task available. Let's add a task. 1. Enter task title. I'll say buy milk. Okay, so that's a task buy milk added. Let's look at it if it's there. Okay, I have 1 buy milk incomplete. Let's add a couple of more of them. Let's say buy eggs. 1 get car wash. Okay, let's look at these tasks, and I see all the 3 tasks: buy milk, buy eggs, get car wash. So we can view the task. Let's mark something as complete. Let's say pick 3, and I say I already got done with buying eggs, and it says task buy eggs, mark it complete. Let's see if it's true. View the task, and if you see incomplete, complete, and incomplete, perfect. So that worked. I want to delete a task. Let me delete buy milk task. So I'm going to say 4, enter the task ID 1, and it gave me an error. I knew there was some problem somewhere. So this happened in the delete function. In delete task ID, it says there is some problem here. Looks like, oh, it says this I copied from here. That makes sense, because this is not true. So this is deleted task, or deleted task, and then inside that has a title. Makes sense. Perfect. Clear. I am very sure nothing of this is saved. Let's see if no task available. Of course, that means I'll have to go through the entire process again. Add a task buy milk, add a task buy eggs, add a task get car wash. Let's view the task. I have all the 3 tasks here. Let's go ahead and directly delete. Let's say 4, and I want to delete buy eggs again. And let's see now, to view task, I have only 2 tasks: buy milk and get car wash. So only option left to test is 5, and it says goodbye. Perfect. So there you go. So we have completed our project, which is creating a task manager, step-by-step task. Now you can create an API out of it or something to use it, but this is a basic command line interface task manager that we've created. If you have any questions or had any issues, let me know and I'll get back to you. And as per some additional features to add, I'll give you some tasks to add some additional features. You can add deadlines or priorities for tasks. Next thing you can do is export task to a JSON or CSV file. Something that we didn't test here was we saved those to our file. Did they get saved? Let's look at it. So here is my task.txt. When I pressed exit, it saved whatever was left in the task into this particular file. And next time when I run this, now it will open those tasks and show me the tasks. So I can always go here, clear it out. I can run that project again, and I can say view task, and you see those tasks are persisted to my hard disk in this particular folder, because we have saved the task using this OS module function. So okay, that's so try to export the task to a JSON or CSV file. Give that as an option to the user, and then support command line arguments for quicker task management. So try these out and let me know how it goes. So today on day 7, we learned how to write clean Pythonic code, use advanced Python features, and build a real world project integrating your knowledge of functions, data structures, and file handling. Whatever we did in the entire week, we kind of put or tried to put everything together into one single project. The Task Manager project helped you reinforce these concepts through practical application. So if you had any questions or any problems, let me know and we can start with our week 2.
Welcome to week 2, Data Science Essentials. This week, on day 1, we'll cover Introduction to NumPy for numerical computing, followed by day 2, where we will be looking at advanced NumPy operations. Day 3 will cover Introduction to Pandas for data manipulation. Day 4, we will be looking at data cleaning and preparation with Pandas. Day 5 will be data aggregation and grouping in Pandas. Day 6 will be data visualization with Matplotlib and Seaborn, followed by Day 7, where we will be looking at an exploratory data analysis or EDA project. So let's get started with week. Welcome to day 1 of week 2, where we'll be going over introduction to NumPy for numerical computing. Today's topic, first, we will be looking at understanding the role of NumPy in data science and AI. What is NumPy? NumPy, or numerical Python, is a foundational library in Python for numerical computations. It provides a fast, efficient way to perform operations on large data sets using arrays and supports advanced mathematical function. Now, why use NumPy in AI? First, because of the performance. NumPy arrays are more efficient than Python lists. Ease of use. Built-in operations for mathematical and linear algebra functions helps you easily implement a lot of different mathematical and linear algebra functions. Integration. Works seamlessly with libraries like Pandas, Matplotlib, TensorFlow, and PyTorch. That's why we're using NumPy in AI. Next, creating and manipulating NumPy arrays. First, let's look at how to import our NumPy library. So to do that, you say import NumPy as NP. So I'm going to start a new file, Python file, save it inside our week 2 in this particular case, day 1. I'm going to create a file called as day 1 NumPy basics .py. Now here, to import NumPy, as I mentioned, import NumPy as NP. So I'm going to use the alias NP for this. Next, creating arrays. Now there's different ways of creating arrays. One is from a list. So from a list, how do we create an array? So let's look at an example here. Create an array. I can say np.array and give it the list that you want to do. Give 1, 2, 3, 4. And if I print this array, I will see, I'll say Python day 1, and there you go, 1, 2, 3, 4. So from a list, we have created a NumPy array. Next is using built-in functions. Now there's some built-in functions. For example, we have, let's create a variable zeros, np dot zeros, and I am going to say 3, 3. What this does is it will create a 3 by 3 matrix of zeros. We can print that just to check how it looks like. There you go, a 3 by 3 array of zeros. This is the first one, that's why it was still showing, but I'm going to comment these out. Next, ones. I am going to create np.ones. You probably already know what it does, but I'm going to say 2 by 4. So this will create a 2 by 4 matrix of ones. If I print it, and there you go, 2 by 4 matrix of ones. Next one, I'm going to say range array equal to np dot range. What this does is it returns an evenly spaced values within a given interval. So for example, I want to get 1 to 10 numbers, but an interval of 2. So if I do this, I will get 1, 3, 5, 7, 9. So what it did was it went to 1 to 10 with evenly spacing of 2. So the interval of 2. So 1, it skipped 1, 2, then gave me 3, skipped 1, 5, skipped 1, 7. So every 2 it skipped and went to the next one. So 1 and skipped 2, went to 3, skipped 4, went to 5. So that's what this does. If I give it a spacing of 3, I get 1, 4, and 7. 1 skipped 2 and 3, fourth one skipped 5 and 6, third one is 7 then. So that's what it gives me. If I give a bigger number,
There you go. 1 skips 2, 4 skips 2, 7, keeps on going all the way till 97. This is how it can work. Next one that I want to show is linspace. So I can just say linspace underscore array equal to np dot linspace 0, 1, 5. So what linspace does is it returns evenly spaced numbers over a specified interval. So if I say that I want from 0 to 1 with the interval of 5 inside that, so what it will give me is 0, 0, 0.25, 0.5. So it gives an interval of 5 and gives me that inside in between the two numbers. So let's look at this. So this is 0, 0.25, 0.5, 0.75, 1. So these are 1, 2, 3, 4, 5 different numbers evenly spaced in between this. If I do this 1 to 10 and run it, it will say 0, 2.5, 5, 7.5, 10 evenly spaced. If I say 4, then it will probably give me whole numbers. So no, 0 is 3.33, 6.66, 10 point. So for 3, it will give me 0, 5, and 10. So evenly spaced with whole numbers in there. Next, let's look at manipulating arrays. So we can do a bunch of different things like changing the shape of an array, and we can also add dimensions to an array. So let's look at those examples. I'm going to go back to the same one and get rid of everything. I'm going to clear this out too. And here I'm going to start first array equal to, I have removed the import statement too. So I'm going to say array equal to np dot array. So if I want to create an array from a list, we already saw how to do that. 1, 2, 3, 4, 5, and let's give 6 this time. And then I want to reshape this array. I'm going to call the reshaped array equal to array dot reshape, and say that I want to reshape into 2 by 3 matrix. Let's print it out. So instead of one single dimension, it's going to have 2 by 3 matrix for me. So if I run this, I have 1, 2, 3, 4, 5, 6. So it took and reshaped that. I can also do 3 by 3, and it will give me an error because I don't have 3 by 3 elements here. I have 2 by 3, or I have 3 by 2 since I have 6 elements. There you go, 1, 2, 3, 4, 5, 6. So I can give any of those combinations. If I add 7, 8, and 9, and now do 3 by 3, it will give me 1, 2, 3, 4, 5, 6, 7, 8, 9. I can create whatever multiples that is available based on these 9 elements and create a reshaped array or different matrix. Next thing is to adding dimensions. Now that I can do by saying np dot array. Let's create an array with 1, 2, 3. So this array, let me comment out these things. Now when I have that array, I'll say expanded another object array. So this will add dimensions to it when I say np dot new axis. So let's look at it, how it adds a new dimension to this. Expanded, and you see 1, 2, 3 has added new axis for each and every element. Since I've not given a dimension here, creates 3 different dimensions for each and every element in here. So this is how you can manipulate a basic arrays and create, like, reshape them or add dimensions to them. Next, let's look at some basic operations on arrays. So we'll look at element wise operations and we'll look at mathematical operations. Let's jump in here. I'm going to create an array a equal to np dot array, and inside that I'll add 3 elements, 1, 2, and 3. And then I'll create another array, call it as b np dot array. In this particular case, I'm going to give numbers 4, 5, and 6. So I have these arrays. Now to do element wise operations, let's say I want to add these 2 arrays, I can do print a plus b. That's a good thing that you can do with numpy arrays, where you can add. This will give you an output of, based on this addition, 4 plus 1, 5, 5 plus 2, 7, and 6 plus 3, 9. If I want to do, let's say, multiplication of these arrays, A times B, it will give me 4 times 1, 4, 5 times 2, 10, 6 times 3, 18. I can also do division. A divided by B. This will give me 0.25 for this, 5 divided by 0.4, and 3 divided by 6 is 0.5. So that's what it will give me. Let's go ahead and run this. Let's clear it out first and run it on a clear board. So I have 5, 7, and 9 for addition. Multiplication, I have 4, 10, and 18. And for division, I have 0.25, 0.4, and 0.5 for 1 divided by 4, 2 divided by 5, and 3 divided by 6 respectively. Next, let's look at some mathematical operations. So I'm going to say array equal to np dot array, and I'll create 1, 2, 3. Could have just used the previous one, but that's fine. And here I am going to do a square root. So I can say np dot square root of the array. So you can always make it a better example. I can say 4, 16, 25. Let's see how it look like. And here it is 2, 4, and 5. So it took square root of this and give me a new list with square root items in there. I can do print np dot sum of array. I am sure you got what it does. I'm going to clear this out, and we see 45, which is sum of all these three numbers. Next, I can do a mean, np dot mean of all the numbers in an array. Clear, run it, and mean is 15 for these three. Next, I can do a max also. I can just copy this and say max of this particular array. Clear, run it, and the max is 25. As you can see, 4, 16, and 25. 25 is the max. But if you have a bigger array or list of item, you can kind of find the max in that particular list. Next, let's look at array indexing, slicing, and reshaping. So first, let's look at indexing. Indexing is something similar where you can get an element for a particular index. Then we'll look at slicing, where you can slice an array into a smaller array, which we have done in list before in Python last week. And then reshaping, where we can reshape a particular array, which we have seen earlier today. But let's look at how this can be done again. So first, as I mentioned, indexing. Array equal to np dot array. I'm going to create an array and probably try to use this one. 10, 20, 30, 40, 50. So 10 to 50. Next, I want to print a particular object in this array. So I can just say array at item number 2. It will print me 30 because this is index is 0, 1, and 2. Now, if I similarly in what we did in list, you can also use negative numbers. For example, -1 will give me the last element because this is the 0th element. So if you go behind, this is -1, -2. So that's how this works. Let's check it out. So it should give me 30 and 50. For 30 for index 2 and 50 for index -1. Next, let's look at slicing. So I can do slicing similar to what we did before, where you can say that I want items from 1 to 4. In this case, I will get items 20, 30, and 40 because 1 is this, 30, 2, 3, and doesn't include the last element. So index 1 to 4 minus excluding the last element. And similarly, I can do array, comma, 3. So what this does is it will give me all the numbers before until 3. So 0, 1, 0, 1, 2, and it will not give me the third element, of course, because it will give me 10, 20, and 30. So starting from the start all the way up till 3. Similarly, you can do the other way too, where you say that you want everything starting from 3. So that will give you 40 and 50. 0, 1, 2, 3, and 4. Next is reshaping, which we have seen earlier, where I can say reshaped array equal to array dot reshape. I have 1, 2, 3, 4, 5 elements. put 60 just so that I can do a reshape of in this particular case 2 by 3 and print reshaped. So see, this saw this earlier. So it reshaped the array into 2 by 3 from 1 by 6. It converted into 2 by 3. So that's our reshaping. Next, based on whatever we learned, let's do our hands-on exercises. Our first exercise is to generate an array for basic mathematical operations. Here, the objective is to practice creating arrays and performing operations. The things that I'll follow here is first I'll create two arrays of size 5 using np.range and then perform addition, subtraction, multiplication, and division on those. So let's get started. It's pretty straightforward. I am going to call it day1 underscore exercise 1 dot py. Here, as I mentioned, I'm going to create two arrays, np dot range. First, of course, remember to import numpy as np and then arrange 1 comma 6. So this will create an array of 1 2 3 4 5. I'm going to create another array, np dot range and this one I want to create, let's say 6 comma 11. So it's because 6 7 8 9 10, that's what it's going to create. So I have two arrays. Now first let's do a addition operation, which is a plus b. What I'll do a subtraction, multiplication, division. So I'm going to say sub multiplication and division, multiplication, subtraction. Now if I run this, let's clear this out. I'll say Python name is day1 underscore ex1, and there you go. We have the addition of the two arrays which had, if you want to see how they look like before I print them, I can say print a and print b. Go ahead, clear it out and run it again. So a and b, so addition 6 plus 1 7. I can also look at the last one, 10 plus 1 15. Subtraction of those, multiplication of it, and division of those two arrays that I have created. So this kind of completes our exercise 1, where we generated an array for basic mathematical operation. Our exercise 2 is to create a 3 by 3 matrix and perform operations. So the objective here is to work with the multi-dimensional arrays and perform basic operations. So we'll first create a 3 by 3 matrix using np.array. Then we will calculate its transpose using .t and perform element-wise addition and multiplication with another matrix. So let's try this out. So first, let's create a file, call it day1 underscore ex2.py. I'm going to create a matrix equal to np dot array, and since it's a matrix of let's say 3 by 3, I said, so I'll create first one 1 2 3 comma 4 5 6 comma 7 8 9. So I have this matrix of 3 by 3 array created. Of course, I need to import numpy as np. Next, I want to print. Let's print this original matrix so we can differentiate, comma matrix. I'll put it in the next line, so /n. Next, to do the transpose operation. To do this, what we'll do is we'll create a transpose object, a variable, and say matrix that we created dot t. That's all you need to do. Let's print the transpose of this /n comma transpose. Just try it out, clear it out, Python, this is day1 underscore ex2.py. And there you go, there's our original matrix. And here is a transpose where you can see 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 7, 8, 9 in this particular angle. So it's created a transpose of this original matrix. If you don't know what a transpose is, it's pretty much reflecting the rows and switching the columns and rows here. 1 by 1 was changed to 1 by 1. 1 by 2 was changed to 2 by 1. So that's why 2 is here. So it kind of switches the rows and columns. Next is let's do element wise operations. So let's create another matrix. I'll call it, for simplicity, another matrix, np dot array, and this time I'll create 9, 8, 7, comma. I can even use the transpose to do the same operations, but it's more fun to create a completely opposite side matrix. 9, 8, 7, 6, 5, 4, 3, 2, 1. So I have my another matrix. I'm going to say print. Now this first one is element wise addition slash n, and I want to display matrix plus another matrix. I'll also do multiplication, which is much more complicated in matrix, times, and clear this out. Let's run it out. So we have the transpose, and then here we have the addition. Because it's all opposite numbers, it should give you a matrix of tens. And then for multiplication, we have this output here, which is multiplications of 9 by times 1 is 9, 8 times 2 is 16, 7 times 3 is 21. So that's what we got element wise arithmetic here. So I hope you were able to follow along and build both these exercises, exercise 1 and 2. If you had any issues or problems, let me know in the comments and I'll get back to you. And for some additional practice, you can create a 4 by 4 matrix and calculate the sum of its rows and columns. Try that out. Next, you can write a program to normalize an array, which means scaling the values between 0 and 1. And then finally, try to generate a random array and find the minimum and maximum values. And do these using NP or NumPy library and not just the basic list. So it's more fun. So in summary, on day 1 of week 2, we learned the basics of numerical computing with NumPy, focusing on creating, manipulating, and performing operations on array. The hands-on exercise hopefully will ensure practical understanding of mathematical and array operations. If you had any questions or problems, let me know and I'll get back to you. Day 2, Advanced NumPy operation. We looked at NumPy yesterday, but today we're going to look at some of the advanced NumPy operations that exist. So first, we are going to cover broadcasting in NumPy. Now, what is broadcasting? Broadcasting allows NumPy to perform arithmetic operations on arrays of different shapes. Smaller arrays are automatically expanded to match the shape of larger arrays. Some of the rules of broadcasting include dimensions are aligned from the right, and a dimension is compatible if it matches the other array's dimension. One of the dimension is 1. So let's look at some examples for this. So first, I'm going to import NumPy, and then we'll do some array and scalar broadcasting, and then look at array broadcasting in detail. So for this, I'm going to create a new file, call it a Python file, save it under my week 2, day 2. I'll call it day 2 underscore samples, and start with importing NumPy as NP. Next, let's do I'll add a comment here, array and scalar broadcasting. How does this work? So first I'll say array equal to np dot array. So I'll create an array from a list 1, 2, and 3. So this is my array. Now I'm going to say print array plus 10. So this what it does is it adds 10 to each and every element in here. If you want to see an example, I'm going to say clear ls, and I'm going to say, oh, I said day samples instead of day 2 samples, but that's fine. I'm going to say Python day samples. I have 11, 12, and 13. So 10 was added to every single element. So it's kind of broadcasting the number to each and every element, and it added there. So in a scalar array. So let's look at more on the array broadcasting. So I have a matrix equal to np dot array, and this one I'll create a 2 by 3 matrix, 1 comma 2 comma 3, and the next element in here I'll add 4 comma 5 comma 6. Straightforward one. So this will create me a matrix 2 by 3, which is 1 2 3, and 4 by 4 5 6. I'll create a vector np dot array, call it 1 comma 0 comma 1. Okay, so there you go, that's our vector. Now I am going to say print matrix plus vector. So the output for this will be based on the values that we have here. 1 0 1, it will give me 2 2 4, and below it will be 5 5 7, because it kind of takes this vector and adds it properly to each line of the matrix. Let's look at the output. And we have 2 to 4, because 1 plus 1 2, 2 plus 0 2, and then 3 plus 1 4. That's what we have. Then next line, 4 plus 1 5, 5 plus 0 5, and 6 plus 1 7. So this is how array broadcasting works, where you take a vector here, a single array, and then I am broadcasting it to the entire matrix here. Next that we're going to look at is aggregation functions. Now aggregation functions compute summary statistics for arrays. So it's pretty helpful in AI world. So let's look at some of the common functions that are available in the aggregation functions. So I'm going to go here. I am going to remove everything, create an array, np dot array. I'll create a matrix here. It will be a matrix of, oops, need to fix this, okay, matrix of 1 2 and 3 comma 4 5 and 6. So I have this matrix here which is 2 by 3. Next, let's look at some of the functions. First, I want to do the total sum of all elements. So I'm going to call it sum, and I can use np dot sum. This is the function that you can use. This will give you the total sum of all the elements in this matrix up here. I can say print, I can say what is the mean of this particular matrix that we have. You can say np dot mean and pass the array to it. I can also get the max, similar way, max comma np dot max and pass the array to it. Similarly, I'm going to just copy paste this. I can get max, so I can get min. Say min, there you go. Next, I want to get the spread of the data. How is the standard deviation? Standard deviation. For that, I'll just call the function std and pass the array to it. I can, what else can I do? Oops, sorry. Next, I can get sum along the rows. So sum per row. So that I can say sum along rows. For that, I can say np dot sum, and then I give the array, and I'll say axis equal to 1. So it will take one single axis, so it will give you per row. Same thing you can do for column, where you can, I'll say columns, np dot sum, pass the array, and axis is 0. So one axis is for the row, and for column axis is equal to 0. So I do this, go back here, clear it out, let's run it, and you'll see sum is 21. If you add this 6 plus 5 plus 4 3 to 1 is 21. Mean is 3.5, max is 6, minimum is 1, standard deviation is 1.7078, sum along the rows is 6 15, 6 and 15 3 4 5 6, and 6 plus 5 plus 4 is 15. Sum along the columns is 1 plus 4 is 5, 7 plus 5, 7, 2 plus 5 is 7, and 3 plus 6 is 9. So that's how you can use the aggregation functions that are available. Next, let's look at Boolean indexing and filtering. Now, what is Boolean indexing? We use Boolean arrays or conditions to filter elements from an array. So let's look at some examples of Boolean indexing. What I'm going to do here is I am going to get rid of everything. I will create an array of a single access array 1, 2, 3, 4, 5, and 6. So I have this array available. Next, I am going to filter all the even numbers. So to that, I can say evens array mod, I can also use mod operator, equal to 0. What this will give me, it will print 2, 4, and 6. So this kind of filters even numbers. Say print evens, comma, evens. So you can check that out. Next is modifying the elements based on a particular condition. So for example, I can say array is greater than 3 equal to 0. So in this case, if the values are greater than 0, it will make sure that it will change that array values into 0. So I'll say modified array is array. Let's output this and check it out. So I have an array, again, let's clear it out. I have an array 1, 2, 3, 4, 5, 6. So to get the evens 2, 4, and 6, I've created this array. So this is more of a filtering option here. And then to modify elements based on a condition, if you see this 1, 2, 3, 0, 0, 0. So if array value is greater than 3 inside an array item, it will change those values into 0. So this is kind of very helpful when you work with data sets and you want to change values, especially when you are creating models or training models. Next, let's look at random number generation and setting seeds. We already did something random number generation in Python. Now let's see how we can do this using NumPy. So first, for random number generation, NumPy provides the np.random module for generating random numbers. Let's look at some of the common functions for it. So go back to this, get rid of everything. And I am going to first generate random numbers. So I am going to create a random array equal to np.random.rand. That's what we use, 3, 3. So this will create a random array for us and the uniform distribution of 0, 1. So if I print this, you can see how this looks like. I'm going to say random array. I'll move the array to the next line so it's more clear. I'm going to call it random array. Let's go back, clear it out, and run this, and you see you have a random array of 3 by 3 which has random numbers with a uniform distribution from 0 to 1. Next, I want to generate integers instead of the numbers that we have created. So I'm going to call it random integers equal to np.random.rand. It's very similar until here, except it's rand int, say 0, 10, size of 2 by 3. So this one, as it says here, that it will return you an array, a matrix of 2 by 3 with numbers from 0 to 10, which are integers. So if I want to print this, I can print saying random integers /n, and that is my random, not array, that is my previous one, random integers. Let's go ahead, clear this out. So now we'll have two different, first for the random array, and then next is random integers. If I run it again, if you see, every single time it will give me different numbers and integers, array and integers, based on what it generates. Next thing that I want to talk about is setting random seeds. Now this ensures reproducibility by fixing the random sequence. Before, what happened was every time I run it, I was getting different numbers every single time. So what I can do here is I can say np.random dot seed. I like my favorite number 42. And then now when I use the random numbers, output will always be same. So if I go back, clear, run it, no matter how many times I run, the values will be same because I've set a particular seed. And this is very helpful in some of the models where we are training the data set and picking a particular data set for training, and we want to make sure that every time we run that training set, it uses the same training set and testing sets for our models. So that this is very important to know about setting the seeds. Now that we have understood more about advanced NumPy, let's get into some hands-on exercises. Our first exercise is broadcasting operations. We've already done this, but the objective here is to perform operations on arrays of different shapes using broadcasting. So first we'll create a 3 by 3 matrix, and then we'll add a 1 by 3 vector to the matrix, and then we'll multiply the matrix by a scalar. So let's get started. Create a new file, save it as day2 underscore exercise 1.py. Now here, let's create a matrix equal to, okay, I need to import numpy as np, and then np dot array. Let's create this array of, as I mentioned, 3 by 3 matrix. So that I can do by first saying 1, 2, and 3, comma, next one I'll say 4, 5, and 6. The next matrix, it's very easy to guess what I'm going to do, 7, 8, 9. Perfect. I'm going to create a vector which is 1 by 3 array, np dot array, and here the vector I'll give it, this time I'll say 1, 0, and -1. Let's bring some negativity in the vector. Now broadcasting addition, we've seen that. I'm going to say result addition equal to matrix plus vector. So this will give me addition. So let's print it out just so we can see the results. Of course, I like to keep it clean, the code. So addition is common result add. Next, I want to broadcast a scalar multiplication. To do that, let's say result underscore multiplication equal to matrix times 2. Print multiplication, and here I'm going to say result mal. Make sure that it's on the next line for both of them, so it's cleaner result. And now our results should be based on addition of these two. So let's look at it. We clear it out, run the code called as python day2 and .ex1. So there you go. That's our addition first, where we took this 1, 2, 3, 1, 0, -1, so that's why 2, 2, 2, 4, 5, 6, 1, 0, -1, so that's why 5, 5, 5, and increment same, decrement, and it was 8, 8, 8 here. Now multiplication for my matrix, which is this array, I multiplied by 2. That's why every single number 2, 4, 6, 8, 10, 12, 14, 16, 18 is twice what these values were initially. So that's our exercise 1, where we did the broadcasting operations again. Our second exercise is to generate and filter a random data set. We already did this, but again, this is an exercise that you should probably follow along. Here, the objective is to generate a random data set, filter elements based on conditions, and calculate the summary statistics. So we will create a 5 by 5 matrix of random integers between 1 and 50. You probably know how to do that, but again, we'll practice. Filter values greater than 25 and replace them with 0. We saw that, but we'll do that again. And calculate and print the sum, mean, and standard deviation of the modified matrix. Interesting enough? So let's go ahead and start it. Let me clear this out. I am going to create another one, save it as exercise 2, and here first thing is import numpy as np. Next step is generate the random data set. So I am going to say data set equal to np dot random dot rand int. As I mentioned, I want a random integers array. And to this, I am going to say, and so it's 1 to 50. So I'm going to say 1 comma 51, and then size equal to 5 by 5 matrix. That's what I wanted to create. So this will give me a matrix of 5 by 5 of random integers between 1 and 50. Our next step is to print this so we can look at the differences. Original slash n comma data set. So we display the data set out. Next step, as I mentioned, filter the values greater than 25 and replace them by 0. So first, let me add comments here so we know what we are. Generate random data set. Next I mentioned was we will try to do filter values greater than 25 and replace with 0. And finally, we will calculate summary stats, which are we'll do the sum, mean, and standard deviation. So now to filter part, data set greater than data set where values of data set are greater than 25, I want to replace them by 0. As simple as that. We'll print this modified data set slash n comma data set. So it replaces the existing data set with the new data set. Now calculating the summary statistics of the new data set that we have. Let's say print sum of everything should be np dot sum of that entire data set. Next I want to, as I mentioned, I want to do mean, and next I want to do the standard deviation. Now mean was mean and standard deviation was HTD. So I have this. Let's go ahead and print it out and look if it looks any good. You can, I've not set the seed here. You can set the seed so every time the output is same, but I'm going to run it just one. So I'm going to say python day2 dot ex underscore ex2 dot py. And here is our original matrix 21 4. It has some numbers which are about 25. So those are, for example, this 40 is set to 0, this 34 is set to 0. So this is the modified data set with values restricting up to 25. The sum of this entire data set is 182. I'm not going to do addition manually. I trust the system. The mean is 7.28 and the standard deviation is 7.78. Pretty good compared as since I were going from 1 to 25 in this particular case, and we have reduced all the higher numbers to 0. So there's much more flexibility towards the lower numbers, and that's why the standard deviation and mean are more inclined to the lesser numbers. If I don't do this here, it will be much more higher. If you look at it, 584 is the sum, mean is 23, and standard deviation is 13 because we have more numbers towards the higher end. So I'll save this. I'm going to go back. Now let's talk about the next step. So we have some additional practice for you. You can create a 3D random array and compute statistics along specific axis. We did that previously where we specified axis equal to 0 or 1 depending on if you want to do column or row. Then you can write a program to generate a data set of random floats and normalize the values between 0 and 1. We did something like that. Some examples we have so you know where you're headed. And finally, implement conditional replacement to create a binary mask for values above a threshold. We did that in our exercises, so I hope that is helpful. If you have any problems or questions or need help on these, let me know. To summarize, today we dived into advanced NumPy operations, including broadcasting. We looked at aggregation, we did filtering and random number generation. Now these concepts are foundational, as I mentioned, for efficient numerical computation in AI and data science workflows. It's very helpful, especially for training a model and testing those models with data. So let me know if you want any more explanation on these or had any problems or questions. I will always get back to you. Day 3. Introduction to Pandas for Data Manipulation. We already completed NumPy and some advanced NumPy. Now let's look at the second favorite library, which is Pandas. First, we're going to look at Introduction to Pandas data structure, where we're going to talk about what is Pandas. Pandas is a powerful Python library for data manipulation and analysis. It provides an easy to use data structure, which is series and data frames. Let's look at those Pandas data structures. First, series. Series is a one-dimensional labeled array capable of holding data of any type. And we have data frame. Data frame is a two-dimensional labeled data structure like a table. Let's look at the syntax for both of these. I'm going to go ahead and create a new file, Python file, save it. On my day 3, I'll call it day3 underscore samples. Let's start with importing pandas. So to import, you say import pandas as pd is what alias will use, s equal to pd dot series, and to this I'll pass 10, 20, 30, a list of 3 items, which is 10, 20, 30, and I'm going to say index equal to a, b, and c. So now if I print this series s, how does it look like? So this will create kind of like a dictionary where each one of these is indexed at a particular point. So it kind of converts, you can think of it as a list into a dictionary. So let's go ahead and run this. I'm going to go ahead here. I'm in week 2, day 3. Perfect. Say Python day 3. There you go. And there you go. Our series A is 10, B is 20, C is 30. Perfect. So that's how a series works. A one-dimensional labeled array capable of holding data of any type in this particular case. The data in this particular type, if you'll see, is integer 64. It also specifies that. Next, as I mentioned, data frame, which is a two-dimensional labeled data structure like a table. So for that, I am going to say data equal to, I'm going to create a dictionary of name is, create a list inside there, names actually, Alice and Bob, and I'll create another key, age, and this age is a list of numbers, which is the age is 25 and 30. Now I can say df equal to pd dot data frame. This is how you create a data frame, data, and print df. I'm going to comment this out because we already saw how the series looks like, but how does a data frame look like? So I'm going to clear this out, run it, and here, there you go. We have 0 and 1 row. We have name Alice and Bob, age is 25 and 30. So it kind of creates a two-dimensional label data structure which looks like a table. Next, let's look at loading data from CSV, Excel, and other sources. The kind of Pandas is used for that quite a lot, and it automatically converts them into data frames. So first, common data loading methods is, first we can look at how to do this from a CSV file. We can see from an Excel file, and you can also do that from a dictionary. We already saw a dictionary, which is right here, where we have a dictionary. Think of it, you have a bigger dictionary with all the different things, and you can pick data from there. Now, if I wanted to pick data from Excel, I would probably say, let me comment this out. The way to pick from a CSV is data frame equal to pd dot read CSV. That's the function that we call, and you give the path of the file where that CSV file is. So I'm going to say CSV, something like this. Next, if you want to do similar with Excel, we'll say read dot Excel, and then here you give your XLS or XLSX file, whatever it is, you give that path here. So these are 3 different ways you can load data from a CSV file directly, or from an Excel file, and or from a dictionary that is available. We'll look at them in our hands-on, but for now, this probably is very helpful. And it's used quite a lot because there are a lot of different websites these days, like Hugging Face, that provides you data sets that are available. And you can use those data sets to get the CSV file and import them inside here directly. Next, we have saving data. Now we can save to CSV and save to Excel. Just how we loaded the data, there are similar functions. So for example, if I loaded this, I read this files. Now if I want to save it, you will say, let's remove this. Since it's a data frame that I'm saving, not a file. So I say df data frame, and then I'll say to underscore CSV. So this is how you can save the file data.csv, save the data frame into a CSV file. Similarly, I can just say df dot to underscore Excel to save the data frame into an Excel file that you have that you can provide. Also, if you don't want the indexing, because it also has index of 0, 1, 2, 3 in the data frame, you can set index equal to false and it will not add that additional column. If you've seen this column here, 0 and 1, if you don't want that, you just say index equal to false. There you go. This is how you can save it. Now, when you import it or load the data from a particular CSV file, you can load it in a similar way and it will automatically index it for you. So next, basic data frame operations. Let's look at some of them. We have first viewing data. So if you want to view the data, I am going to go and comment this out. So I'm going to say here viewing data. To do that, let's say you have a data frame df, and if you want to see the first 5 rows, you call a function called as df.head. This will, let's say, print df.head. This will print the first 5 rows of a particular data set. If you want to see the last 3 rows or more, you can always say df.tail, which will show you last few rows. But if you specify how many you want, you can see the last 3 rows of a data set. You can also get information summary of a data frame by saying print df.info. It will give you complete information about the head, the column that uses, some statistics that is there. It will give you that. But if you want to get detailed statistics, you can use df.describe function that will give you statistical summary. This will give you summary of the data frame. This will give you statistical summary of the data frame, and we'll try these out when we work with some hands-on later on today. Next, we have selecting and indexing. Now, if you want to select a particular column, you can directly use print data frame and then give, for example, we had name as one of the column. It will give you single column, the name column. Similarly, if you want to select multiple columns, you can say df name comma age with double square brackets in here. So this will give you multiple columns, which is name and age in this particular case. We can also look at, so that's for selecting columns. Now, if you want to filter few rows, we can do that by saying print df. Now inside my data frame, I want to filter rows where age is greater than 25. So I can do that by saying df of age is greater than 25. So this will filter rows where age is greater than 25. So you can get a particular data set from a bigger data set. Now, if you want to, next thing that we'll look at is selecting by a particular position. You can get, let's say, for first row by position. If you want to get a data item from the first row, I can just say print df.ilock of 0. So this will give me the first row by position. If I want to get the first column by position, I say df ilock : 0. This will give me the first column by position. So the first item that is available, first column that is available by position. That's what this does. Next, let's look at selecting by label. So I can do that by, let me just print df dot, instead of I, it's lock. This will give you the first row by index label. And now if you want to get by name column, I can use the same thing as before. You probably guessed it. You just say comma name. So this will give you the name column data item in this particular case. So that kind of summarizes a lot of different basic data frame operations. Now we want to see them in action. So let's go into hands-on exercises. Our first exercise is to load and explore a sample data set. So the objective here is to load a sample data set and explore its structure. So we are going to get a data set from GitHub data structures. We're going to get the iris data set from there, and we are going to use pandas to load that CSV data set and print the first and the last few rows, summary information and statistics. So now to get that particular data set, the URL for that is, let's go here and create a new file. I'm going to call it day3 exercise1.py. The URL for that is this one. I am going to open a Chrome, paste it here, and you see this is the data set that we have about iris, which has the about iris flowers, sepal length, petal length, petal width, and species of flower that it is, which is setosa or versicolor or virginica. So this is a simple basic data set that is available. So I am going to use that. So as I mentioned, the first step is to import our pandas as PD. So this is the alias that we are giving. Next, I want to load the data set. So for that, I am going to first say load data set. And inside here, I want to say data frame equal to PD dot read underscore CSV. Now this path doesn't have to be local path. I can give this URL that we have right here, and it will read that CSV inside this data frame. Next, I am going to say explore the structure. Now we have defined all these things but never saw any of these in action. So I am going to say print first 5 rows. Do you remember how do we get the first 5 rows? If not, that's df data frame dot head will give you the first 5 rows. So we already saw the data. Let's look at that data again. I am going to say, let's make sure we're in the right folder. Yes, we are. Python day3 underscore ex underscore 1.py. It's going to download that data set, and it will show me the first 5 0 1 2 3 4 rows from that data set because I called df.head. Next I want to do is last 5 rows. Now if you remember, that is tail. Run that, and we have the first 5 rows and the last 5 rows right here. I am going to comment these out because it's going to just keep on growing. Next thing I want to do is I want to get the information about the data set that we have, and we mentioned we can just say df.info to print it out. Go here, clear it out, run it, and here you go. We have the information about it. It says there are 5 columns: sepal length, sepal width, petal length, petal widths, memory usage is this much, and it tells you what are these. There's 150 non-null count items. Data type that it saves is float 62, whereas the last one is an object because it's a text string. So it kind of gives you an explanation about that. Next thing I want to do, describe, which gives me all the statistical information about that data set. So I am going to say run this, and it says count sepal length is 150, which we know all of them are 150. Mean for each one of them, what is that? Standard deviation minimum 75% or 25% of data, 50% of the data, 75% of data, max of those. So it gives you all this information from there by just calling the describe function. You don't have to specifically go and find mean, max, standard deviation. It does give you all the information in one single place. Next, let's look at exercise 2. Our exercise 2 is select specific columns and filter rows. So we'll use the same data set that we used, and we'll practice selecting columns and filtering rows based on particular conditions. So we'll select specific columns. In this case, we'll use species and sepal length. We'll filter rows where sepal length is greater than 5.0 and species is setosa. So I am going to just work with the same data set. So I'm not going to create another exercise file. But here I want to select some columns. So I'm going to say selected columns equal to, if you remember, how do you select columns? Double square brackets. And here I am interested in species. If you remember, we have a species, which is the last column here. I think we did here. Species is the last column. That's what I'm going to call. Always copy paste it because it's easier to make sure that you don't do any mistakes. Sepal length is what I'm going to select. These are the columns that I'm interested in. And I am going to print next my selected columns /n, and that is selected columns. Let's see how does it look like. Clear. And here is my species and sepal length data structure, which selected columns have just that, nothing else. So this is my new data frame, which has only the 2 columns in there, so I can play around with it. Now you can think of it as it can be used for data modeling, where you can take all the lengths, all the different columns except for the ones that you're interested in to predict, and train the model with that. So that's what this can be used for. Next, let's filter the rows. So to filter rows, I am going to create filtered underscore rows, and I'm going to say df. Now in this case, I'll say df of sepal length. Take that, sepal length. If that is greater than 5.0, that's what I was interested in. And I use this rounded bracket because I want to add another condition, which is df of species is of particular type. In this case, I am only interested in, let's take the first one, which is I think setosa. So I'm only interested in setosa. So this will filter only setosas which have sepal length which is greater than 5.0. I can go ahead, I make sure I close everything and print it out. Filtered rows /n, comma, pass the filtered rows to it. I'm gonna comment this out. I don't need that. Clear it out, run it, and there you go. We have 0, 5, 10, 14, 15. These are the ones where sepal length is greater than 5 and the species is setosa. So these are all the rows that are available with our filtered items that we are interested in. So there you go. This is pretty awesome. I hope you are able to follow along with both the exercises that we've done here. If not, if you had any problems, let me know. Now you can always look at how this is useful. If you've never worked with data modeling or AI projects before, this is probably new for you, but we'll be using this quite a lot in our later weeks. The additional exercises or additional practice that I have for you is you can load a local Excel file and explore its structure. And then you can create a data frame from a dictionary and add a new calculated column to it. Also try to save filtered data to a new CSV file. Play around with this and let me know if you have any issues or problems, and I'll get back to you. So just to summarize, today we learned the basics of working with pandas, including data structures, loading data sets, and performing essential operations on data frames. These skills are crucial for data manipulation in data science and AI workflows. So I hope you were able to catch up. If not, I would say repeat these functions and learn them again and again. Try with different data sets and make yourself more comfortable with using these functions. If you have any issues or problems or questions, let me know. Day 4, data cleaning and preparation with pandas. Today we're going to look at how we can make sure that the data that we have is clean and is ready for pandas so we can run different statistic models on them. So first is handling missing values. Sometimes you get the data but there's not all the columns or all the rows have the right amount of data or right data in there or has missing values. So why handle missing values? Missing data can affect analysis and model performance. Pandas provide powerful tools to manage these missing data. So let's see how we can handle these missing data. So there's different methods to handle missing data. First is dropping missing values by drop NA function. We also have fill missing values with fill NA. Also, we can do linear interpolation where based on the data that we have, we can fill data which is on a similar lines to that particular data set. So that's what interpolation means. Let's look at some examples. I'm going to go ahead and start a Python file, save it in my day 4, call it day 4 underscore samples. And here, let's say we have a data frame df. Now this df, if I want to drop rows with any missing values, I can say df dot drop na. And what this does is drop na, it drops rows with any missing values. So if there is like 100 rows and 10 of them don't have any values in particular rows, it will drop those. Another way is to drop columns with missing values. So we can get rid of some of the columns altogether because that might cause some issues, or you don't even need those columns. For example, if you have a data set for property values in California, let's say, and you have some columns over there which talks about weather. Now that doesn't change the value of price because all the houses are in California, and if the weather data is missing, we don't even need that. So we can say drop NA, and in this case axis equal to 1. So what this does is this will drop columns with missing values. Next that we spoke about is filling missing values. So if we can't drop some but we need those values, so for example the same data set that I gave example of California houses, now it has salaries of people who are living in, or monthly income is available in the data set, but we have 90% of the data and 10% is missing. So if you want to fill that with, let's say, a zero amount, so you can always say df, for example, whatever the column name is, so let's say in this case is salaries, df, I can say column name, I'm just using generic column name, and I can say fill na of 0. So I can fill a value in there which is 0, which doesn't make sense with salaries, but we'll look at interpolation for that. But you can, if you want to just enter some value and it doesn't matter if it's 0 or some random number, you can save that here. So it replaces not a numbers or anything that is empty with 0. Next is there's two different types of fills, forward fill and backward fills, that you can do by saying df dot fill na and method equal to, if it's forward fill, we take the forward values, you can say ff f fill. Similarly, if you want to use backward fill, you use b fill. So this will enter values based on the data that is available, forward fill or backward fill, which kind of makes more sense, but still in salaries it makes more sense, but still is not the right way to do it. Then we have interpolation. Now you can use interpolation because it kind of uses a linear interpolation here, where you can get the data set, like for example California houses and the salaries, but now you can use linear interpolation to kind of add values that are similar to other houses, just because you want to make sure that there is no empty data set, so no empty columns. You can do that by saying, for example, column name equal to df column name, and then you can just say dot interpolate. That's the function that you call. Where did I miss it? Here, interpolate. So this will add values based on interpolation. So that kind of covers our drop missing values. So there's three different methods, as I mentioned. You drop the missing values if you don't care about it. You fill the missing values if you need the values that are available. For example, sometimes there's data available for 95% and not available for 10%. It might fluctuate your values, but depending on what it is, you want to fill some missing values, you can do that. Or you can interpolate. You add based on the data that is available, interpolate, add interpolation data to the data frame. Next, let's look at data transformation. Now there is three different things that I want to cover here. One is renaming your columns. That sometimes happens where the column is named in a data frame which is not something that you would like or you prefer. So you want to change that. That's renaming columns. You can change the data types. Sometimes you have data sets which are let's say a particular column name. You want to change that from strings to float. You can do that here, or integers to float, or float to integers. You can do that. They change the data types here. You can also add, we also can look at an example of how to convert to date time, a particular date that is given in a particular column. And then we have creating or modifying columns. You can modify a particular column. For example, if you have a column with some data but you want to multiply that with 2, you can do that here, so using data transformation. So I'll give you an example for this. I'll move these down. So let's say you have a data frame and first you want to rename the columns. So let's say df dot rename, and then inside that you specify the columns that you want to rename. What is its old name? Whatever the old name is, you want to rename that to a new name. You can do that here. So this is how you can rename any of the columns. Next thing that I mentioned about was changing the data types. Now this can be done by saying, let's say if you have a data frame of a particular column name and you want to change the data type from whatever it is, let's say you specify column name and then what type you want. So I want to convert that as type, for example, float. There are sometimes there's data sets that is available in a particular, let's say, integer 64, and you want to convert to integer 32 because PyTorch doesn't work with it, or frameworks that don't work with it. So you can do those transformations using these. You can change the data type like this. df, another one, I'll give you example that I mentioned was converting to date time. So you have data, but that is string, but you want to convert it to date time, and I specify df column name here. So what it does is it takes the existing column and which is string in this case, and it will convert to date time for us. Next, I mentioned about creating or modifying columns. So if you want to modify the data in the column, I can say that, okay, whatever the new column is, or whatever the new column that I want to use the older column, which is, let's say, existing column, and then I want to multiply all those values by 2. Just an example. So create a new column and you modify the value of that column here. So that is how you can create or modify existing columns. Next, let's look at combining and merging data frames. So sometimes you might get data frames from different places, or it might be, let's say, population data for 1990, 1991, 1992. So you have a bunch of different data sets available, but you want to combine them together. You can use the concat method, which will concatenate, which will combine data frames along rows or columns. You can do merging, where you can use the merge function, which merges data frames based on a key or condition. And then we also have joining option using join, which joins the data frames using index alignment. So let's look at examples here, how this works. Delete everything here. So if I want to combine two different data frames along rows or columns, I can say, let's see for rows first, let's say combined data set, I can say pd dot concat, that is the function. I'll say I want to use data frame 1 and data frame 2. I want to combine these data from axis of 0 for rows. Similarly, if you want to do for columns, all you change is axis equal to 1. So first one will combine the two data frames along rows. The second one will combine the data frames along columns. So depending on how you want to use it, you can use these options. Next is about merging, as I mentioned, which merge data frames based on a key or condition. So I can have a merge data set from pd dot, as I said, the function is merge, where you create the first data set, give the first data set, give the second data set, and then on which column, which common column do you want to merge them on? Common column. So let's say you have data about houses and you have data about the people, and then you want to merge both those data sets based on the salaries of or income of that particular look of house. So you can do that using this. Next, if I want to do more on the, now if you're familiar with data sets, this is, the first one was merging on a common column, but what if you want to do left join or inner join? So let's look at how would we do a left join. So I can say pd dot merge df1 data frame 2, and then you can say how equal to left and on which column, what is the column that you have, common column in both the data frames, you can specify that. So this will do a left join. If you want to do inner join, you can just say inner here and specify the common column, give both the data sets. So this is almost same as this function, just that how parameter changes. Next, about joining. Now joining data frames using index alignment, you can do that similar to above. I can say joined equal to df1 dot join, and you pass the df2 here, and you can say how equal to inner, or you can say left, just like before. But this is how you can join data frames using index alignment without the column, just the index alignment. This is what it does. Now that we learned some of these different combinations and how to play with data frames, let's go ahead and work on a hands-on exercise. Our exercise 1 is to clean a data set by handling missing values and renaming columns. The objective here is to practice handling missing data and renaming columns. What we're going to do here is we'll load a data set with missing values, then fill the missing values in numeric column with the mean, and then rename the columns to follow consistent naming convention. So let's go ahead and create day 4 underscore exercise 1.py. Now here first I am going to import my libraries, which is pandas as pd, and also import numpy as np. So I'm going to use everything that I've learned in the previous days. Then let's create a data set, a sample data set. Since we don't want to use anything that is available, I'm going to create one here, a simple easy one, where I have names. Names I can enter as a list of, let's say, Alice. We have Bob, and then we have np dot not a number, it's a missing value, and then I have David here. So these are my names. Then I have age column, and this has different values. 25, Alice is 25 years old. I don't know the age of Bob, so I'm going to say np.nan. The third person, I know their age is 30, but I don't know their name, and 35 for David. Now for their scores, let's use, instead of grade, we can use score. This code 85, 90, I don't know how much this person scored, there's no data available, and 88 for the last person. Okay, so I have my data set available. Now I'm going to say df.pd. So this dictionary that I have, I'm going to convert that into a data frame, which we saw how to do it. We just call the data frame function and pass the data to it. So we converted the dictionary into a data frame. Now that I have it, let's print our original data set of how it looks like /n, comma, it's df is what we're going to print out, the entire thing, because we don't have much data, only three columns and 4 rows. Now next, I'm going to fill in the missing values. Let's run it just to check it out. So I'm going to say Python day 4 underscore exercise 1. So here, there you go, 0, 1, 2, 3, 4. It indexed them, not a number, some missing values here and there. So now let's fill the missing values. I'm going to say df age. For age, I can just say df wherever there is an age which is missing values, fill not availables with df age dot mean of all the different columns. So based on the mean, just fill this. So it will probably be, I would say, around 30ish. So let's see what it does. So that's the first part. I'm going to say for score, I'm going to say df score. I will interpolate in this case. It's called the interpolate function. So based on the straight line, it will add some values based on the values that we have here. Now, if I want to print this thing, I can check it out. Let's go here, clear it out, run it, and this is the original data set. Now, if you look at the age, if you see Alice age, Bob's age is 30, which I mentioned, as it will be 30ish something. Score, if you see, it's 89. It's interpolated based on the values that we have here. So even if this person never gave the score, he's not a person, no name, or scored more than Alice and David. 89, pretty good, based on interpolation. Next, let's rename some columns. Let's see how we can rename columns. So I am going to say df equal to df dot rename. Now in this case, I want to rename, let's say columns equal to, I will say name. I want to change that to, student underscore name. And then I want to change score to exam score. That's what I'll specify. And then let's print this entire thing. If you saw earlier, it still kept the same names. Now when I do this, clear it out, run it, we have the new student name, exam score is available. Now I can drop this one which has doesn't have a name, but I don't want to right now. I'll keep the way it is, and this is our data set that is available. So this is what I want you to do. If you were able to follow along, good. If not, do so and let me know if you have any problems. Our second exercise is to merge two data sets and perform data transformation. The objective here is to combine the data sets and apply some transformation. What we will be doing is we'll create two data frames with a common column and perform an inner merge based on the common column, and then finally add a calculated column to the merged data set. So let's go ahead and do that. So I am going to create a new file, day4 underscore ex2.py. Okay, let's copy these are always required most of the times, and I am going to create my first data set. I will call data frame 1 equal to pd dot data frame. I'm just directly gonna call this instead of creating a dictionary, and pass it a dictionary inside it, where I'll say id is a list of 1, 2, and 3. Next, I'll say name is Alice, Bob, and Charlie. Okay, next one is, let's use age again, and this time I'll say 25, 30, and 35. So I have my first data frame. Now the second one I'll create with the same IDs. So I'm going to say df2 equal to pd dot data frame, and this frame I will give IDs are same, so I'm just going to copy this and paste it here, and then I'll say scores that these students have scored are 85, 90, and 88. So I have these scores available. Next, let's print them and check this out. So I have my first data set /n comma df1, right? And I have my second data set, I'll call it data set 1 and data set 2, df1 and df2. So I have my two data sets. Next, I want to merge the data sets. So to merge, I'm going to say merge data set equal to pd dot merge, that's the function that I'll call, pass the first data set, pass the second data set, and then how do I join it? I said I want to use inner join. And what is the column that I want to join it on? On ID. So I will say ID. Perfect. Next, let's print and see how does it look like. Merge data set /n comma merged. So that will give me my merge data set. Now let's add a calculated column to it. So we'll create another column and add to it based on the data that we have. I'm going to say merged. Let's create score percentage. And this percentage will be merged data set wherever the score is, whatever the score is. Okay, I think I have to use this bracket here. Divide by 100 times 100. So this is the percentage. And this I'll say print, and I'll say transformed data set /n comma merged. I kept the name same, so that should not cause a problem. So let's go ahead and run this. I hope you were able to follow along. If not, pause the video, just make sure that you are at this point, and then run Python day 4 ex2 actually. So I'm going to go ahead and say ex2, and there you go. Our data set initially 1, 2, 3, first data set, Alice, Bob, Charlie, their ages. We have their scores here. Now it's a merged data set 1, 2, 3, Alice, Bob, Charlie, 25, 30, 35, and their scores here. Transform data set, I got the percentage. Now this is out of 100, so of course the values will be almost same unless I change this being out of 200, then it will be 200 and will be half of it, most probably 42, 45, and 44. So that's how this works, and I've created it. So this can be helpful even in like this data set where you have a data set with all the students and you have their scores in a different data set, and then you want to also calculate the percentage, so you can use this entire data set to get what is the overall percentage of students that you have, or how many of them passed, or what is the grade level in there. So you can use this data set for additional calculations. Now that you've completed this, for additional practice, you can drop columns with more than 50% missing values. You can merge 3 data sets and analyze relationship between them. You can also do convert categorical data to numerical using one-hot encoding. If you don't know what that is, look it up, but we'll be covering that in the future. So just to summarize, today we learned how to clean and prepare datasets using pandas, focusing on handling missing values, renaming columns, and combining data frames. These skills are essential for pre-processing data in data science and AI workflows, and we'll be using this quite a lot in every single project. So if you had any issues or problems, let me know so we can catch them early, and then you can move on to the next days. Welcome back to day 5. Today we are going to cover data aggregation and grouping in pandas. Let's start with grouping data by categories. So now, why group data? Grouping data allows you to perform operation on subsets of data based on shared categories. We can do group by using group by in pandas. The syntax for this is something like, let's create a new file first, Python save it inside day 5. I'm going to call it day 5 underscore samples. And here, let's look at the syntax. So grouped equal to data frame dot group by, and then you select the column name here. So that's how you use, that's the syntax for group by. So now let's go ahead and look at what are the different operations that are available. Now first you can go over, iterate over groups. So you have a bunch of groups, and you can iterate over this by name and group. You can do that by saying, let's go ahead and say for name comma group in grouped above. So this group that we have, I can print name, I can print group. So based on that, it will iterate over the groups, and you can display the name and the group out here. Another operation is to apply aggregation. This can be done using, you can say grouped dot mean. This is a function that you can use, and you can also say grouped dot sum. So you can apply these aggregation functions to a grouped category. Next, let's look at aggregation functions. So first is using group by. We can combine grouping with aggregation methods. We can do that by saying something like this. I can take a data frame, and say group by, and to that I can specify a category column, let's say, and then I can say numeric column, numeric underscore column, and then directly give mean to it. So this will give me the mean of that particular columns grouped together. Next is I can say group by category underscore column dot agg. Now this is the aggregation function where you can specify the numeric underscore column, and of that column you can specify in a list format of what all you're looking for. For example, I can say I'm looking for mean, max, and looking for min. It will do that all together. This is the power of group by, where you can combine grouping with aggregation methods. Next, we have using the pivot table. Now you can reshape the data with aggregation if you use pivot table function. So that can be done using, let's say I say pivot equal to data frame dot pivot underscore table, and to that I can say values equal to numeric underscore column. I can say the index that I want to use is category column, and the aggregate function that I want to use is mean. So this is another way using pivot table you can do this. Another aggregate function that we can do is custom aggregation. Now this you can apply custom function using agg function. So that can be done using, I can say, let's say I create a function called as range underscore function. This is my range function which takes an input of, let's say, x, and then I can say return x dot max minus x dot min. Now if I want to use this range function, this is my custom aggregate function, I can say df dot group by category column numeric, close this, numeric column dot right here dot agg. Actually this doesn't need a group by category column of let's close this, of numeric column dot agg range, the function that we have created, range function, and it will pass those values and it will group by based on this custom function. And we'll be doing a lot of these in our hands-on, so if you don't understand exactly how it will work, I'm going to show you some samples in the in the hands-on. So that's what we just saw. We saw the app, how to apply custom functions using AGG here. We used this range function. We created a custom function and we applied to that, which is x max minus x min, which will kind of give you the difference between the maximum and minimum. Next thing that I want to look at is calculating summary statistics for group data. So if you have group data, how do you get the statistics for it? So some of the common statistics that you can get are mean, max, and min. So I'm going to go here. I have my category column. Now to get the mean, I can just say mean something like this. Let me just make sure that I keep the previous one. Move it up. So a category column, and then here I can directly use the mean function and get mean from it. Similarly for max, all you do is change this to max, and now I know how I know you know how to do min is this way. So these are the three functions that are common statistics that are available for us. Now if you want to do multi aggregation, that's our next topic of how to do multi aggregation. That you can do in a similar format which we saw a little bit earlier, group by, and here I can just say dot aggregate, which applies to numeric column. Close this, and of this I am looking for, what am I looking for? Let's make sure everything is closed. I'm looking for mean, comma, max, max, comma, min. That's what I'm looking for, and this aggregation function ends at the end here, something like this. And if you want to format it nicely, you can always have it this way. So now I'm grouping by multi-aggregation, where I'm saying I want to group by based on mean, max, and min. That's it. So these are different things that I wanted to cover inside inside data aggregation and grouping in pandas. Now let's go ahead, and to understand it better, let's jump into hands-on exercises. The first exercise that we are going to do is we are going to group data by a categorical column. So we'll load a data set and group the data by categorical column. First, we'll load a sample data set with a categorical column inside it, and group the data by categorical column and calculate the mean for each group. Those are the steps that will follow. Pretty much 2 steps that we'll do to see how all this works, comes together. Save this. I'm going to create a new file. I'm going to call it day5 underscore exercise1 dot py. Inside this, first let's import pandas because we are using the pandas functions. The sample data set, let me create a data set here where I have class which is A, B, someone else got A, then someone got B, someone got C, and then I'll use one more C here. So these are different classes that are available. Next, I'm going to say the score for each one of these is, let's give some numbers, 85, 90, 88, 72, 95, and 80. So I have my numbers. Next, I am going to create one for age where it will show the ages. I'll say 15, 16, 15, 17, 16, and 15. So I have that. I have 3 columns here: class, score, and age. Now let's create a data frame out of it. It's very easy, as you've done it already so many times. Data frame, and pass it this data. So I'm creating a data frame from a key value or dictionary. Once I have that, let's print out the original data set /n, and to this I'll pass df. So I have my data set. Now let's, as I mentioned, group by class and calculate the mean. So the categorical the categorical column that we're going to select here is class, and we'll calculate the mean. So to do that, I'm going to say grouped equal to, I'll take the data frame and I'll say group by, and I'll select the categorical column class, and I'll look for mean. Now let's go ahead and print this out, grouped. Let's see, how does it group back? I'm going to go back here, ls, and I'll say Python day5 underscore ex1. Run it. This is my original, as you know, ABC, AB, AB, CC, and these are the score, and this is the age. Now here it's grouped based on this categorical class A, B, and C. They're grouped together based on class. That's what we mentioned, and it got a score. So if you got the mean score for A, which is 86, based on this and this, B, it got based on this and this, 81, and C. So it grouped them properly and gave me the statistics of mean for this particular project. Next, I'm going to do exercise 2, where we will calculate the summary statistics for group data. So the objective here is to use grouping and aggregation function to calculate summary statistics. First, what we'll do is we'll group data by a categorical column class that we've used before, and then calculate the statistics like mean, max, and min for numeric columns. So we already have created this project, so we can just work off this. I am going to comment this out. I have my original data set. Now if I want to get the stats, I'll say stats equal to df dot group by. I want to group them by class, and since I want all the different aggregates, and I want it for, let's say I want it for score this time, same as before. And here, what are the different things I want? I want mean, max, and I want min. Now if you want to add also age, because we did that before, you can also use age, and inside this I can copy and paste the same stuff. Now let's print this out and see how does it look like. Go back here, clear, and there you go. So we have the class ABC, and mean, max, and min are calculated and given to you in a nicer data set for both score and age in 2 different columns, and they have sub columns for mean, max, and minimum. So there you go. This looks like what we wanted. We grouped the data based on the class, and we got all the summary statistics for this grouped data. I hope you were able to follow along and understand. If you have any questions on this, let me know. It just helps you group different types of data types together and then get mean, max, and min, or different statistics information based on what you're doing. Another option is, if you want to do some more additional work, you can practice with creating a data set of sales data and group it by region or product category. You can find these data online, so you can pick that. You can use the pivot table to calculate total sales per region and per year. Also, you can create a custom aggregation function to calculate the variance for each group. And again, while working on these, if you have any problems or questions, let me know and I can help you out. So to summarize, today we learned how to group data and calculate summary statistics using pandas. These techniques are fundamental for aggregating and summarizing data in preparation for analysis or visualization of the data when we are doing some AI projects in the future. Day 6, data visualization with Matplotlib and Seaborn. Now, what's the fun in working with all the data if you can't plot your data? So this day is dedicated to that. Let's start with introduction to Matplotlib for plotting data.
Now, what is matplotlib? It's a foundational Python library for creating static, interactive, and animated plots. It allows for detailed customization of plots. Let's look at the basic syntax for using matplotlib. So I'm going to go ahead and create a new file, Python, save it. In my day 6, I'm going to call it day 6 underscore samples. And here I am going to first import matplotlib dot pyplot as plt. I'm going to use that alias. Now let's do a basic plot. So I'm going to call it basic plot. To do that, let's say if I have a list of items x equal to 1, comma 2, comma 3, and 4, and then I have y, which is say 10, comma 20, comma 25, comma 30. So these are my basic x and y. And if I want to plot this, I can just say plt dot plot, and x and y is what I want to plot. And if I want to see it, plot dot show. As simple as that. Let's go to our terminal, clear it out, and I can say Python day 6 underscore samples, and there you go. We see our plot here, x-axis and y-axis, and based on the coordinates that I've given, it has plotted that plot here using matplotlib. Next, let's look at some basic plots. We have the line plot used to visualize trends over time or sequences. We just saw one which is similar to that, but we can create another one. What I can do here is I can say plt. I can keep this actually just for future. So for line plot, let's say line plot plt dot plot. I can directly use that, and instead of creating variables, I can say 1, 2, and 3 here. Give the first list. I want to give the second list, which is 10, 20, and let's say 30. And I am going to give label equal to trend plt dot title. I'll give it a title. In the previous one we didn't give title, so this will give you an idea of where the title shows up. I'm going to call it line plot. I can give other attributes like x label, which will give a label to the x-axis. I'm going to just call it x-axis. And next I'll say plot dot y label. Again, as you probably guessed it, we'll call it y-axis. And then next I am going to say plot dot legend, create a legend for this, and plt dot show. So now if I run this, I have a straight line because 1, 2, 3, 10, 20, 30 will be a straight line. You see x-axis, you see the line plot, y-axis, all those labels are displayed. So this is a simple line plot. Next, let's look at bar chart. Now bar chart, as you probably have seen, is a bar of bars displayed. So for that, comment this out, go up here, and say bar chart. And this, what it does is used for categorical data comparison. That's what bar charts are usually used for, whereas line plots were used to visualize trends over time or sequences. So I am going to say categories equal to, I'm going to create a list of categories, and just to make it simple, I'll call it A, B, and C category. Next, I will create a values list which will have, let's call it 10, 15, and 7. You can probably already draw the bar chart in your head. So I can say plt.bar, and here I'm going to say categories. I pass categories. I'll pass the values, and I can also pass color. In this case, I am going to use, let's use blue color. Plt dot title. For title, I will give bar chart, how original, and then say
plot.show. Run this. Oh, okay, this is still running, I guess. Run this again, and there's my bar chart with my values, which are A, B, and C categories, and I have 10, 15, and 7 displayed right here, and the color is blue. You can change that to whatever you want, customize it to however you want. Next one that we're going to look at is histogram. Now, histogram shows the distribution of a data set. So for that, comment this out first. And the thing that we want here is histogram. For histogram, I'll give a data set. I'll use 1, 2, 2, 3, 3, 3, 4, 4, 4, and 4. Bunch of data set points here. For plotting histogram, you say plot.hist, and inside here I have to give the data. Next, I need to get how many bins I need to create for this histogram. I'm going to say I'll create 4 bins. Color that I want to use equal to green, since we used blue last time. And there's also something called as edge color. I use black for that. So that's how you create it. Now I can give the same all parameters. I'll just give title for this again, histogram, and then I'll say plot.show. Save it, run it here, and I have my histogram with all those 1s, 2s, 3s, and 4s displayed right here in a histogram format. And we have 4 bins, and it has color green, and the edge color, which is black, is displayed there. So that's it. I'm going to close this up. Make sure this is closed. Clear. Next thing that I want to talk about is scatter plot. Now, scatter plot visualizes the relationship between two continuous variables and used quite a lot in AI projects. So I am going to go back here, comment this out, x, or just say this is scatter plot x equal to, let's give it some numbers, 1, 2, 3, 4, and 5. I want to give some numbers to y, probably 10, 12, 25, 30, and 45, some random numbers. Now to create the scatter plot, I call plt.scatter or plot.scatter, give x and y, and the color for the scatters I'll give red. Plot.title, I'll call it scatter plot. Next, finally, just say plot.show. Let's look at how the scatter plot look like. Run this project, and there you go, a scatter plot. So think of it, if you have like a big data set, how it will look. And that's what you see quite a lot these days when data scientists talk about their scatter plots or data items, or how it's scattered and how they are classified into different places. And so this is very useful for building things in future. So I'll go ahead, clear this out. So that's all that I have here. Next, let's talk about customizing plots. Now we saw that we can add title, X label, Y label, legends, all those things. What are the different things we can do in here? So we can add, as I mentioned, titles, axis labels, we can give legends, we can adjust the colors and styles. So let's look at some of those things that we can do. I'm going to use this exact same thing here that we have here. We already gave a title. We can give X label as X axis label. I can do the same thing for Y label, Y axis label, and I can also give a legend. For now I don't have any legend, so I'm just going to create an empty list and call it dataset 1, something like this. Go back, run it, and we have this here. You see the legend on the top. I can give multiple legends in the list, and you see the entire x-axis and y-axis. Title is already given, scatter plot. I can also change the colors. So when I plot a particular thing, for example, if I want to plot. Let's use one that we plotted earlier. So I'm going to comment this out, go here, and when I plotted here x and y, we gave the label as trend, and then we can also give color as, let's say, orange. I can give what else can I give? I can give line style because this is a line graph equal to, if I want to give dotted, I can just say dash and dash, and I can give marker equal to small o, something like this. If I run this now, let's make sure that our plot is closed, clear, run it again, and there you go. Our dotted lines are orange. We have color orange, line style dashed because of this, and marker is 0. That's what I've given here. You can also use x for this, and there you go. Now we have x points over there. That's how it looks like. So these are different customizations that you can do to plots. Clear this out. Next, let's get introduction to Seaborn for advanced visualization. Now, what is Seaborn? Built on top of Matplotlib for easier and more visually appealing plots, Seaborn was born to bring some more customizations to Matplotlib. It provides a high-level interfaces for statistical graphics. Some of the common Seaborn plots include, we have the heat map, which visualizes a matrix of data. We have pair plot, which shows pairwise relationship in a data set. We can kind of test these out. What I'm going to do is I am going to take this same project, import Seaborn as SNS. Next, I am going to import NumPy as NP. So now let's get some data equal to np dot, I'm going to just create some random integers here, random numbers of 5 by 5, and then I'll say sns dot heat map. This is for the heat map that visualizes a matrix of data. So you can give the data to that since we created that matrix data above. I'll say annotations equal to true, and then cmap equal to, it has bunch of different uh, things that you can use for colors, and for that I'm using cmap, which has bunch of different options. I'm going to use cool warm. Next, I'm going to say plot dot title is heat map, and as usual plot dot show. Save this and I'll run it here, and there you go, our heat map. Pretty cool, right? So based on the matrix that it created of 5 by 5 matrix, it has this 1 2 3 4 5 1 2 3 4 5 items here, and it shows the heat based on where the numbers have been randomly created. Of course, every time you run this, it will look different because I've not given a seed. So if I run it again, it will look a little different from the previous one because it randomly generates these numbers and then makes this heat map out here. Next, for pair plot, which shows pairwise relationship in a data set, you'll have to say, instead of saying this, we comment this out, you say sns dot pair plot, and then to that you'll give df, which is the data frame, which I don't have it right now, but we'll see in one of our hands-on example, and then you say plot dot show. That will give you or show the pairwise relationship in this particular data set, and we'll look at those in our hands-on. But that's those are the two different heat maps and pair plots that you can do using. So these are the common Seaborn plots that you can build. Next, let's run to our hands-on exercise. So based on whatever we have learned, first exercise, we're going to create basic plots with Matplotlib. The objective here is to plot a line graph, a bar chart, and a scatter plot. So what we're going to do is we're going to create data for trends, categorical comparisons, and relationships. And then we're going to customize plots with titles, labels, and legends. So let's get started with exercise 1.
I'm gonna close this and create a new file. Save it as day 6 underscore exercise 1 dot py, and make sure my other projects are closed. So I'm gonna close this, go back to here, clear this out. Now, to start with, first we need matplotlib. Import matplotlib dot py plot as plt. So first step is to create a line plot, but for that we need some data. So I'll create an object variable called as years, and inside this I'll say 2010, 2011, 2012, 2013. I will say sales number for these years include 100, 120, 140, and 160. Good sales numbers, increasing, of course. plt dot plot, I'll pass the years as x and sales as y, and then I'll say label equal to sales trend. I will give a color of blue, even though it's very bright. I'll use the marker of O, and then I'll say give a plot dot title of sales over years. Next, I'll say plot dot x label. I'll give x label as is our years, so I'm going to say years. plt dot y label is our sales, so I'm going to say sales. And then let's display the legend and display the plot. Do this, go back here. It's already cleared. I'm going to say Python day 6 underscore ex1, run it, and we have our line plot here based on the years and the sales. So that's pretty cool. We have the legend word displayed. Perfect. Next thing that I want to do is a bar chart. So I can say bar chart. I'll create different categories. For this, let's use electronics. Another category is clothing, and another one is groceries. You can pick whatever you want. I'm just choosing randomly. Revenue for these is, let's say, 250 for electronics, 400 for clothing, and 150 for groceries. Now I'm going to say plot dot bar because I want to display a bar chart. I'll pass it categories and revenue and give a color of green. Then I can say plot dot title. I'll give it a title. I'll say revenue by category and show this plot. Now if I run this, I have my line plot. Close this. I have my bar chart. I should have commented that, but if you close that, the next one will run and show you your categories. You'll show your revenue here, and we have three different numbers: 250, 400, and 150, depending on what it is, and that's why it is up and down. It's a bar chart. So there you go. We have our bar chart. Next thing that I want to do is the scatter plot. So for this scatter plot, what you need to do is first use let's say hours studied, of how many hours I studied. If I study 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours, what's the difference? Exam scores based on how much I've studied. So if I study 1 hour, I get 50, 55, 65, 70, 85. Just from the graph you can say, depending on how much you studied, better you scored in your exams. Next, I'm going to say plot dot scatter. I'll pass this hours studied, pass this exam scores, and I want to display red as color for these these scatters. Plot dot title
study hours versus exam scores. I'll say plot.x label is hours studied. I want to use a y label too. I'll call it exam scores. And then finally I'll say show me this plot. Run this and I have my exam plots based on how much more I've studied, more I score. So these are the three charts that we created. We created a line graph showing sales trend. We did a bar chart showing revenue comparisons, and then we did a scatter plot showing the relationship between study hours and exam scores. So I hope you were able to follow along. If not, let me know and I can help you out. But let's move on to exercise 2, where we will be creating a heat map with Seaborn. So the objective here is we'll use Seaborn to create a heat map from a correlation matrix. Instructions that I can follow here is first I'll load a data set and calculate the correlation matrix. Then I'm going to visualize the correlation matrix using a heat map. In this particular case, I will be loading up that same Iris database that we loaded earlier in one of the days this week. So I am going to go here and create one for day 6 underscore exercise 2.py. And this is the URL that we're going to get the data from. So first, let's get pandas as PD. Next, we need Seaborn as SNS. Next, I want to use the matplotlib matplotlib.py plot as plt. So I have these three. Next, let's load the data set that we have. So I'm going to say pound, let's copy this from here, load data set, and I am going to say df equal to pd dot read csv, and this csv is coming from this URL. So I have my data set. Now next, let's calculate correlation matrix. To do that, I'm going to say correlation. This is just a variable, so it doesn't matter if there's a typo. Say df dot corr. That's the function that will give us the correlation matrix for the data that we have, which is the types of petals, the petals we have. Next, I am going to say plot the heat map. Now to plot it, I'm going to say sns dot heat map. I'll pass the correlation. Where is it? Correlation matrix. Next, I will. Should have some equal to. Next, I want to give annotation equal to true annotated, and CMap. If you like the previous school worm, I'm going to use that same heat map. Plot dot title equal to correlation heat map. Next, I'm going to say plot dot show. So this should show me a heat map with annotation showing correlations between numerical columns in the data set, which is our, if you remember this, I can open this up again in Chrome. And there you go, sepal length, sepal width, petal length, petal width, and species. So I will run this up in my, okay, I think we have a graph running. Close this, clear Python day 6 underscore ex2.py. Run this, pull the data, could not convert string to float for Setosa. The last column that we have over there is not numbers, is not numerical, so it will cause problem for that. So what I'm going to do is I'm going to drop that column from my data frame.
So to do that, I can just say del df, and that column was called, let's open that data set again. It was called species. Go back and I'll say drop that. Let's go back, clear it out, run it, and now we have it based on the other items that we have: petal width, petal length, petal sepal width, petal length, and petal width. It has the heat map depending on how the correlation matrix shows up. So if I hope you were able to follow along with this. If you have any questions or had any other issues, not something that I'm facing, let me know. For now, for additional practice, you can look at how to create a histogram with multiple data sets overlaid. That's one thing that you can try. Next, you can try is use Seaborn to create a violin plot or box plot for visualizing distributions. Next, try to combine multiple plots in a single figure using matplotlib's subplot. So try this out and let me know if you have any issues or problems. So today we learned how to visualize data using Matplotlib and Seaborn, focusing on basic plots, customization, and advanced statistical visualizations. Now these skills are crucial for presenting data and uncovering insights in data science and AI projects that we'll be working on in the future weeks. So let me know if you were able to follow along. If you had any questions or problems, let me know and we can move to the next day. See you tomorrow. Day 7, Exploratory Data Analysis, or something called as EDA project. So here on day 7, we're going to create an exploratory data analysis project. To do that, let's look at all the different steps that we need to follow. First, applying data manipulation and visualization for EDA. So what is EDA? Exploratory data analysis involves summarizing data sets to uncover patterns, relationships, and insights. Now, the steps in EDA include first data cleaning, handle missing values, remove duplicates, and fix inconsistencies. We have seen that before earlier this week. Data transformation, changing data types, normalize data, and create new feature if needed. And that's also something that we saw this week earlier. Aggregation and filtering, summarizing data and applying filters to focus on specific aspects. Again, something that we've already covered this week. So we are going to put all these steps together, and that's what is called EDA, or exploratory data analysis. Next, let's look at identifying patterns, trends, and correlations. Some of the visual tools that we use for these insights include line plots for trending data over time. We do bar charts for categorized comparisons. We use scatter plots to find relationships, and we use heat maps for correlation analysis. And we already learned how to build all these line plots, bar charts, scatter plots, heat map. Using Matplotlib and Seaborn, we can build any of these. Next, the key patterns that we are looking for is relationship between variables, which is correlations. We're looking for distribution of variables, how to build histograms, box plots, and we'll find the outliers or anomalies. These are the patterns that we're looking for. Let's talk about the summary statistics, visual insights, and hypothesis generation. Our first thing, summary statistics, we have already seen how to get these. You can create a data frame and call the describe function, which will get you the mean, the standard deviation, the min values, the max values, and much more. So that's already taken care by the data frame's describe function. We have df.correlation, which provides your correlation matrix, which we looked at when we created a Seaborn matrix earlier this week, where we took the iris data about all the petals of flowers and we created a correlation matrix over there. Next, about hypothesis generation. Now formulate hypothesis based on observations. For example, we're going to take Titanic data set in this particular today in our project, in our hands-on, and one of the examples over there is passengers in higher Titanic classes have higher survival rates.
Is that true? Is that the hypothesis that is true? Now you can use EDA to validate or refute these hypotheses, and that's what we will be doing. So we take the Titanic data set, and our hypothesis is passenger in higher Titanic classes have higher survival rates. Now, based on common sense, or if you've even watched the movie, you probably have seen higher Titanic classes, customers over there were allowed on the deck and they could get out of it there easily. Whereas passengers in the lower classes were locked downstairs. So there's much less survival rates for them. But at the end of the day, you know what happened. But we are going to use the data set now to kind of validate or refute these hypotheses using EDA. That's what we will be doing. So let's jump directly into our hands-on EDA on a sample data set, which in our case we'll be picking up Titanic data set. The link I'll provide you in a second, but our first task in this particular project will be to perform data cleaning, aggregation, and filtering. The data will be available using this URL, which is something similar to Irish dataset. It's a CSV file here, Titanic CSV, which is available in GitHub usercontent.com slash data science dojo slash datasets master titanic.csv. It has passenger ID, if it survived or not is 0 and 1, PC class, what class they belong to, third class, first class, name of that person, sex, age, SIP, SP, barge, tickets, fare, cabin, and embarked. So it has all this information that we can use, and it has a bunch of data available for us. So using these data set, so we have from passenger ID 1 all the way, okay, let's close this, all the way to passenger ID 891. We have these many records. Now, again, this data set might not be clean, so we will be performing data cleaning, as I mentioned, aggregation and filtering to this particular data set. So first step that we'll be following here is load the data set and inspect its structure. Then we will handle the missing values, duplicates, and inconsistencies in here. Then we're gonna apply filters or aggregation to summarize specific groups. So let's go ahead and create a project. I'm going to start a new project, Python file, save it as day7 underscore ex. And here I am going to first import pandas as PD. I need to load the Titanic data set, so I'm going to copy this URL. You can take this URL from here, load Titanic data set. Let's get the URL equal to, again, it's https raw github usercontent.com data science dojo datasets master titanic.csv. And then I'm going to create a data frame out of that, pd.read underscore csv, and pass the URL to this. So I have loaded my Titanic dataset. Next, let's inspect the data. So for that, I am going to say print df.info, get some basic information. I'll also get some stats of it. So I can say df.describe. And so let's run this just based on what we have right now. I'm in the right file. I am going to say Python day7 ex.py, and here is our first few rows, the first info about this particular right here. The information is available here, passenger ID survived, all these different columns that are there, not null, non-null count. If you look at it, some of them don't have age information. The cabin information is not available for all the data sets. There is 889, 891. So there are some things missing in here, as what we can say. And this is the basic describe, which gave us some stats on count, mean, standard deviation, minimum 25%, 50%, 71%, and max of the values that are in the data set. So that's pretty good. I'm going to take that data, and first what I'm going to do is I am going to handle the missing values. What do you recommend we do here? So as I mentioned, there is probably age which is missing over here, I am going to give a median of based on the other ages that are there. So df age dot fill na wherever is not available. I will fill df age dot median. That's what I'm going to fill here, which makes sense because ships back then were taken based on a particular age criteria, and whatever is missing we can just fill that by that. We'll also take the embarked data, which is I think there. Let's see, embarked, which is 889 non-null. I'm going to take that, and over there I'll fill the mode for it. df embarked. For this I am going to say if not available, I will use df embarked dot mode of 0. So that's what I'll fill this with. So that will kind of takes care of our handling the missing values. Next, let's remove some duplicates. Let's see if there's any duplicates and remove duplicates here. Even if it doesn't have duplicates, it's a good idea to run this df dot drop underscore duplicates. Just running this function will drop duplicates. You don't have to do anything special for this. So why not just use it anyways? Because having duplicates will kind of cause problems in your data set. Say filter data, next one, passengers in first class. So let's do that. I'll say first underscore class is a variable that I'm creating, and here I am going to say df, and for that I think we use p class as you've seen equal to 1. So this will give me all the first class passengers, all data for that, and I can say print first class passengers slash n comma first class dot head. Just let's look at the top 5 of them. I'm going to save this, go back here, clear it out, run that project, and we have the data here. So we are displaying the information again. We're displaying the description with all the different count, mean, median, everything here. And then for passengers with first class, I'm displaying their information or just the top 5 of them. So that's our task 1. Our task 2 now is to generate visualizations to illustrate key insights. So we're going to create visualizations for trends, comparisons, and distributions in this particular case. So what I'm going to do is I'm going to go back here, and for visualizations we need matplotlib dot pyplot as plot. Next I'll say import seaborn as SNS. That's what I need. Now to build, now I'll go all the way to the bottom. Now first I want to display a bar chart. This will display survival rate by class. Now to do that, I'll create a variable survival by class equal to df dot, I'll use that group by that we have learned earlier, group by, pass the p class as the class that I want to display, and then I'll get survived out of that. So group them together and get the mean out of it. So that will give me survival by class. Next I'm going to use the survival by class and plot kind equal to bar, and color, let's use sky blue this time, make it a little bit lighter, sky blue. Next I'm going to say plot dot title. I want to use the title as survival rate by class.
I'll use plot dot y label. I'll not create x label. Survival rate, since it's a bar chart, and then plot dot show will show me that bar chart. So let's run this and see how does it look like. And there you go. We have our bar chart in sky blue, which looks much nicer than others. Now, depending on class, what is the survival rate? So from the data itself, we can say that more people survived in first class, then second class, and then finally third class. Next step, let's first close this. I'm going to clear this out and then go back here. And next, we're going to create a histogram of age distribution. So I'm going to say histogram age distribution. So I'm going to use Seaborn for this. So I'll probably say SNS dot hist plot, and I'll use df of age, comma. Next thing is my KDE equal to true. Next, I want to give how many bins I want for this histogram, which is I'll select 20, and color equal to, I'll use purple this time. Next, I'm going to say plot dot title. I'll say age distribution. Next, I'm going to say plot dot x label is age. Plot dot y label is frequency, and I'll say plot dot show. I am going to comment this out so that doesn't draw on top of this. So we have our histogram. So let's go ahead and run this. And we have our histogram displayed depending on the age distribution. So depending on what your age is, that's how many passengers that were there in the Titanic. So see, most of them are focused towards from 25 to 30 around, I would say. So that's the data that we have. Now close this, clear this out, go back here, comment this out. The next thing that we want to do is a scatter plot of age versus fair. So I'm going to say scatter plot, and this is age versus fair. So for that, I'm going to say plot dot scatter. I'm going to use age for it, age. I'm going to say df y-axis is another thing that I'll use is fair. Then I'll say alpha is how much transparent I wanted, 0.5. Next is color equal to green. I'll use that. I'll give a title this time as age versus fair. I'll give the X label as age. I'll give Y label as fair, and I'll say plot dot show. So let's try this out. And there you go, a scatter plot, age versus fair. So depending on how much more older you are, more you're paid. Nope, it's actually, this is where most of the scatter is, which is that the fare that you paid is somewhere around here at the age of 30. So this is shows you the scatter plot for that. So that kind of concludes our task 2, where we generate visualization to illustrate some of the key insights. Next task is to identify and interpret patterns or anomalies. So what we're going to do is we can use the visualizations and summary statistics to identify these patterns that we looked at and look for anomalies such as unusually high fares or missing data trends. Some of the example observations that I can mention based on our plots is higher class passengers have higher survival rate. We saw that in the first plot graph. And older passengers paid higher fares. That's what we saw in our scatter plot, where the concentration of older people had more higher paid fares. Our task 4 is to summarize
findings in a report. Now, the things that we'll do here is we'll create a report summarizing insights, including key visualization and statistical summaries. And you can upload these different plots that we did to that. Some of the plotting looks like, if you want to create a document, it looks something like this, where I can say Titanic data set EDA report. This is how you'll create a report if you're a data scientist. I'm going to get rid of that. And here I'm going to say one overview section. I'll create overview section where I can say data set contains around 891, I think, rows and 12 columns. Next, I can specify that missing values handled for, we did for age. And what did we do for that? We filled with median. That's what we did. And we also did something for embarked, and that was we filled that with mode. So I can say filled with mode, something like that. Next, you can give, so I can skip this, that's basic overview. Next, I can say key insights. Make sure I don't type it wrong. Next, I can say survival rates are highest for first class passengers. It's around, I think, 62% based on the plots that we have seen, and lowest for, we had second class and third class customers, but it was lowest for third class customers, which is around 24%. So you can display those, kind of attach those graphs that we have created here, the plot that we have created. And I can say majority of passengers are aged between, we checked the age distribution, it was between 20 to 40 years and mostly between 25 to 30 years. So you can specify that and display your plot here, which you can include the screenshots. And a positive correlation exists between fare and survival, because we saw that older people paid more amount, which means they have higher survival rate because they were in the first class category, whereas the younger people who paid less fare had less chances of survival because they were in third class. And then finally, a third ones which we did was visual insights. So based on whatever we did above, so what we can do is you can include the screenshots of those plots right over here. So this is how a EDA report looks like, and this is what is expected as a delivery. You have the clean data set with missing values handled and duplicates removed, a set of visualization showcasing trends, comparisons and relationships, and a written summary of key findings, patterns, and potential hypotheses. That's what we give. Now, for additional practice, what you can do is you can use another data set and apply the same EDA steps. You can explore advanced visualizations like box plots or pair plots in Seaborn, and you can create a dashboard for your findings using Plotty or Dash, which are other tools that are also available. So, to summarize, our last day of week 2, we applied our pandas knowledge and visualization skill to perform a full EDA project, uh, culminating in a report that highlights our ability to manipulate, analyze, and visualize data effectively. This is very helpful in the world of data science to provide reports to data scientists and to business managers, which can make decisions accordingly based on the reports that you specify. So I hope you were able to follow along. If you have any questions or problems or issues, let me know and I'll get back to you.
Welcome to week 3. Mathematics for machine learning. Day 1 will be looking at linear algebra fundamentals. Day 2, advanced linear algebra concepts. Day 3 will be covering calculus for machine learning, which will cover specifically derivatives. Next, on day 4, we'll be doing again calculus for machine learning, but this time with integrals and optimization. For day 5, we'll be looking at probability theory and distributions. For day 6, we'll be looking at our statistics fundamentals. Finally, on day 7, we'll be doing our math-driven mini project on linear regression from scratch. So let's get started with week 3.
Welcome to week 3, day 1. Today we are going to cover linear algebra fundamentals, one of my favorite topics in school, and I hope you enjoy this one. First, we're going to look at vectors and matrices. Now, what is a vector? A vector is a 1D array representing quantities with both magnitude and direction. It looks something like this. Example, more like a list format. Then we have a matrix. A matrix is a 2D array of numbers arranged in rows and columns. One of the example is this, where we have a 3 by 3 matrix displayed here, where its values are 2, minus 3, 1, 2, 0, minus 1, 1, 4, and 5. It's kind of, you read it out from left to right, and then you go down every single row. Let's talk about the properties. As I mentioned, the matrix is kind of read out as 3 by 3 or m by n, where m is the rows and n is the columns. A vector, on the other hand, is a special case of a matrix with one row or column. As you can see above, we have a list 2, 3, and 4. That's a matrix with only one row or column. Now let's go ahead and talk about matrix operations. We have addition and subtraction first. Matrices must have the same dimensions. For element-wise operation, I can give you an example. What we can do is we can create a new file, Python, save it as week 3, day 1. I want to make sure I'm in the right folder, day 1 underscore samples. Here, I am going to first import NumPy. If you have not gone through week 2, I would probably recommend you go to week 2 to understand whatever we are doing, because we'll be using NumPy quite a lot. I'm going to create a matrix here by using np.array, and in here I'm going to make a 2 by 2 matrix, 1, 2, 3, 4. So I have my 2 by 2 matrix here. Similarly, I'll create one more, call it B, and here I'm going to add values a little bit more than that, 5 by 6 and 7 and 8. So I have my two matrices here. One is A and one is B, and the values are 1, 2, 3, 4, 5, 6, 7, 8 for these two matrices or two variables that we created, A and B. Now if I want to print the addition between the two of them, I can directly say A plus B because these are NumPy arrays, so I can directly use that. Similarly, I can also do subtraction by saying A minus B, and it does, as I mentioned, element wise addition and subtraction, which means it will take each element and take the corresponding one to it and do the operation. So if I run this, let's open my week 3 day 1, perfect, Python day 1 samples, and it will give you the solution here, 6. Okay, it's always good to put it on the next line so it looks much more clear. Clear it out, run it one more time. I have 6, 8, 10, 12. So 5 plus 1, 6 plus 2, 7 plus 3, and 4 plus 8, 12. Similarly, 5 minus 1 minus 5 is negative 4, 2 minus 4, 6 is minus 4, 3 minus 7 is minus 4, 4 minus 8 is minus 4, and that's why we have this subtraction here. I can always do other way around. So it's all positive numbers, see 4, 4, 4, 4. So you can always do element-wise operations for addition and subtraction. Next, we want to talk about scalar multiplication. Now this is not a matrix multiplication, that's something else we will talk about, but scalar multiplication is you multiply every element in the matrix by a scalar. So what happens in that case is, so for example, I want to create an array C, which is 2 times A. So this is where you give a scalar value to a particular matrix. And now if I print it out, multiplication /n, comma, C. So what this does is it does something similar to addition, but it will take the value 2 and multiply with every single element inside the matrix A. So if I run this, I have 2, 4, 6, and 8, because 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. And that's what we get in scalar multiplication. Another operation that we have, which I want to talk about, is matrix multiplication. It requires the number of columns in the first matrix to be equal to the number of rows in the second matrix. So because of the way the multiplication works. So you have to remember again, number of columns in the first matrix to be equal to the number of rows in the second matrix. The reason is the formula for this goes something like this. Let's say A and B are two matrices, and I and jth element of A times B should be equal to summation of n equal to 1 to k, A ik and B kj. So if you see, the rows and columns kind of multiply with each other. That's why the number of columns in the first matrix should be equal to the number of rows in the second matrix. Now if you want to use it in Python, the way we do it is A equal to np dot, let's say we already have the arrays, so I'm not going to create again, I'm going to just use them. Let's say result equal to np dot, the function is called dot itself, A comma B. So this is what this does is it will multiply A and B together. I can say print matrix multiplication /n and pass the result there. Run it. I'm going to comment out the rest of them and just run this. So looks like I have the wrong answer here because I have said A and C. Let me do A and B so it's much more visual. So I'm going to go here, clear it out and run it again. So there you go. We have 1 times 5, which is 5, plus 2 times 7 equal to 14. 14 plus 5 is 19. That's the value here. Same thing. So you keep on doing multiplication by rows by columns, and that's why you get this solution here. So again, the first element in the row with the first element in the column, first column, second element times the second in the row times column, say first element, that is the first element right here. So similarly, you keep on going through these elements one by one, and then you do that. But again, luckily you don't have to do those manually. You can just use np dot function. Now it would be so much easier if it was available when we were in school, but again, we had to learn this the hard way. So next thing that I want to talk about is special matrices. So under special matrices, we have identity matrix, which is I, a square matrix with ones or on the diagonals and zeros elsewhere, and it's represented as I times A equal to A. The way we do that in here in our code is we say I equal to np dot ey I 3 by 3. If I want to print this, print to see how identity matrix look like, identity matrix. Now again, I didn't have to specify 3 by 3 because, as I mentioned, it's a square matrix. So if you just have to provide one, and it will one element of what the row is, and columns is the same as the rows. I am going to run this up, and there you go. We have 1 0 0 0 1 0 0 0 1, and if you see, the diagonal elements are all 1. Similarly, I can make it a bigger one. There you go, 1 1 1 1. So all the diagonal elements. So that's an identity matrix. I am going to show you another one, which is a zero matrix. A zero matrix is a matrix with all the elements as 0. So this doesn't have to be a square matrix. For this, I am going to comment this out. Let's move it a little bit up. And a zero matrix looks like, let's say, z equal to np dot, and to create that you say zeros, and then you have to specify the rows and columns. So let's say if I want to create 2 by 3, I can say print 0 matrix slash n comma z, save it, go back, clear it out, and let's print it out. So 0 matrix is a 2 by 3 matrix here with all zeros inside here. That's what a 0 matrix look like. Next thing that I want to talk about is a diagonal matrix. A diagonal matrix is a square matrix where all elements except the diagonals are 0. So it's a little bit different than identity matrix. Again, it's a square matrix, but in this case everything except the diagonals are 0. So the way you create them in Python is use the numpy, say diag, and now here I'm going to give some values 1, 2 and 3, and let's print this diagonal matrix slash n comma d. Let's look at how it looks like. Let me go ahead and first comment this out, open this, clear it out, make sure it's saved, run it. And if you see here 1, 2 and 3, so when you say diagonal matrix, you're actually giving the values to the diagonals. So everything except the diagonals are 0 in this particular case. So that's a diagonal matrix. Now next, now that we understand all the different types of matrices, let's go and play around with them. Let's head to hands-on exercises. So our first exercise is to create vectors and matrices using NumPy. So just to get started with things. Our objective here is to practice creating and manipulating vectors and matrices. First, let's create two matrices of size 2 by 2, and then we'll perform addition, subtraction, and scalar multiplication. So let's go back here, clear this out. I'm going to create a new file called as day1 underscore exercise 1.py. As I mentioned, first, we always need numpy as np, and as I mentioned, our first step is to create matrices. Our first matrix will be np.array, and inside that I'll create 1, 2 and 3, 4. Nothing special. I'm going to copy this and create another one called as b, and here I'm going to say 9, 8, 7 and 6. Okay, so I've created two matrices. Now next, first thing is addition. So try to pause it here and do it yourself, and then continue. Print addition. So if you got it right, you probably did something like this where you said a plus b. Simple enough. How about subtraction? So try to do subtraction and then come back, and then next thing, as I mentioned, you can do a scalar multiplication with the number 3 for the matrix A. So try that and then come back. So if you did it right, you probably did print subtraction slash n comma a minus b. For scalar multiplication, I mentioned that do slash n, do a multiplication of 3 times the matrix A. So if you did exactly like this, it should show up something like, let's clear it out, Python day1 underscore ex1.py. So we'll get 10, 10, 10, 10 because 9 plus 1, 8 plus 2, 7 plus 3 are all 10. Subtraction, 1 minus 9 is minus 8, 2 minus 8 is minus 6, 3 minus 7 is minus 4, and 4 minus 6 is minus 2. And then scalar multiplication for A, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So that's what you should see as the output of exercise 1. We have exercise 2, where we will be implementing matrix vector multiplication. So the objective here is to multiply a matrix by a vector. So first we'll create a 3 by 3 matrix and a 3D vector, and then perform matrix vector multiplication. So let's see how do we do this in code. If you want to try it out, you can try it out yourself before you look at the solution. I'm going to call day1 ex2.py. Here first, we need to import numpy as np. Next thing is we'll create a matrix and vector. So for the matrix, I'm going to call it m equal to np dot array, and as I mentioned, we're going to create 3 by 3. So I am going to give it numbers 1, 2, and 3. Our next row is 4, 5, and 6. Our next row is 7, 8, and 9. So it's a 3 by 3 matrix here. Now we need to create a vector. I'll call it v equal to np dot array, and my vector is always one row or one column. So I am going to call it create one row matrix 1, 0, and -1. Now let's do a matrix vector multiplication. So to do that, I am going to say matrix vector multiplication, and here I'll create a result array, result matrix np dot m comma v. Now if you use the same numbers, our multiplication results should be same. Print matrix vector multiplication slash n comma result. So let's display it and let's see if we have the same answer. So I'm going to clear this out. Let's say python day1 underscore exercise 2 dot py, run it, and our matrix vector multiplication is -2, -2, -2. It's kind of did the multiplication based on these two vectors, and this is the solution that you should be looking at. If not, check your code again and then go through it again. For today, we have an extra. We have exercise 3, where we will explore special matrices. So objective here is to work with identity, 0, and diagonal matrices. So what we'll do is we'll create a 3 by 3 identity matrix and multiply it with another matrix, and then create a diagonal matrix and a 0 matrix. So let's go ahead and do this. I'm going to clear this out, save it, and create another one. This one I'll save as day1 ex3.py. Now here, as I mentioned, first we'll create an identity matrix. So I'll let you guys do that. Next, do a diagonal and 0 matrix and display them out. So that's what you have to do. So if you have already done or not, just pause it and come back. So first thing that we need is import numpy as np. Next, for identity matrix, I'll say I equal to np dot I, and I will create an identity matrix of 3. It's up to you, whatever you create. And then I'll create another matrix np dot array. Now if I want to do a matrix multiplication with the identity matrix of 3, I need to make sure the rows are matching with the columns, which means I'll create a same 3 by 3 matrix 1, 2, and 3, comma 4, 5, and 6, comma 7, 8, and 9. So my 3 by 3 matrix. Next, let's do the multiplication. I'm going to say A times I slash n is np dot and A comma I is what I'll pass. Let's run this and check if it works. Python day1 ex3.py, and there you go. We have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. The thing is, as I mentioned earlier in our previous slide, where identity matrix I times A equal to A, identity matrix always gives you the same result as your as your original matrix. So there you go. So that's success. Next thing that I want to do is create a diagonal matrix. So I'm going to create a diagonal matrix np dot diag, if you remember that. And then I'll create 1, 7, and 9. Some random numbers I'll give this time. Then I'm going to say z equal to np dot zeros. This time I'll create 3, 3 by 3. And let's print first the diagonal matrix slash n comma d. Next I want to print the zero matrix, so I'm going to call it zero matrix with z. I will comment that out. I don't want to see that, so let's go ahead and print it out. And there you go, we have a diagonal matrix 1, 7, and 9. The values are in the diagonals, and zero matrix of 3 by 3. We have a zero matrix of 3 by 3 here. I hope you were able to follow along or do these on your own. If not, let me know and I can help you out. Our next step is some additional practice for you. Try this out. First thing that you want to do is compute the determinant and inverse of a 2 by 2 matrix using NumPy. Next, try to verify properties of a matrix multiplication. Something like a times b raised to t equal to b raised to t and a raised to t. Then create a block diagonal matrix using NumPy. Try this out and let me know if it works. If you have any questions or problems, let me know and I'll come back to you. So just to summarize, today we learned the foundation concepts of linear algebra, including vectors, matrices, and operations. These concepts are crucial for understanding machine learning algorithms and computational models in AI. So if you have any questions or if you have any suggestions, let me know and I'll get back to you. Welcome back to day 2. Today we are going to look at advanced linear algebra concepts. Yesterday we looked at some of the linear algebra concepts. Let's look at something more. So here we're going to cover first determinants and inverse of a matrix. Now what are determinants? A determinant is a scalar value that provides information about a matrix's properties, such as invertibility. It is calculated only for square matrices. Some of the key insights for the determinant include: if a determinant of a matrix A equal to 0, the matrix A is singular, which means it's not invertible. Whereas if determinant of A is not equal to 0, then A is invertible. Let's look at the geometric interpretation for that. So for a 2 by 2 matrix, the determinant represents the scaling factor of the area formed by its column vectors. So the formula can be represented for a 2 by 2 matrix as determinant of the matrix is, here we have a 2 by 2 matrix A, B, C, D equal to A times D minus B times C. That kind of gives you the determinant of a 2 by 2 matrix. Now let's look at how we can implement this inside Python. So I'm going to start a new file, Python. I am going to save it inside my day 2 and call it samples. Here, let's start with importing NumPy as np. So I have that available. Now I'm going to say create a matrix np dot array, and then let's create a matrix here 2 by 2, call it 2, 3 and 1, 4. Now if you look at our formula that we have given here, if I try to calculate a times, sorry, 2 a, so this is a, b, c and d, ad, which is 2 times 4, 4 to the 8, and then 3 times 1, which is 3, 8 minus 3 is 5. So let's go ahead and calculate that and see if it gives me the determinant. Determinant equal to np dot linalg dot determinant of A. That's where it's available. So linear algebra dot determinant. Print what is the determinant of this. I can get that by printing this out. Let's go ahead and check it out. Python day underscore samples. I forgot to put the day to. So as I mentioned, it's 5.00001 because it has a little bit of error factor over there, but that's perfect. It's multiplying by float, so we get sometimes this thing, but the value is 5. Now let's look at next topic, which is inverse of a matrix. So the inverse of a matrix A is denoted as A raised to minus 1. That's how you can tell if a matrix is an inverse matrix. Now the product of a matrix and its inverse is the identity matrix, which kind of makes sense. A reverse of itself is identity matrix. A matrix is invertible only if the determinant of A is not equal to 0. Now a formula for a 2 by 2 matrix shows something like this: A raised to minus 1 equal to 1 divided by determinant of A and the matrix D minus B minus C A. That's how you can get an inverse matrix. So how do I implement this in Python? I can go here. Let's go ahead and comment this out. I'm going to say inverse equal to np dot linear algebra library dot inverse of A, and I can print this one saying inverse of A is slash n comma inverse. Let's look at how the inverse looks like. Clear this out, run it again, and here is my inverse of this matrix. So this times this matrix should give us an identity matrix. Next, let's look at eigenvalues and eigenvectors. Now, what are eigenvalues and eigenvectors? Eigenvalues and eigenvectors are properties of square matrices that describe transformations. So for example, if a matrix A times V equal to lambda times V, then in this particular case, the V is the eigenvector, a vector that doesn't change direction during the transformation. And lambda is an eigenvalue, a scalar indicating how V is scaled during the transformation. The geometric representation of this, I can talk about eigenvectors as an eigenvector point in the direction where the matrix transformation stretches or compresses vectors, whereas eigenvalues indicate the factor of stretching or compression. The properties I can talk about is a matrix of the size n by n has n eigenvalues and eigenvectors. Eigenvalues can be real or complex. And another property is for a symmetric matrix, eigenvalues are always real. Now, let's see how we can compute eigenvalues and eigenvectors in NumPy. So I'll go back here. I'm going to use the same one. I'm going to comment this out. You can say eigenvalues, comma, eigenvectors equal to np dot linear algebra dot eig of A. This will give me the eigenvalues and eigenvectors for matrix A. If I want to print it and check it out, I can say print eigenvalues slash n comma eigenvalues. Can do the same thing for eigenvectors. I can print this out here. So let's go ahead and run this and check it out. So eigenvalue for that matrix is 1 and 5, and eigenvector is this particular matrix right here. I can give another example. So for example, if we create another array, let's call it B because A is already there. np dot array, give it values 4 comma 2 and let's create 1 comma 1. Now I can say eigenval and eigenvec equal to np dot linear algebra of dot eig of B this time, and then I can print eig val is comma eig val, and for vectors Since it's a matrix, I'm going to go into next line and display this here. Comment this out because we want to see for B here. Clear it out and run this again. And this is my eigenvalues and this is my eigenvector here. So they are available. So this is how you can calculate eigenvalues and eigenvectors in NumPy. Next, I want to talk about introduction to matrix decomposition. Now first, what is matrix decomposition? Matrix decomposition is a process of breaking a matrix into smaller components to analyze or solve problems. Now for that we have singular value decomposition or SVD. SVD decomposes a matrix A into three matrices. We could get A equal to U times sigma times V raised to T, where U is a left singular vectors or orthogonal matrix. Sigma is a diagonal matrix of singular values or non-negative. V raised to T is the right singular vectors or orthogonal matrix. Now, some of the applications of SVD include dimensionality reduction. Example, in principal component analysis, PC algorithm, we use that. We also use it for noise reduction in data sets and also sometimes for image compression. Let's look at how we compute SVD in NumPy. So I am going to comment this out. I will use my A matrix. So I'm going to just write some code here so it's visible to you. U for sigma I'll use S and V raised to T I'll say VT equal to NP dot linear algebra dot SVD. So if you see, you don't have to write any of these, implement any of these functionalities. They're all available as part of NumPy linear algebra library. Now let's print them out. How is it decomposed of? U is slash n U. Same thing I'm going to do for S is S and V or V raised to T is sometimes called as V transpose. So if you want to know the full form of that, VT. And S is also sometimes called as singular values. So that's what it is. So as I mentioned, U is the left singular vector. This is S is the diagonal matrix of a singular values, which is non-negative. And this is the right singular vectors, which is also called as V transpose. So let's go ahead and clear this out, run it out, and you have your U matrix, a singular values, and the V transpose right here. And these together kind of create the matrix A. Now, next step is to jump into hands-on exercises. Here, first exercise that we will be covering is calculating the determinant and inverse of a matrix. We learned this in the first section today, where the objective is to practice using NumPy to compute determinants and inverses. So instruction that we'll follow here is we'll create a 3x3 matrix and then compute its determinant and inverse. So it's pretty straightforward. So let's go create a new file. I'm going to save it as day2.ex1.py. In here, I am going to first import NumPy as np. Next, we'll create an array A, np.array or a matrix which is 3x3. So I will create it this way. I'm going to say 2 3 1 comma 4 5 6, some random numbers, I'm just filling it up, 7 8 9. Okay, so this is my matrix. Now to create the determinant, I'll say determinant equal to, it's np dot linear algebra dot determinant of A. Similarly for inverse, I will say np dot linear algebra library dot inverse of A. That's it. Pretty straightforward. Let's print them out and check it out, our results. Determinant determinant inverse is inverse. Let's go ahead and run this. I'm going to say Python day2.ex1, and there you go. We have our determinant and we have our inverse. Pretty big numbers I see here, exponential raised to ex, so that means the decimal places are pretty low. But here we have our determinant and inverse, and we can use these. Now let's jump into exercise 2. Our exercise 2 is to compute eigenvalues and eigenvectors. So the objective here is using NumPy to compute and interpret eigenvalues and eigenvectors. So we will be creating a 2 by 2 matrix and compute its eigenvalues and eigenvectors. Pretty straightforward. So let's go ahead and create a new file, day2_ex2.py. Here first thing is import NumPy as np. Next, let's create a matrix A equal to np.array, and as I mentioned, I'll create a 2 by 2 matrix. So this matrix will have 4 comma, it's a -2, 1 comma 1. So this is my matrix. Eigenvals and eigenvectors equal to np dot linear algebra dot eig of a. Now let's print this. That's it. Eigenvalues, don't have to eigenvectors. So I'll say eigenvalues, comma, and eigenvectors slash n, because it's a matrix. This is a singular. So I'm going to clear this out, and I'm going to say Python day2ex2, and there you go. We have our eigenvalues and eigenvectors. Let's do one more exercise, and in this one, let's perform the singular value decomposition. So we'll be using the SVD function in linear algebra. The objective here is to implement SVD and interpret the components, which is the U, sigma, and V transpose. So let's go ahead and code that out. Create a new file, save it as 3. Here, import NumPy as np. Next, A equal to, let's create a matrix, np dot array. I will create a 3 by 3 matrix here. First values, let's give some random values, 3, 1, 1, comma, next one, I'll say -1, comma, 3, comma, 1. Next one, I'll create 1, comma, 1, comma, 3. So I have my matrix here. I can get U, S, and VT from np dot linear algebra dot svd of this matrix. So let's print them out. Print U slash n, print me U. Next, single values. So this is singular values, which is diagonal, and that is S, and this one is V transpose, which is VT. Now if I want to reconstruct the matrix and see if it works, what I can do is, let's say reconstruct, because someone asked me that can you use all these 3 and then reconstruct. So I can say sure, sigma equal to np dot zeros, create a zeros matrix 3 by 3. Then I want to do np dot fill underscore diagonal with sigma with S. So that kind of creates my initial thing. Then reconstructed constructed equal to U at the rate, so multiplication pretty much, sigma multiply that with V transpose. So that should be my entire matrix. So let's print it out. Reconstructed matrix slash n is reconstructed. Okay, perfect. So let's run this up and then check if it matches what we have here. So I'm going to say Python day2 x3. Okay, there you go. Our first U matrix, our S sigma, which is singular values, and V transpose. Now we took the singular matrix and then we created a zero first, and then we uh, filled the diagonal with the values that we have, and then we created the reconstructed matrix using the U, sigma, and VT, which is 311 minus 131 113 exactly to the dot. So there you go. That's how you can create create a decomposition matrix, singular value decomposition matrices, and then reconstruct them back here. Now, for some additional practice, you can try to compute the eigenvalues and eigenvectors for larger matrices. You can use SVD to reduce the dimensionality of a dataset, and also try to verify the properties of an eigenvalues. You can do the determinant of A minus lambda of identity equal to 0. Try that out and let me know how it works. If you have any problems or had any problems following along through any of these exercises or any of the additional practice that you're doing, let me know and I'll get back to you. So just to recap, today we learned advanced linear algebra concepts including determinants, matrix inverses, eigenvalues, eigenvectors, and matrix decomposition. These concepts are foundational for understanding data transformation and dimensionality reduction techniques in AI. So if you had any issues or problems or have any doubts, let me know and I'll get back to you. Day 3. Today we are going to look at calculus for machine learning. Specifically, we're going to look at the derivatives. So first, we're going to cover introduction to derivatives and their role in optimization. So what are derivatives? A derivative measures the rate at which a function changes with respect to its input. For a function f of x, the derivative, or also called as the first derivative, f of x, indicates the slope of the tangent line at a point x. Let's look at the role in optimization for derivatives. Derivatives are used to minimize or maximize a function, which is critical in machine learning for optimizing loss functions. Example can be the loss function in linear regression measures the error. Derivatives help find the direction to adjust parameters to minimize this error. So let's look at some of the common derivatives. We have for f of x equal to x square, and the first derivative is equal to 2x. And for f of x equal to sine x, and the first derivative equal to cos x. Now, how do we implement this in Python? Using, we have a library called as SymPy. So I'm going to start with the Python file, save it in our day3 underscore samples. And here, I'm going to use that SymPy library as SP. And here, I'm going to say x equal to sp dot symbol. And for that, I'll use x. Next, f equal to x star star 2, squares that up. So that's our f of x equal to x square, which we mentioned right here. And now to get the derivative, I am going to say sp dot diff and pass it the two variables f and x. Let's print the derivative. There you go. Save it, open and make sure we're in the right place. Python day3 samples. And there you go. Derivative is 2 times x, which is what we are expecting right here. So similarly, you can do that for the other one too, but I'm going to leave that for you. We're going to jump into partial derivatives. Now, a partial derivative measures how a function changes with respect to one variable while keeping the other variable constant. So for f of x equal to x square plus y square, partial derivatives are defined as its partial derivative of f divided by partial derivative of x equal to 2x, and partial derivative f divided by partial derivative y equal to 2y. We also have gradient, where the gradients is a vector of all partial derivatives, indicating the direction of the steepest ascent. For f of x equal to x square plus y square, the gradient is defined as del of f or nabla of f with the matrix of partial derivative of f divided by partial derivative of x and partial derivative of f divided by partial derivative of y, which is equal to 2x and 2y. That's the matrix of 2 by 1. Now in Python, how do we implement these things? Whatever we did partial derivative and gradient. So let's see how do we get the partial derivative and gradients here. I'm going to go clear this out. Here I am going to say a comma b. Actually, let's keep the values as x and y only. So x comma y, we can get it by saying sp dot symbols that I want to use in this particular case is x and y. So that's what we get assigned here. F equal to x square of 2 plus y square of 2. It's exactly same as the function that we have here, x square plus y square. So that's what I'm doing here. Next, I'm going to say gradient of x equal to sp dot diff f comma x and gradient of y equal to sp dot diff differential f comma y. So now let's go ahead and print the partial derivatives that we created. Partial derivatives, and I can pass grad x and gradient y. There you go. Oh, I spelled it wrong. That's why it was not showing up. And there you go. Let's run this and check out the solution. And there you go. Partial derivatives is 2 times x, 2 times y. That's our object that we wanted to get. So this is how you can implement this using Python, and SymPy is the library that we use. Next, look at gradient descent optimization algorithm. Now, what is gradient descent? Gradient descent is an iterative optimization algorithm used to minimize a function. Example can be a loss function. It updates parameters in the direction of the negative gradient to find the minimum. Now the update rule here is theta equal to theta minus alpha del or nabla f of theta, where theta is parameters of the model and alpha is the learning rate, which is the step size. Now, why is gradient descent important in machine learning? It's used in training models to minimize the loss functions and find optimal model parameters. And that's why it's very important to understand how this works. Now, let's go ahead and jump directly into our hands-on exercises. So our exercise 1 is to compute derivative of basic functions. So objective here again is to use Python to compute derivatives of simple functions. First, we'll define a symbolic function using SymPy, and then we'll compute its derivative. Something that we did already, but let's do it as an exercise. Follow along if you want to. If not, if you want to do it before me, just go ahead and implement it and then cross-check your answer. So I'm going to say day 3 underscore exercise 1. I wanted to make it as a, so I'm going to open again, open dot, and make sure that I make it a Python file, add and open that file. Okay, so here first import SymPy as sp. Once I have that, let's go ahead and define a function. I'm going to write comments so you can understand what I'm trying to do. X equal to sp dot, let's create a symbol. Let's use our traditional x symbol. Next, I'm going to create a function x raised to 3 minus 5 times x, 5x plus 7. So now if I want to get its derivative, let's compute the derivative of this. that I can do by saying, let's say derivative equal to sp dot diff f comma x, and this should give me the function. So I can get the initial function, which is f. I am going to print the derivative of it, which is the derivative. Let's look at the function and its derivatives. Clear it out. Python day 3 exercise 1.py, and here is the function x cube minus 5x plus 7, and the derivative of that is 3 times x square, or 3x square minus 5. So that's the derivative of this function. Pretty easy, and Python helps you, makes it much more easier. Our next exercise that we want to look at is computing the gradients. Here the objective is to calculate partial derivatives and the gradient for a multivariable function. What we're going to do here is we define a function with 2 variables, and then we'll compute the partial derivatives and represent the gradient as a vector. So let's go ahead and implement this. Create a new file. I'll call it day 3 exercise 2.py. First, let's go ahead and import our SymPy. Next, I am going to define a multivariable function. In the previous one we just used x. This time we're going to do both x and y. So x and y equal to sp dot symbols. I need x and y. These are the symbols that I need, so that's what I specified. My function in this case is, let's say, x square plus 3y, so 3 times y square is this way, and then I'll say minus 4 times x times y, so 4xy. So this is represent f is equal to x square plus 3y square minus 4xy. Now let's go ahead and compute the partial derivatives. You can say grade, or I can first write the comment, said compute partial derivatives, and to do that, grad underscore x equal to sp dot def, and I give my function and variable x. Next, for grad y, I will say sp dot def, and I'll say f comma y, function y. So that's perfect. Now let's go ahead and print our gradients. So our first gradient f of, let's say, the function for grad x, or let's say grad x, I'll keep it simple. I don't want to say a differential of grad x, but that is grad underscore x, and I have similar for grad y is grad underscore or gradient y. So there you go. Let's go ahead and run it. I'm going to clear this out, and this is exercise 2.py, and here you go. So for our function x square plus 3y square minus 4xy, our gradient x, or the partial derivative, is 2x minus 4y, and our gradient y is minus 4x plus 6y. I hope you were able to do it, but we're going to move to the third one, which is implement gradient descent for linear regression. Now the objective here is to write a Python function to perform gradient descent and optimize parameters for a linear regression problem. So we can use NumPy for this one because we have the solutions available for it. We're going to define the gradient descent function, and we're going to provide some sample data and perform the gradient descent. So let's go ahead and implement this. I'm going to say this is exercise 3, and here first I am going to import NumPy as NP. Next, the first step that I mentioned is we will define the gradient descent function, and that we can define by creating a function called as gradient descent, and it takes multiple values x, y, we also need the theta, we need learning rate, and we need iterations that are required to run through this function. So that's what I need. So I'm going to first say m equal to length of y. I'll take that, and then for underscore in range of iterations. So for all the iterations that we have, I should say iterations, which makes more sense. So I'm going to run through this for loop for all the iterations that are there. So first I'm going to try to get my predictions equal to np dot and pass it x and theta. For errors, I will say predictions minus y, and for gradients, I will get 1 divided by m times np dot x dot t transformed transform and errors is what I'm going to take. Let's look at it. Perfect. So that's our gradients, and then to calculate the theta for it, I'll have to decrement it based on learning rate times gradient. So that will give me my theta, and that's what I can return after this loop is over, going through the iterations that I've specified, and theta. So there you go. That's our gradient function. Now next thing is, let's create some sample data to test it out. Sample data, where I'm going to say x equal to np dot array. Let's create an array, and we'll also have to include the bias terms here. So for this, I am going to create 1 comma 1, the first element in the matrix, 1 comma 2, second row, and my third row I'll give 1 comma 3. Pretty simple and straightforward. Next, I am going to create the y variable, np dot array, and this is a one line or a single vector, 2 comma 2.5 comma 3.5. This is my y. Next, I need theta. For theta, I will say np dot array, and that can be represented as, we can do the initial parameters as 0.1 comma 0.1. Next, I will give the learning rate of 0.1 iterations. I don't want to give too much, but let's try with 1000. That's how many times this will run through this loop. Next, let's do the perform the gradient descent. So we have the function, why not run through it? So do that. I'll say my optimized theta equal to gradient descent, and now we'll get all the values that we have here: x, y, theta. We have learning rate of 0.1, and we have iteration of 1000. Let's call it iterations since it's 1000. And now let's print this out, see how our optimized parameters look like, and that I can say optimized theta. Perfect. So this is the entire function. So let's go ahead and run it. Now clear it out and say python day3 ex3.py, and our optimized parameters are 1.1663 and 0.7507. So it went through this bunch of different times, 1000 times specifically, and used the gradient descent function to give us the optimized parameters for the theta. Next, if you want to do some more additional practice on these, you can use SymPy to compute second order derivatives, which is Bayesian metrics. So we did the first order derivatives, but you can do the second order derivatives if you want. You can implement gradient descent with multiple learning rates and compare convergence speeds. Also, you can visualize the gradient descent process on a quadratic function. To try this out and let me know how it goes. If you have any problems or questions or were not able to follow along, let me know and I'll get back to you. So to recap, today we explored the foundational concepts of derivatives and gradients, focusing on their applications in machine learning. By implementing the gradient descent, we gained practical insight into optimization, which is a key component for AI model training, and we'll be using that quite a lot in coming weeks. So let me know if you have any issues or problems or need any help, and I'll get back to you. Welcome back to day 4, Calculus for Machine Learning, where we're going to cover this time integrals and optimization. Now, the topics that we will start with is first understanding integrals and their applications in ML. So what are integrals? Integrals compute the area under a curve, representing the entire accumulation that is under the curve. If you see a bell-shaped curve, that's where integrals come into picture, where it computes the area that is covered under that particular curve. The definite integral of f of x from a to b is represented as integration from a to b f of x dx. This is the formula. This is what you'll see probably, and you've seen in school before. Now let's talk about applications in ML. We have probability distribution. Integrals are used to compute the probability under a probability density function, which is PDF. Also, cost functions. Regularization terms in cost functions often involve integrals. Example, integrating over weights in Bayesian models. Let's look at some examples with Python of how to use it. So I'm going to go back, create a new file, Python file. Make sure I save it in day 4, call it day 4 underscore samples. And here first, we need SymPy as SP. That's the library we'll use, a module we'll use. And then I'm going to say x equal to sp dot symbol. I'll use the symbol x as before. If you have not seen the previous videos, I would recommend you watch them before doing this. And I say my function that I'm interested in is x square, which can be represented as x star star 2. Now definite integral, I'm going to give it definite integral equal to sp dot integrate. That's the function that we'll call, and to it we'll pass f and x comma from 0 to 2. So what I'm doing here is I'm saying integration of x square dx from 0 to 2. Now let's go ahead and get indefinite integral. Indefinite integral. For that I am going to say sp dot integrate, and here I'm going to say f and x. So this is integration of x square dx. So I have that. Now let's print this. Print definite integral is definite integral. Do the same thing for indefinite integral, and the variable is this one. Let's look at it. Sure we are in the right folder. Bootcamp week 3 day 4. Perfect. And I am going to run Python day 4 dot samples, and there you go. Definite integral is 8 by 3 and indefinite integral is x cube divided by 3. So that's how you can calculate definite and indefinite integral. Next, let's look at some optimization concepts. So we have local versus global minima, where local minimum is a point where the function has a lower value than the neighborhood points, and global minimum is the absolute lowest point of the function across its entire domain. So in ML or machine learning, the optimization goal is to find the global minimum of a loss function, but local minima can sometimes suffice. Next, let's look at convex functions. A function is convex if, I'm going to display you the entire formula, where f of lambda of x1 plus 1 minus lambda of x2 is less than equal to lambda of x1 plus 1 minus lambda of fx2 for all lambda which belongs to 0 to 1. Now convex functions ensures that any local minimum is also a global minimum. Next, non-convex functions in ML. Most of the neural network loss functions are non-convex, leading to challenges in optimization. Next, let's look at stochastic gradient descent, or also called as SGD, and its variants. So first, what is stochastic gradient descent, or SGD? An optimization algorithm that uses random subsets, or also mini batches of the data to compute gradients and update parameters. So why do we use SGD? SGD is used for faster convergence for large data sets compared to batch gradient descent. Now, what are the variants of SGD? We have mini batch SGD, which updates parameters using small batches instead of single examples. We also have momentum, which adds a fraction of the previous update to the current update to accelerate the convergence. And we have Adam Optimizer, which is used quite a lot. It combines momentum with adaptive learning rates for faster convergence. Now that we know the basics about integrals and optimization, let's get into some hands-on exercise. So the first exercise that we'll be doing is we'll be calculating integrals of simple functions. The objective here is to use Python to compute definite and indefinite integrals, which we have seen earlier. And what we'll be doing is we're going to define symbolic functions using SymPy first, and then compute the definite and indefinite integral. So let's go ahead, and I'm going to create a new file, call it day4_ex1.py. Now to start with, we'll import the SymPy module and give it an alias of sp. Next, let's go ahead and define a function. Now this function, I'm going to say x equal to sp.symbol, symbol, and I'll use the symbol x. Next, I'm going to say f equal to sp.exponential of minus x. So we have x and f. Now let's compute indefinite integral. Now, as we've seen earlier, indefinite integral can be calculated by saying sp dot integrate and pass it f and x. Next, let's print it out. Print indefinite integral, comma, and print the value of it. Next thing, let's compute definite integral. To do that, I'll say definite integral equal to sp dot integrate and pass it f comma x comma 0 to sp dot oo. So that's what we specify for definite integral. We'll say print definite integral is equal to comma, pass the definite integral right there, some spaces so it looks good. So now let's go ahead and run this. I'm going to clear this out, and I'm going to say Python day underscore, I forgot to give day 4, but it's the same name, and my indefinite integral is minus exp minus x, and my definite integral is 1. There you go. So we have the values as per expected. Our second exercise here is to implement stochastic gradient descent for a linear model. Now objective here is to implement SGD to minimize a linear regression loss function. What we will be doing is we'll be defining a simple data set, and we'll write a Python function to perform the SGD. So let's go ahead and start coding. I'm going to clear this out, create another file, save it as day4_ex2.py. So first, let's import numpy as np. Next, I need to generate some synthetic data. So I will say np.random.seed. If you remember, this will make sure that every time we run the randomizer, it will give me the same data. same random data. So I'm going to say x equal to 2 times np dot random dot rand, and I'm going to say 100 comma 1. So this is my feature. Now I want to create a target of which I'm going to predict. So 4 plus, I'm just giving some random numbers, 3 times x plus np dot random dot randn of 100 comma 1. So this will give me target with some noise values to it, added to it. Now let's add some bias term to x. To add bias term, what you do is let's create x underscore b equal to np dot c underscore and np dot ones 100 comma 1 comma x. So this is our bias term that added to x. Now next we need to get SGD implementation. So let's see how do we, so create a function first, call it stochastic underscore gradient underscore descent, and then this will take our usual parameters, the target, sorry, the feature, the target, the theta that we have to give, next theta, and then we need learning rate and the number of iterations or epochs is another way for saying iterations. I'm going to first take m is equal to length of y, do that. Next I'm going to run the iteration for, I'm going to say epoch in range of n underscore epochs. I want to run this, and then again for I in range of m, which we calculated the length of y, and here I am going to say first I want to get the random index equal to np dot random dot rand integer I. So I'm going to pick a random index here, oh sorry, not I but m, and then next I am going to say xi equal to x of random underscore index. So depending on what index I've taken, random index plus 1. So that will give me xi value. Similarly for yi, I will say y of random index colon random underscore index plus 1. Next I need the gradients. For that I'll say 2 times xi dot t at xi. So I'm doing multiplication here, again multiplication, theta minus yi. So there you go, this will give me my gradients, and for theta I will say minus equal to, I'm going to decrement based on the learning rate times gradients. So that will take care of that. Now finally I can return the theta here. So that is the value of the final optimization. Now next step is to initialize this parameter that I want to start with. Initialize parameters. So I am going to create theta equal to np dot random dot randn 2 comma 1. This will give me the bias and the weight. Next I have the learning rate, which is, I'll say 0.1 or 0.01. Let's do 0.01. How many iterations I want? Let's keep it 50. I remember last code that we wrote, we used 1000. Perform SGD now and get the, so we are calling that function above. So for that I'll say theta optimized equal to stochastic gradient descent x underscore b that you generated above, y and theta, and we need to pass the learning rate and we need to pass the epochs. There you go. So I'll pass all these. That will let me get the theta, optimized theta, and I can say print, call it by it name, optimized parameters are theta underscore op. So this should give me, so the expected results should be around based on, okay, I'm not going to even guess this. So let's go ahead and run this. I am going to say Python day 4 underscore ex2.py, and there you go. We have our optimized parameter 4.16 and 2.69. These are very close to the actual values that we have given, but that's how you can perform an SGD to get the optimized theta here. Now if you want to do some additional work, you can go ahead and visualize the loss functions surface and the SGD optimization path. Also try to implement a mini batch SGD and compare it with the vanilla SGD. And also finally use Atom Optimizer for a more complex data set. And we'll be doing some of these in our machine learning videos in the future, but try it out and let me know how it goes. If you have any issues or problems, let me know. So just to summarize, today we learned the basics of integrals, optimization concepts, and stochastic gradient descent. By implementing these concepts, we gained a deeper understanding of optimization, which is a cornerstone of machine learning training. If you have any questions or suggestions, let me know and I'll get back to you. Day 5, probability theory and distributions. Let's start with probability basics. And in here, let's look at conditional probability. The probability of an event A given that event B has occurred is represented as P A by B, which means the probability of an event A given that event B has occurred is equal to P of A and B divided by P of B. Example can be the probability of drawing a red card given that a face card is drawn from a deck of cards. Next we have Bayes' theorem. This relates conditional probabilities where P of A of an event A given that event B has occurred is equal to P of B given event A has occurred, P of A divided by P of B, where P of A or probability of A is prior probability, P of B A is likelihood, and P of B is evidence. We can do this Bayes theorem in Python by, let's create a new file, save it in day 5 as day 5 underscore samples. Now if I want to create a Bayes theorem, I'm going to say Bayes theorem. So I'm going to create a function here, and to it I'll pass the prior probability. I'm going to give it the likelihood, and I'm going to give it an evidence which is based on our function here. And to calculate it, you can say return likelihood times prior probability divide by evidence. That's what we return. So that's the actual formula right here. So that's how Bayes theorem works. Let's save this and close it, and let's go to the next topic, which is common probability distributions. Now we are going to talk about different probability distributions here, starting with the Gaussian distribution, which is also called as a normal distribution. It's a bell-shaped curve with mean mu and standard deviation, which is sigma. The formula for it is f of x equal to 1 divided by square root of 2 pi of sigma square e raised to minus x minus mu square divided by 2 sigma square. Now, example of this can be modeling continuous data like heights or test scores. We can look at a Python example for that. What I'm going to do here is I'm going to import first numpy as np. You can go ahead and comment these out. Next, I want to import matplotlib to plot a graph for this, pyplot as plt. So let's say if I use, say, mu for mu and sigma for sigma, and I'll set its value to 0 and 1. Next, I'm going to create a variable x equal to np dot linear space minus 4 comma 4 comma 100. Next, I will say y equal to 1 divided by, it's based on the formula that we have here, and we need to pass np dot square root of, and inside square root we had 2 times np dot pi, as you can see here, np dot pi, and we need sigma square, so let's say sigma star star 2, which is sigma square, make sure all the brackets are closed, times np dot exp exponential, that's what we have here, exponential raised to minus, so that we can specify by saying np minus 0.5 star, because we have divided by 2 below, so that's why I'm doing that, minus 0.5 x minus mu, and after this divide by sigma, and then square the entire thing, as you can see from the formula right here. So next step is to plot this. So I'm going to say plt dot plot x comma y, and then I'm going to say plot dot title equal to Gaussian distribution, and then I'll say plot dot show. If you have not seen for some of our previous videos on matplotlib, that will probably help us understand what we are trying to do here. So now that I have it, let's run it and see how it looks like. I'm going to open terminal, make sure I'm in the right folder, week 3 day 5, and I'm going to run this file python day 5 underscore samples, and there you go, we have our Gaussian distribution right here. So now if you had the similar graph, that's good. If not, please check your code again to make sure that it's exactly the same, because sometimes the formula can be confusing. As you can see, it has a lot of different parameters to it. Next thing, we're going to look at Bernoulli distribution, which describes outcomes of a binary experiment. Example, you can think of it as a coin toss. So the formula for that is more on p of x equal to 1 equal to p, p of x equal to 0 equal to 1 minus p. So this is the Bernoulli distribution. And now if you want to implement this, I am going to comment this out, and then here let's say p equal to 0.6 and plt dot bar diagram, in this particular case say 0 comma 1 and 1 minus p comma p are the two parameters. Color, I will use blue for this bar, and that's all that I need here. Next, let's give a title, call it Bernoulli distribution, make sure I get the spelling right, Bernoulli. Next, I will say plot dot xtext is 0 1, and then I'll need labels, which is 0 for failure, and then I need 1 for success, which is 1 is for success. Perfect. So those are my xtext, and then finally show the plot. Save it, go back to my terminal, clear this out, and run this. And there you go, we have our Bernoulli distribution for 0 and 1 based on the probability of 0.6. It kind of shows it properly on the graph. Next thing that we want to talk about is binomial distribution. Now, binomial distribution models the number of successes in n independent Bernoulli trials. So this is kind of defined as p of x equal to k equal to n to k p raised to k 1 minus p raised to n minus k. Now if I want to show this in Python, the way to draw this out is from cpy dot stats, that's the module that we'll use. Import, we need binom, that's where you can find the binomial distribution function. Let's say n comma p equal to, let's assign it some values like 10 and 0.5, x equal to np dot range from 0 to n plus 1. Next I'm going to say y equal to, as I mentioned, we use binom dot pmf, and inside this I'll pass x, n and p, the different parameters that it needs to run the binomial distribution. So once I've given that, let's plot the bar. Say plt dot bar x comma, do I have my plot is not commented, that's good, x comma y comma color equal to, last time we used blue, this time we'll use green. Next I'm going to say plot dot title, and for the title I'll say binomial distribution, and then plt dot show. That's it. Let's go ahead, open terminal, and make sure my graph from the before is closed, clear it out, run it again, and there you go. We have a binomial distribution which looks perfectly fine. This is how a binomial distribution should look like based on the values that we have provided. So if you got this, that's good. If not, please check your values and what functions you're calling. Or if you have an error, let me know and I'll get back to you. Next thing that we're going to talk about is Poisson distribution. Now Poisson models the number of events in a fixed interval of time or space, that is defined as p of x equal to k equal to lambda raised to k e raised to minus lambda k factorial. So if you want to define this or do this in Python, the way to do it is, I am going to comment this out. This is something similar. We'll use, instead of binom, we'll use Poisson. That's the module that we want. I'm going to say LAM equal to 3. I will say x equal to np dot range, and I'll give values from 0 to 10. Next I'm going to say y equal to Poisson and in dot pmf, and pass it x and the value of lamb, and then I'll say plot the bar graph where I'll say x is pretty much same as before, and next I will give so let's change the color this time to orange, and next I'll give a title. This time it's POI SSON, Poisson distribution, and show this plot. Perfect. Let's go back, clear it out, run it again, and this is how the Poisson distribution looks based on the lamb and x values that we have provided. Perfect. This is how it should look for you. If you had any issues or problems, let me know. If not, good, we can move to the next topic, which is applications in machine learning for all these different distributions that we have learned. So first, let's look at Gaussian distribution. It is used in Gaussian naive Bayes and kernel density estimation. We have Bernoulli distribution, which is used for by models binary classification problems. Example can be spam or not spam emails. We have binomial distribution, which is used in logistic regression to model binary outcomes. And we have Poisson distribution, which models the count data. Example can be number of clicks on a website. That's what it's used for. So these are different applications in machine learning for these distributions that we have learned. Next, let's look at hands-on exercise. So we will be doing a couple of them here. First one is to calculate probabilities using Bayes theorem. The objective here is to write a Python function to calculate probabilities using Bayes theorem that you learned earlier. So the example problem can be a disease affects 1% of the population. A test is 95% accurate for diseased individuals and 90% accurate for non-diseased individuals. Now what we have to do is find the probability of having the disease given a positive test result. So let me write it down so it's much more easier to understand. I'm going to create day 5 underscore ex1.py, and as I mentioned, the problem here is, let's create bullet points. I'm going to say first the problem is, I'm going to give 3 bullets for 3 different things that we're going to define here. A disease affects 1% of a population. Next, I can say a test that is available is 95% accurate for diseased individuals and 90% accurate for non-diseased individuals. And then the final one is, what we have to do is find the probability of having the disease given a positive test result. Because even if you're not, as I mentioned, the test is 90% accurate for non-diseased individuals. Okay. Oh, there's no more typos. Okay, so let's see. Let's go ahead solving this. So as I mentioned, we'll be using Bayes theorem. So first, let's create a function for Bayes theorem, which takes prior probabilities, which takes the sensitivity and the specificity. The spellings are right, hopefully. So the evidence is sensitivity times prior. If you remember the formula that it had, this is what it is, and 1 minus specificity times 1 minus prior. Okay, so that's the first line of our. Next, we can calculate the posterior equal to sensitivity times prior and divide by evidence. Now that is what we will return here. So let's say based on the requirements, our prior is 0.01, which means 1% prevalence. We have sensitivity is equal to 0.95, which means true positives are 95%, as it mentions. Next, we have specificity equal to 90%. So that's what we have. This is a true negative rate. So again, if I want to write it down based on a requirement, it's 1% prevalence. Our sensitivity, as I mentioned, which is also called as true positive rate, and our true negative rate is specificity, true negative rate. Okay, so now that we have this, let's go ahead and get the value. Posterior equal to Bayes theorem, and to this I can pass the values that I've created here. Prior, next it needs sensitivity, and then it needs specificity. Let's print it out. Now we say find the probability of having the disease given a positive test result. So probability of disease given positive test is posterior. So let's run this and test it out. I'm gonna make sure my graph is closed clear it out, and I'm going to say Python day 5 exercise 1.py. Probability of disease given positive test is 0.08, which is 8% probable that you might have the disease. So that's pretty cool. Now let's clear it out, and I hope you were able to figure out or calculate the probabilities using the Bayes theorem that we did here. If not, had any issues or have any questions, let me know. Next, let's go ahead and look at exercise 2. Our exercise 2 is to plot and explore different probability distributions that we learned, which is Gaussian distribution, binomial distribution, and Poisson distribution. Let's look at those and how we can visualize and understand key probability distributions using Python. So go here and save it as day 5 exercise 2.py. Now here, first thing I'll say import numpy as np. Next I'll get my matplotlib dot pyplot as plt. Next import skypy.stats, and import from this I can get my Gaussian distribution, which is also called as normal distribution. I need binomial distribution, so that is binom, and Poisson comes from POISSON, that's the Poisson distribution. So we have these. Next, let's start with Gaussian distribution. So here, the reason we see error here is to say from import these. Perfect. So for this, I'm going to say x equal to np dot linspace, and here I'll give -4, 4, 100. Next, I'm going to say y equal to normal distribution dot pdf, and in here I'm going to give x loc equal to 0 and scale equal to 1. Next, I will say pl dot plot, and I want to plot x comma y label equal to Gaussian or normal distribution, whatever you want to call it. Dot title, I'll give Gaussian distribution. So that's good. Next, I'm going to say plt dot show. So we'll show my plot. So let's go ahead and run it. I'm going to say here Python day 5 ex2.py, and there you go. We have our Gaussian distribution. Perfect. Next thing is binomial distribution, and this I can say n comma p equal to 10 comma 0.5. We have x equal to np dot range and pass it 0 comma n plus 1, and y equal to binom dot pmf, and it needs x, n, and p, just like how we did earlier. So these three parameters. Next, I'm going to say plot dot bar. It's a bar diagram that it gives. So let's give it x comma y and label equal to binomial. Next, I want to say title, and title will be binomial distribution. And finally, let's show this plot. Perfect. I am going to comment this out. So it shows only one right now. Close this previous one and run it again. And there you go. It showed both of them because I still have I'm using the same variable here. So I'll just go ahead and comment this out and close this and run it again. There you go. We have our bar diagram displayed here. You can always merge something like this. It's interesting to have bar and the plot diagram together displayed here. Next one that we have is Poisson distribution, and for this we'll say lamb equal to, so we need lamb and x, y, lamb equal to 3 x equal to np dot range. I will say 0 to 10. Next, I need to give y equal to Poisson here dot pmf, and this needs x and lamb values to it. Perfect. Now let's create the bar diagram, bar chart. I'll say x comma y, and I need label equal to Poisson. Perfect. Next, I need to give a title. I mean, I don't need, but it looks good. SSON distribution. Next, let's show the plot. This is bare minimum. You can always give x and y axis and all those things, but I like to keep it as simple as possible. I'm going to close this binomial distribution, clear it out, and run this one. And there you go. We have our Poisson distribution displayed here on the graph perfectly. So I hope you are able to follow along. If not, go through this and let me know if you have any issues or problems. For additional practice, you can look at creating and visualizing a multinomial distribution for multi-class data. You can try with comparing Gaussian and uniform distribution for continuous data. Also, try to use probability distributions to simulate and analyze real-world data sets that are available in different websites. So to summarize, today we explored probability theory and its applications in machine learning. By calculating probabilities using Bayes' theorem and visualizing distributions, we gained an essential understanding of probabilistic modeling, and this will be quite helpful in future videos as we go along. So if you have any questions or problems, let me know and I'll get back to you. Day 6, Statistics Fundamentals. Today we are going to look at measures of central tendency and dispersion. Now, what is central tendency? Central tendency has mean in it, which is the average value of a data set. It has median, the middle value where data is sorted, and the mode where the most frequently occurring value. Now, if you want to kind of look at these three in Python, we can probably start a file, save it as day6 underscore samples, and here I will start with first some data equal to, let's say, 10 comma 20 comma 30 comma 40 comma, let's take one more, 50. So we have some data. Now mean is equal to sum of data divided by length of this data. That's how you calculate mean. Let's print it out. Print mean comma mean. If I open my I'll say Python day6.samples, and there you go, mean is 30 of this data set, 10 20 30 40 50. The mean over here is 30. So that's how you calculate the mean. Now let's look for median. Now median, as you're familiar with, or for not, needs sorted data. So I am going to say sorted data equal to sorted, and sort the data that we have above. Next, to calculate median, I'm going to say median equal to sorted underscore data, and in here I'm going to say length of data / 2 if length of data mod of 2 is not equal to 0, else, next line, I'm going to say sorted underscore data length of data, I'm in the right place, / 2 minus 1 plus sorted data length of data to / 2, and then I will say close slash divided by 2. So that will give me the median for this entire value. So to calculate, to actually print it out, I'm going to say print median of the median. So again, this will be the median of this entire data. Again, it's already sorted, so we don't have to sort anything. Let's go to our here and print it out. There you go. My mean is 30, median is 30, because it's a pretty uniform data that I have here. So that's why it calculated it and gave me that median. Next that we have is mode. Now for mode, we need something from a library. I always like to put my modules up here. Let's say statistics. I need mode. So for mode now, very simple. I'm going to say print mode. I wish everybody had the libraries, but there are different types of libraries available for doing this. But I can say from statistics, I can just say mode of data, and then go ahead, clear it out, print it out again. So mean is 30, median is 30, mode is 10 in this particular case from the data that we have. Next, let's look at dispersion. So we have variance inside here, which is the average squared deviation from the mean. And if you want to calculate variance in here, you can say variance equal to sum of x. This is the function for it. This is the algorithm for this, or let's say formula for this, 2 for x in data slash length of data, or divide by length of data. So this is what will give you variance. Now if I want to print this out, let's go and print variance comma variance for the same data that we have. Let's look at the differences, clear it out, run. We already know the first, and the variance is 200 for this data that we have. Let's make sure everything is right. X minus mean square of 2 for x in data length of perfect. So that's the variance that we get. Next thing that we can calculate is standard deviation. Now standard deviation is the square root of variance indicating the spread of the data. So we already have variance, so I can do the square root. I can say std deviation, standard deviation, equal to variance square root. So for that I'll say square of 0.5. This will give me standard deviation. Comma std underscore dev. Let's go ahead and print everything together. There you go. My standard deviation is 14.142133, whatever the rest of the values is. But those are the difference basic or measures of central tendency and dispersion that we have. Next, let's look at hypothesis testing. Now, what is hypothesis testing? It's a statistical method to determine whether a result is significant or occurred by chance. So the steps that we follow for this is, first we formulate the hypothesis. We have two different things here. One is null hypothesis and the other one is alternative hypothesis. Null hypothesis, you'll probably always see it as defined as h of 0, and alternative hypothesis is defined as h of a. Now null hypothesis assumes that no effect or difference is created, whereas alternative hypothesis assumes an effect or difference exists. Second step is to calculate the test statistic, which quantifies the difference. Next, we determine the p-value, which is the probability of observing data as extreme as the test statistics under null hypothesis. And finally, we interpret the results, where we check if the probability is less than alpha, which is a significance level, example 0.05, we reject the null hypothesis, which means it has some significance. Example for this can be the comparing mean test scores of two groups using a t-test. Next, let's look at the confidence intervals and statistical significance. Now, confidence interval, it's a range of values within which the true population parameter is expected to lie. The formula for this confidence interval is Ci equal to x bar plus or minus z times S divided by square root of n, where x bar is a sample mean, z is the z-score, example 1.96 for 95% confidence, and we have S, which is standard deviation, which we already learned how to do. If I want to do this in Python, let's go here and comment everything out. Let's go all the way to the top, and here I am going to import something from scipy dot stats as stats. So from the scipy, we got stats from there, which has all the different methods available for statistics. I'm going to say mean equal to mean, sample mean equal to mean. Next, I'm going to say z underscore score equal to 1.96. Now, where do we get this mean from? We got the mean from here. So I'm going to get this data right here. Okay, so we have our mean, we have a z-score, which is 95% confidence level. Now to calculate CI, we can say sample mean minus z underscore score times standard deviation, std underscore deviation, divided by length of data times 0.5. Now that we need most of this, looks like, so if we need the std deviation, that is coming from here. I'm going to take this, and for that I need variance, which is sum of x minus mean, and we already have mean, so I'm going to take that up here. So we have variance, sum of x minus mean, and I think I don't need to print this, need the standard deviation for this. Perfect. So I have that. So next thing that I need is comma, not here, comma, and I need sample mean plus z-score as per our formula that we saw times std dev divided by length of data square root, so 0. Square 0.5, so that should be perfect. So this will give me print 95% confidence interval is the CI level, so I'm gonna display that. Let's go ahead and run this. Confidence level is 17.60, 42.39. That's pretty good. So that's our 95% confidence level that we have. Next, let's talk about statistic significance. A result is statistically significant if the p-value is less than the significant level, which is alpha equal to 0.05. So now that we have completed some of the basics and some understanding about confidence intervals and statistic significance, let's look into hands-on exercises. Our first exercise is to calculate mean, variance, and standard deviation. So if you've already followed along, you can skip this, but the objective here is to compute the basic statistic measures for a data set. So I'm going to go ahead and use some shortcuts this time. I'm going to go back here, create a new file, save it as day6 underscore exercise1.py, and as I mentioned, I'm going to import numpy as np, and I'm going to have a data set. Let's call that data set as data equal to, I'll use the same data I used before, 10, 20, 30, 40, and 50, and then I will calculate the stats. First I'll do mean, then I will do variance, and then I will do standard deviation. So if you know the formulas, go ahead and write it and pause it here. If you don't, I am gonna do it here and follow along. Data, I can say np dot variance data. As I said, shortcut. It's easier to just write it instead of writing the formulas, because these are available through some of the modules that Python provides inside NumPy. So we have all the data available here. I am going to say print mean is mean. Next, I want to print the variance. Variance. Next, I want to print the standard deviation, which is std underscore dev. So I have these. So that's our exercise. Let's go ahead and run this. I'm going to clear this out and say Python day underscore ex1. Looks like I've missed the day 6 again. But here's my mean, variance, and standard deviation. Looks exactly same as what we got from using the complete formulas earlier, but now you have np.variance and or numpy to do all these things for you. Next, our second exercise is to perform a t-test. Now we'll perform a t-test to compare two sample data sets. So let's go ahead and first have those sample data sets. I'm going to save this, go next and save it as day6.ex2.py, use underscore, and from first I need scipy dot stats. From there I can import the t-test individual here, this one, and I need my sample data sets. For that I'll create two groups. One is group 1 with data of, let's give some random numbers, 2.1 comma 2.5 comma 2.8 comma 3.0 comma 3.2, and then I'll create a group 2 with data sets, that's 1.8 comma, I'll say 2.0, 2.4, 2.7, and give 2.9, some random numbers. Next, let's perform the t-test on this data sets. So for that I'll get t-stat and p-value from t-test underscore ind, where I can pass group 1 and pass group 2. So this is as straightforward as that. And here the t-stat is my t-statistics. So that is t statistics statistic, and that I can display by saying t underscore stat. Similarly, my p-value is this. You can print that out. Next, let's also do the interpretation, the statistical value for it. I'm going to say alpha, which was our, if you remember in the previous slide, we say statistical significance. If in statistical significance a result is statistically significant if the p-value is less than the significant level, which is alpha is 0.05. So let's go ahead and do that. I'm going to say alpha equal to 0.05. Now I'm going to check if p-value is less than alpha, which means I'll print saying reject the null hypothesis, which means it's significant difference. Else I will say print fail to reject the null hypothesis, which means no significant difference. Let's see, I've given some random numbers, so let's see how does this act. You can try out with different values. I'm going to say Python day6 underscore ex2.py, run it, and it says failed to reject the null hypothesis, no significant difference, because the p-value is 0.2, whereas so my p-value, which is 0.2, is less than 0.05, and that's why it failed to reject, or greater than that, that's why it failed to reject the null hypothesis, because there's no significant difference. So I hope it was helpful to understand whatever we learned to implement in the code. If you had any problems or issues, let me know and I'll get back to you. For additional practice, you can try to visualize the distribution of data and highlight mean, median, and mode using matplotlib. You can perform hypothesis testing on real-world data sets. Example, comparing exam scores of two groups. You can get these data from different websites, and you can calculate confidence intervals for proportions in a data sets. So just to summarize, today we learned statistical fundamentals focusing on central tendency, dispersion, hypothesis testing, and confidence intervals. By performing calculations and hypothesis testing, we gained hands-on experience with data analysis and decision-making techniques. And these are very important for some of the things that we'll be doing in the next few weeks. Day 7, math-driven mini project or linear regression from scratch is what we're going to do here. So there'll be 3 different things that we need to learn before even starting this. First is applying linear algebra, calculus, and statistics. So for linear algebra, linear regression aims to fit a line or hyperplane to minimize the error between predictions and actual values. The mathematical model for this is y cap equal to x times theta, where x is the feature matrix with bias term, theta is the parameters which are weights and bias, and y cap is the predicted values. For calculus, we need optimization of theta which involves minimizing the loss function. That is defined as j theta equal to 1 by 2m summation of I equal to 1 to m for y cap I minus yi squared. And also the gradient of j theta, which is del or nebula of j, equal to 1 raised to m, 1 upon m x raised to t x times theta minus y. Next, we also need statistics. Metrics like mean squared error, MSE, and R square are used to evaluate the model performance. So we're going to look at each one of them in more detail. So first is using gradient descent for parameter optimization. Now the gradient descent algorithm goes something like this, where it iteratively updates theta using theta equal to theta minus alpha times del of j, where alpha is the learning rate and that controls the step size. The key steps involve initializing the parameters using theta, then we have compute the gradients, which is del of j, and update parameters using the gradient descent rule. Finally, let's talk about evaluating the model using the statistics metrics that we mentioned. So we need mean square error, which is MSE, which is defined as 1 raised to 1 upon m summation of I equal to 1 to m y cap I minus yi squared, which measures the average squared error. And then we have R squared, which is R square equal to 1 minus SS res divided by SS tot, which measures how well the regression line explains the variance in the data. So let's go ahead and do our hands-on project based on whatever we have learned on linear regression from scratch. We'll be following 3 different tasks. Task 1 is to implement the mathematical formula for linear regression. Next, we'll use gradient descent to optimize the model parameters. And third task is to calculate the evaluation metrics. So for task 1, so let's go ahead and first create a project. I'm going to create a new file, save it in my day 7, and I'm going to call it mini project, which is linear regression from scratch. So first task, as I mentioned, task 1 is to implement the mathematical formula for linear regression. So the objective here is to create a function to compute the predictions. So let's go ahead and write some code for that. For that, I'll say import numpy as np. Of course, we're not going to do all the work here. We'll use some of the libraries that are available. And I will create a predict function which will take the x, which are our features, and the theta here, and we'll predict by returning np dot, and here I'll pass x and theta. So that will take care of predicting for me. So this will, that's all we need to do for task 1. Our task 2 is to use, let's see, use the gradient descent to optimize the model parameter. So use gradient descent to optimize the model parameters. So here the objective is to implement gradient descent to minimize the loss function. The example, so code can be written something like this, where I can say gradient descent, and it takes, as we've done before, x, y, theta, learning rate, and iterations that are required to get optimized solution. Now I'm going to say m equal to len of y, and I'm going to go through each and every iteration here. For underscore in range of iterations, I will go ahead and get the gradients first. Gradients equal to, from the formula that we saw, 1 divided by m times np dot x dot t. This is the summation thing that we did. Np dot, and to it I'll pass x and theta, and I'll put this entire thing inside a bracket, say minus, or right here, np dot minus y. Did I close all of them properly? No, one more. So yeah, that's my entire formula for that. Next I need theta minus equal to learning rate, so this will give me the optimized value, times gradient, and that's good, and that will return back finally the theta value. So I have that. And finally our task 3 is to I think, look at it, calculate evaluation metrics. So I am going to say calculate evaluation metrics. The objective here is to implement functions to calculate MSE, which is mean square error, and R square. So the code for that, I can just say mean underscore square underscore error, which will give me with true values y and y predicted values. So I can calculate the mean square error from there, and this will return np dot mean of y underscore true minus y underscore pred and square root of the square of 2. So that's what I'll get here. And next, for our r squared, I'm going to say define r squared y underscore true comma y underscore pred, and to create this I need ss res first, if you remember the formula from before, and this will be ss res equal to np dot sum y underscore true minus y underscore pred and squared. So that's what I'll get. Next I need ss underscore tot, which is np dot sum, and this I'll give the same values. Actually y underscore true it needs, but it will be np dot mean of y underscore true, and here I'll square it. That's the ss tot. Now to bring everything together, 1 minus ss underscore res divided by ss underscore dot. Give it a little space, and that was our formula, if you remember from here, 1 minus ss res upon ss dot. So that's the r squared. So that's perfect. Now to put all of them together, let's start from the top. I'm going to generate some synthetic data. Some synthetic data. np dot create a random seed, my favorite number 42, and x equal to 2 times np dot random dot rand 100 to 1. So I'll create some random values. Y equal to 4 plus 3 times x plus some bias np dot random dot rand n 100 comma 1. So there you go. So we have that value. Next I want to create add bias term to the feature matrix. Add bias term to feature matrix, and that I can do by creating a variable x underscore b equal to np dot c underscore, and here I'll say np dot ones 100 comma 1 comma x. So this will add bias term to our feature matrix of x. Next, let's go ahead and initialize the parameters that I need theta, I need learning rate, and I need iterations. Let's start with iterations. Let's do 1000 iterations. Learning rate, let's say 0.1, and for theta I will use np create a random one dot random dot randn and pass it 2 comma 1. So that initializes my parameters. Now next step is actually we need the predict function, so which we already have. We have the gradient descent, we have the mean squared and r square. So let's go below and perform the gradient descent. To do that, we've done it before in the previous videos. Theta optimized equal to, call this function that we have written, pass it x underscore b, pass y, pass theta, we'll pass the learning rate, and we pass the iterations. So that's what our function needs, the gradient descent needs, and that's what we have passed. So once we pass this, okay, I think there is some problem here. I called it iterations and iterations. So Visual Studio Code kind of shows you what issues you have before even you face any problems. So that's good. Next one, I'm going to do predictions and evaluations here. So to predict, I'll create ypred equal to, call the predict function, pass it x underscore b, and we'll pass the theta optimized. Next, MSE to get the mean square error. Since we have ypred now, I'm going to call the mean squared error, pass the original target values and the predicted values. There you go. Next, to get r square, I'm going to say r2 equal to r underscore squared, call that function that we wrote earlier, and pass it y underscore pred. Perfect. And next, now finally we can print all the three of these. I can say print, first one is optimized parameters, which is theta, is r theta optimized, which we get from line number 44 right here. Next, I want to print, let's see what is the mean square error, MSE, which I can get from MSE. Next, I want to print the r square, so I'll say r square, that is comma R2. So that will give me my R square error. So let's go back here, clear it out, and say Python mini project.py, run it. And there you go. We have our optimized parameters, which is as long as it's between 4 and 3, that's good. So 4.2 and 2.77. Our mean square error is roughly 0.80, and our R squared is 0.76, which is pretty good. So by completing this project, we have gained a thorough understanding of linear regression, gradient descent, and evaluation metrics. We also learned how to implement machine learning models from first principles using Python. So we did everything from scratch, which is pretty awesome. And I hope you were able to follow along. If you had any issues or any problems, let me know and I can help you out. If you have any suggestions or anything, let me know about them too, and I can add that to my videos. So I hope you were able to finish our week 4 with all the different projects that we have done. If you have any problems or any questions, let me know and I'll get back to you.